was since the beginning geometric with straight lines, lots of icons, minimalist, but always modern. The focus was clarity, simplicity, and rigor. You still use the same concepts, simple design that both inform and engage. As you can see, this is examples, current examples, and we use the same straight lines, icons, and well, now you use colors. In 1919, the newspaper was black and white, and the way of thinking is the same, but the tools and the way of making isn't the same. When I start working in public infographics teams, we didn't have the internet. It was before the internet's massification. And I don't know if you can imagine how could we did our job. I can't remember either. But something, the editors, journalists come to talk to us with a paper sheet, a photo, a fax, some notes with the data sketch. And if you want to make a map, for instance, we digitalize an enormous atlas page with the region we want and draw the map. Or we type the numbers one by one when we want to do a graphic. Can you imagine? But we just work with the small data sets. It's impossible work with the data sets like nowadays. Illustrator was the only tool we had at the time, but evolution of the work bring us other tools like MS Word, Excel, Photoshop, Acrobat, Flash, lately HTML and CSS, and now JavaScript for simple animations and interactions. So currently our attitude from the work is always learning. We must always be adaptive to the news tools, technologies, everything on the medium. We are 5, the current team, and we ages varying from 50 years old, me, till 19, Francisco, 3 women and 2 men. All of us has different backgrounds, but design is a common link. We have a strong team spirit, and all of us are enthusiasts about infographics. We work for 2 major strands in the newspaper. We do infographics pieces supporting the articles from a journalist to redactor, and we do autonomous infographics articles too, both for the platform statics and digital. Well, this is our work. This is what we do, visualizing information. And information is almost everything. Numbers are data, text is data, everything could be data, not only numbers. Our job is visualizing it and explaining it. The data or the information, the facts, the figures can arrive as in Excel, Word, maps, figures, well, lots of supports, lots of ways, and we must think about data we have in a way that makes it easy to read by our audience, and in a way they can understand and get insights from it. This is an example. This is an infographics for print support for paper, and was made from text dates, because the electoral process in the USA is very different from Portugal, and we felt the need to explain how it works. This is another example. This is created from numbers, and this is about the cases of COVID-19 worldwide. And here we work with the data sets, with the numbers, and with the cases from countries, and the contributions for the total. The main steps to work was 6 before the development, the infographic itself. And this is the 4 steps. It's very important keep this in mind because it helps our job. 1, we must first of all identify the type of data, because they can be everything. We must decide our visual goals, and it depends on the subject and the type of data, of course, and almost other things not so important. We must break the data into its most basic parts, its raw essence, and in this we must think in terms of the 5 Ws plus H. The 5 questions, journalist questions: what, where, who, why, when, and how. This is traditional. We must understand at the same time, we must add in our minds how visual information is perceived, and this is important. Remember Gestalt principles like color, shape, size, proximity, similarity, closure, because when we go think in visualize the elements, we must think with these principles. Then we put the pieces together in a logical narrative or a story. I know it's not quite same thing, but with elements, visual elements, sometimes very different per se. We logical narrative, it's more important, and they create a story. Sometimes we must know a little bit about subjects to create this logical narrative, or must learn about it. Then decide or choose the type of infographics, if we're gonna do something explanatory or exploratory, or mixed. Then the development itself, it's another work, another phase of work. Storytelling is our basic technique, is the best way, and that's what we use, and that's why I'm talking about storytelling, because the digital platform, it's almost everything in storytelling. That's why, because it's a design concept, very easy to use. This does not require much effort from the user, and give the user a sense of control, some kind of exploration and discoverability. Sorry about my English. In the mobile, we have the swipe mode. It's the equivalent, because it's natural. It's a natural gesture. It becomes with smartphones and the mouse with a scroll. It becomes natural for all of us. So storytelling is our natural support. This is how the work process should go. The 6 steps and after the development of final infographics, but this is how it happens most of the time, and it's the natural process. I want to show you some stuff we do, different examples. Maybe it could be a way of showing the different kinds of work we do, the different ways of visualizing the information. This is a small animation. Cod is widely consumed in our country, and this animation made a few years ago continues to be an excellent example of how information can also be fun, and this is information too. Another example from illustrated infographic or infographic illustrated. I don't know the order of the words. I think it's illustrated infographic. This is about the new school year, and in a year of pandemic. And here we use the storytelling and the illustration. Are you seeing my screen?
Yeah.
Yeah.
Perfect.
Okay. Another example, this in this case, I think this is a good example because we work here with images, photographs, and dates, and some text about biographic text about the pieces of art and about the painter, and it's a very good example as we made a timeline. How our material, our data can be everything. We do data visualization too, more recently, when we use only numbers, data sets. This is about the this is an infographic data visualization made by the numbers of abstentions during the legislative elections in Portugal, because this made us think about the scale of this problem. And we did this. It's data visualization, but with infographic thinking, because it's clean. It's not exploratory. It's more explanatory. So the reader can see the line and can see the sequences of the subjects, not see everything he wants. It's a choice, because here we choose the data we want to say, we want to show. Sometimes we do things different. Here, that's an infographics multimedia. Use very elements, different visual elements, video, text. It's all present. Small animations and infographics, iconography, photos, again video. And a small data set. When we can see the endangered of the species in Europe, the red squares show us a species extinct. More recently, we did just for the digital support to infographic species only for support. This is an example of a explanatory infographic about the masks and why they are useful. We did this before the mandatory use of the masks. And in this infographic piece, we teach how our readers can make a mask, a domestic mask, mask in at home. Presently isn't not advised, and we use illustration and the small animations too, and schemes and graphics and all the visual elements we could. We can for this. And finally, but not final, we did this last year, very good infographics, storytelling. All these are storytelling technique, but this was one of the most, one of the best works, projects we did.
Hi everyone, my name is Francisco, and I will talk about a little bit of this job. This job is about the fires that occurred in Australia in 2019, and start with a storytelling that show Australia geography, its major towns. So we can give the reader a little bit of knowledge of Australia geography and how it looks. After that, we show the forest area, and we use the area that scroll above the background to complement the information we see in background. So we are seeing in this case the forest area in Australia. So we use the text that passed above to compare this area with other countries and Portugal, to give our readers familiarity with our numbers, so we can compare the huge numbers we are talking about. So this first part, we choose to make a storytelling because allow us to add multiple layers to the infographic, so we can compare the forest area, and after that we show the burned area in 2019, so you can see how big was the fires and how affected the forest area in Australia, and so on. We keep comparing with our numbers in Portugal, that areas that burn in Portugal and other countries, to show how big these numbers are. Keep scrolling. We keep adding information. We show in this case we show the fires that occurred, and we use that visualization to keep a closer look about New South Wales. That was the most affected state in Australia, and we use the potential of this visualization to close in and see with more detail what's happened there. We compare the fires that occurred in this state with all Australian. This graphic you see best in the right side, and we show you showed the natural parks to see that the area that burn in black is the same with green parks. So all of the areas that burn are natural parks. After that, we stop the storytelling and talk about what has been lost so far. We show in simple graphs the human losses and the animals that are affected by the fires. Use here illustration to unify the style so you can more easily manipulate the graphic style to unify with all the work. And so on. We have a little graphics to show where the species are in percentage affected by the fire, which one is most affected. To complement this part, we use a little GIF to show how big the fire was, and this GIF show us the smoke that are rebirthed by the fires in 2009. We show that cross all over the Pacific Ocean through South America and so on. So to give more backgrounds to the reader, we decided to add some causes that probably, and we think that was the perfect cocktail to what happened. So we use iconography to show simple facts, simple things. We cross it with a scatter plot that shows the driest years. We see that the last 10 years are the driest and hottest years. Go on to give more information to the reader that about what happened, and give the reader the opportunity to understand why this happened and why the fires are so big. We put some, I think is 100 maps that show us these ones show us the annual temperature since
1910.
Yes, and 10 and until the 2019. We see the last 20 years are more yellow, so have more average annual temperature higher than both the other ones. And then we have the annual precipitation. You can see the last 3 years are specifically dry in the South Wales state. I think that's why this state was so affected, because the dry state has been passed by, and that in the final we choose to show a little island called Kangaroo Island, and use it to compare our Bernard area in this island to the district of Lisbon to see how big was the Bernard area in just in that little island, and that we are transpose, I think, to show before and after, and that's all.
So is it on? Okay.
Yes.
Hello everyone, my name is Elves from Público newspaper, Portugal. And first of all, I would want to thank Ricardo and Alipio for the invitation to be here. And let me start by saying that, as you may know, we are information designers by design. So our story with code starts in 2007 with Flash, Adobe Flash, and we kept growing till today. The work, the project I'm going to show you a little bit is this one with this area of code. This is HTML, the basic HTML file. And in 2007, we began with only two lines of code, and we've started to work with it. It kept itself simple, and in 2015, we had to evolve a little bit. So we started to work on CSS HTML. The standard basic file structure is basically this, and the goal here is to keep it simple, the most simple that we can. So if I looking back, this is the graphic I see with the last 5 years, taking a jump with the amount of code. Okay, now we are going to take our quick tour of all over Apollo 11 project, starting with the end. This is the print version. This was executed after we had all the material, all the data, all the photos, everything was available. So it is easier to think on paper after we have this all gathered. So it all began with the NASA infographic. This was the inspiration we needed. A poster, a big poster in a wall with all the key moments of the voyage. The organization was fantastic. So, and off we go. Looking up into the sky, the objects, the clothes, the haircuts were made in this illustration to get the reader that place in time. So let me share the web page. Just a second. Are you still seeing the window?
We are. Mhm.
Okay. Okay.
Yeah.
So here we are. Before we start our journey, some context is needed. So we have our scrolling area, and the context begins with some information. Notice that with the story that scrolls, we have the main animation on the left side of screen and the zoom and the timer on the right. The idea is to allow the reader to know exactly how, when, and where the step of the story is. Okay. This is the module of scale of the Apollo 11 module inside the Saturn V. Here we had the concern to not leaving the page, the animation that was occurring before. Okay. Okay. So here the clock starts at the right. The illusion of movement is created by the background movement. And here the animation takes the stage on the left. Sorry, on the left side. So the scroll keeps its focus on explaining what is happening in the main animation. And as it goes smaller and smaller, the animation starts to divide its attention with the right side. Here we have just added a small looped animation with the scrolling in the scrolling area. Okay, this gives us the opportunity to show in detail all the moves that Columbia made to assemble Apollo 11 at the time. And after 60 hours after, we are going to jump. It's a big step in time and space. Okay. Now, this locator is, as you noticed, to help us to locate us into space, not on Earth, but in space, in a part of the universe. So at this point, at the same time, the Apollo 11 turns. We have the turning around the path goes around the moon. A little bit more at this point. The photography becomes essential at this point. It's going to allow the reader to connect these small graphics, small elements that we want to show the connection to reality, as do video records ahead. Okay.
Down 2.5. Forward. Forward. Good. 40 feet down 2.5.
So these are simple graphics that help us and help the reader follow up, and the videos help to acknowledge the moment that it happens to. So here, the first step is, as you can see, fully documented with photos and videos. And a small GIF animation along with it. The next step, the eagle is going to divide itself, and to do so, every element must be drawn separately. If you go a step back, this is an element drawn separately with this. And one more time, remembering the scale of it, just to the reader, so the reader can acknowledge how small the space was inside the capsules. So 7 hours later, I don't know if you noticed, but the path between Earth and Moon faded away, and we began a new path the other way around. So here entangles again 7 hours of orbiting the Moon, entangles again the path. And the jet starts. So the illusion is once more given by the background, moving backwards this time. And we have here, as you can see, all the schemes introduced in the scrolled area. This is important to explain it. Didn't make sense anywhere else, since we have these areas dedicated. The heating process of the capsule. Okay, and we watered and we landed at the sea. The use of this area proved to be very useful to explain the right and left side, to complement the explanatory needing. So in the last part of the work, we give our readers enough material to explore and understand with the graphics used and made to the first part, when some of them were not used, and we gave them away in this part of the job. Some schemes, some of the suit, of the ship, how they slept. Everything was composed to understand and to try to understand what they lived on this voyage. The part and the step of the mooning, and again some videos that were made to explain this moment.
The Apollo 11 lunar module Eagle, flown by Neil Armstrong.
So that's it. The geography of the moon is the last of it, with the suits and how they worked and how they turned this everything possible.
Thank you. Thank you, Jose. Thank you, Celia, and also Francisco. What a journey, I will say, from the beginning of the first years to the current realm. And you do such an amazing job. It's incredible what you guys do. And I should say, for those who don't know, that this is done with a very short team of 4 to 5 elements. Jose Alves and Celia, they are not only infographics, but they are also journalists. We are a little bit ahead of schedule. Sorry, Pablo, who is going to be our next speaker, but we still have some time for 2 or 3 questions. I also have one question here, but the first one, to raise hand features, thanks Alipio directly from the University of Porto. Alipio is going to give to pose the question, and I will just would like to inform participants that if they want to participate in this discussion or doing some questions, please raise a hand feature, okay? Alipio.
Hi. So I was checking if anyone else would like to go first, but apparently there's no raised hand from another participant. So first of all, thank you to the Publico team for the great presentations. It's a great work. Congratulations on your awards and on your results. I'm a Publico reader, and I enjoy particularly your work. So not only your presentations, but your work frequently. Actually, I'm a Publico subscriber, so it's more than a reader. I have 2 questions. I'm curious. I'm always curious when I see your work. As a computer scientist and someone working with artificial intelligence and automation, and so how much of your work is automated? What is your construction process? Do you do everything by hand? You choose every single icon, you choose every single position and piece of text. So you mentioned coding, but how is the process done? So that's one my first question. And the second question, which is not from my area, but I'm also interested in automating that kind of thing, is how do you make the graphical image of these icons homogeneous? So do you have any kind of program that does that? So you input a photograph and it appears, like you were showing the examples of the animals in Australia with the koalas and the kangaroos. Do you have a library of icons with the same graphical library image, or do you have some kind of adapter that makes everything with similar graphical style?
I don't know if Celia, you want to answer that?
I don't know if the question is for me or for Zé, because the part of illustration is for Zé. But about the automation, I can say it's everything human. nothing is automatic. It's everything human. It's everything from the human minds. We think all the process we choose and draw the icons, the illustrations, the steps. We read the data, all human. Nothing is automatic. Yes.
I should say too that in the codes we have to keep it simple. We have to think ahead, so we can do that part where in 2015-18 we did the standard file that was on purpose, so we could all use the same file to grow. It's the starting point of every work. So yeah, that's a little bit like that. We try to do a little bit more tomorrow than we did yesterday, so it grows and almost grows itself. The illustrations are made all with the style, specific style, you can say. This one of the moon has one style. There are others that are more alike. We draw like we feel, and just how we feel. And sometimes we draw simplest drawings, so we can produce more in less time. Okay, just a little bit like that.
Thank you.
Celia, you mentioned one very important aspect of type of data that we also work with, that slide that breaks data into pieces.
Yeah.
We also work with the 5 W's, the what, the where,
Okay.
who, the why,
Yeah.
and when. But it is curiously because we do it on the automatic perspective. We try to understand more deeply the text through computational techniques. And one thing interesting here to discuss, but on the perspective of journalists, is if you will face this automated process as a risk or as a gift to help you in the task of interpreting data, because you guys showed so many interesting things. You also showed a timeline where the problem is not only to select the most important text, but also the most important dates, or even these last infographics explored by José about related with Apollo. So I'm not properly thinking on doing this infographic process automatically, but on the previous steps, which will help you as a journalist to have a pre-selection of the most important text, of the most important dates. But some journalists that we talk to, some of them, they react saying that they are still not comfortable with that. So my question here is that as a journalist, you face it as a risk or as a gift to your work. This question is for Celia and for José and Francisco, and also Sonia. If you want to join us, you can also join us. I'm looking here.
I think Celia
got frozen. Yeah.
But in my perspective, if I can join the question, this is a moment that moment we feel that this kind of work you do with intelligence, artificial intelligence, is essential so we can be more with other ways or other thinkings and other step to do, so we can always adapt and adjust to everything new you can do in this area.
And you are open to this kind of collaborations that came from the academia.
For sure.
Yes. Great. Adam, before I'll pass you the opportunity to do one question, I would like also to invite Sergio Nunes, who also raised his hand. So Sergio also works with us, and he was also part on the first edition of the organization of the first edition of the workshop. Sergio, are you there?
Yes. And then, can you hear me? Yes.
Yeah, perfect.
Okay, thank you, Ricardo, and congratulations to the speakers. Very interesting work. My question is on another interest of mine is the digital preservation of things, of digital things, and contrary to printed infographics that once printed they stay forever there. Digital infographics need to be maintained. My question is how much of your daily work is on maintaining those past infographics, keeping them alive, or you don't do that? How is that process and Publico's process regarding the preservation of those digital artifacts, like that Apollo that we saw? Thank you.
Are you asking for me or Zé or Francisco? Okay.
The three of you.
The three of us. Okay. Well, sometimes we used archived works because that's work, and we used them. But another times we make it all from the beginning, another new ones. In this case, was totally new, the Space 1969. I don't know if I answered your question.
Not quite. My question was about, for instance, the fact that infographics, digital infographics, degrade themselves in the sense that browsers are updated, technologies change, and things stop working. How can we preserve?
Stop working, like Flash. For instance,
like Flash, yes. that ended last year. So
yes.
how can we keep things working? What is Publico doing for that kind of digital preservation?
The IT, not us. The IT sometimes build. I think they can answer better this, but I think the IT builds interface some kind of way for utilize or. The old infographics digital, like Flash and others, but every time we change the site, we lose something. Every time. But Zé, can you say better than this?
That's just it. I'm glad Sonia is with us, but because I have some complaints to do. No, it's really that simple. The site evolves, and there are new scripts, new classes, new IDs, new everything. So you can realize how deeply sorry we are after all this work we do be somehow lost in translation.
Complete a little bit. Digital is always changing, so we are always looking for oldest works to see if they are affected by them. By these changes. So times to times we need to
go back
some things, but in most works we use scripts or other code locally. So if change, also it's maintained the same. So no, don't change with the host. I think it's mostly that.
That's an interesting question from Sergio. It will probably benefit if we added previously to the discussion Daniel Gomes from the arquivo.pt, because he struggles with that to preserve the information that gets outdated as time goes by. talking about time, we are 20 minutes ahead of schedule. Our break will then be short in a couple of minutes, if we have a break, because probably we cannot. I will just give the opportunity for Adam to make his question. Please, Adam.
Yes, thank you for presentation. I just wanted to ask if you get any feedback from users, and how do you get a feedback? Because you stay in your team and you may think something is understandable by readers, but something may not. So is there any interaction with readers, and how you do that?
Celia.
Lots of interactions. We have our names in the infographics, and the readers can send us an email automatically, just clicking. And we received lots of notes and critiques and corrections and applauses too from our readers. Yes, it's a very pleasant. Even if they critique, it's good for us.
So if I may ask, what is the most problematic issue? What people complain about usually?
It's about statistics way of seeing the sometimes when we adapt the visual elements to a broader public, readers, all kind of readers, and some readers more specific, more exigent from statistics or scientific subjects, critique us about the scales, or if we aren't using the scales, but we didn't cut the scales, we just hide them sometimes, and other things like that. And we must explain our choice to that readers, because it depends, and our readers are vast. We must adapt our content to all of the people who read us, and not just for the scientists or for the academics, for all of us.
You know that with the COVID-19 stuff, we are all statistical doctors nowadays, so we all can criticize, and we all see at the time different things, and they share that with us, fortunately.
Yeah, the way you use these infographics, it's also a new matter of discussion that you didn't have the opportunity to tackle, which is you use these to engage new kinds of our audience, and new appealing forums to get new users. We also know from the news that you have been very successful during the last year by doubling the figures, by doubling the numbers of subscribers into your journal. Should also now welcome for 30 seconds the other organizer, Sumit Bhatia, who has also changed his background to an Apollo image. And
okay.
also Sonia's, sorry that we won't have sorry that we won't have time for extending this discussion. Again, it was our pleasure. We feel very honored to have you here on board, and to have the opportunity to discuss this important thematic with you guys. Thanks for the opportunity.
So, I want to talk about a model of interpretation of embedded stories. But before I do that, I want to thank the organizers for having me here. And very especially, I want to thank them for keeping this event going for so many years. I think it's very important that we have this kind of event and narrative. And there are really no others like it. So thank you very much. Okay, so the reason why I started working on this interpretation of embedded stories comes from is an outcome of a long time working on story generation. So for 20 years, I've been building programs that create stories. And the sad truth is that the stories that come out are usually very disappointing. I've tried using different algorithms for this from many different areas of AI, and still they don't work really well. So at some point, I started thinking maybe the problem was not in the algorithms, but in the representation I was using for narratives. And to test this, I decided to try and transcribe some stories that I thought were good into the representation that I was using. And it immediately became apparent that the representations were falling short of what the stories hold in them. Because good stories are not flat. We have this impression that the stories are a sequence of discourse, and indeed they are in the form that we get them. But when we interpret them, our mind is building a much more complex representation. And unless you have a computational representation that can sort of at least mirror the important aspects, this is not going to work, especially in terms of generation. You still get a flat discourse, but that flat discourse that you're getting, it doesn't show the complexity of the narrative in the way that human written stories do. So I identified the problem as having a representation that can deal with embedding. Now, in this presentation, I'm going to try to keep everything at the intuitive level, and I'm going to talk about the intuitions and the stories and not really go into the definitions. You can find the definitions and the references to official narratological literature in the paper. But here, I just want to keep it simple. So imagine I'm telling you a story about these two characters, and as the story goes on, one of the characters starts telling a story to the other. Now, this second story is inside the story I was telling you, and it's an embedded story. And in this context, the story I was telling you becomes the frame story for the embedded story. Of course, this can go on recursively because the characters inside the embedded story might themselves start telling a story, and so on. So this is the kind of structure that needs to be represented. And this process of shifting one level in, it needs to be addressed computationally as well. So having said that, this is a small summary of what I want to tell you. I'll go a little deeper into the idea of embedded stories, but again, using an example, not that much theory. Then I'll describe the little model that I have built, which is indeed the first approximation, but I think it holds the basics that need to be addressed by any later, more elaborate models. And then I'll discuss how these insights that arise from this can be seen and what they say about particular examples. And then I'll just review some takeaway messages. Okay, so to think about embedded stories, I picked a very classic work that is the essence of embedding in literature, which is the Arabian Nights, which, as you know, is one very long story that has a lot of little stories inside. So if you actually look at this, we all know the story. I'll be going through the actual text, but I've extracted the bits that seem relevant, and I'm superimposing on these colored frames that represent the different narrative levels. So this is the blue frame, is the general frame story of the whole book, and as you move down, basically this is you all know the story, but just to make for completeness, this is an instance of the overcoming the monster classic plot, where the monster is this king that every night takes to bed a virgin girl and then kills her in the morning, has her killed in the morning. And the hero is Scheherazade, who happens to be able to tell very interesting stories. So Scheherazade convinces her father that to let her take on this king, and to set the tone for the book, the father, who's of course very worried, tries to convince her that this is not a good idea, and he does this by telling her a story. And then you can see the first embedded story appearing here. This green frame is the story that the father is telling. The story finishes, but doesn't achieve its purpose. So Scheherazade decides to go and meet the king, but she is not going in blind. She agrees with her little sister to show up at some point and basically let know the king that Scheherazade tells very interesting stories. So the king says, "Oh yes, please tell me a story," and she does. So we get a second frame at this first level, which is the tale, the story that Scheherazade is going to tell on the first night. Now she's very smart, so just in case one story not being enough, she inside the story starts a second story, which guarantees that when the morning comes, she has not one but two stories unfinished. And this creates a lot of tension, and indeed the king is fooled by this and decides to not kill her that morning and wait until the next evening so she can finish the story, which is basically the key of the key narrative mechanism of the book, which allows her to tell lots of stories. Okay, so this is a small representation of the structure of nesting that we're getting in that small fragment. The book is several volumes and has a lot of stories. I don't really know if they're actually 1001, but there's probably more because of these embeddings that some of the nights, the stories that are told have stories in them. And it actually goes quite deep sometimes. Anyway, so you get here the concepts of embedded story and the frame story. Embedded story is the one that's put inside another story, and the frame story is the one that where the embedded story is inserted. So with these terms, I can now start describing the model. And the model, when I sat down to do this, I came up with a number of challenges that need to be faced by any model trying to solve this problem. The first one is actually having to identify from the discourse of a story, which, as we were saying, is flat, it's just a sequence of statements. You need to be able to identify where an embedded story is starting, and this is not trivial. Then you need a representation of the story that shows this kind of level that we've just seen, this kind of nesting structure of boxes inside boxes, so that a simple story is just one box, but any story with more than one level has several boxes, some inside the others. And finally, we need some dynamic description of how we go from a linear sequence, that is the discourse, to this nested structure. Now, as I said before, I'm really more interested in the representation of narrative, because what I really want to achieve is good generation of good stories. So the actual interpretation of the text is not of much interest to me, so I've cheated a little. What I've done is it's a bit like those cookery programs. So I'm starting with a solution that is partly there. Here's one that I prepared earlier. So I get, I'm using stories that are not really text, but represented as a sequence of predicate argument structures. So they are a sequence and they are similar to the real discourse in the sense that this is a linear sequence that we're getting, but I don't need to deal with parsing the actual text. To actually ensure that this contains the information that I need, I've added to the notation some devices to mark the beginning of an embedded story and the end as well. And then over this, I can address the issues of what data structures would be needed to represent this interpretation and what are the computational implications of these elements in terms of the procedure that we would need to for the interpretation process. So, as I say, I've sort of sidelined the issue of identifying the embedded stories from the text. If you go back and look at the example of the Arabian Nights that I showed in the slides, I have tried to underline in black some of the elements in the text that I consider to be relevant cues for identifying the structure. But a lot of what needs to be done involves complex inference about who's talking and which of the previous levels the characters talking belong to. So for the discourse, this is the representation language I'm using for the input. This is a linear sequence of statements. These were basically, as I said at the beginning, these are the representation language I was using to represent the output of the generators, with a few additions to represent the complexity. So this is an example of an embedded story occurring within a longer discourse, and you can see it has this specific statement for the start of the story. Then it is followed by the sequence of statements that actually describe the embedded story, and also a final predicate which acts as a marker for the end of the embedded story, but also doubles up as the representation of the insertion point of the embedded story into the frame story. This is where in the frame story we are told that someone is telling a story, and it also has who's telling the story and who's listening to the story, or who's being addressed. And both of these statements are linked together by the name of the story, which comes as an argument and acts as a unique identifier for the story. So this is the setup. This is what would have to be obtained from the text to be at the point where we can now apply the interpretation procedure and the representation procedure that we need. And the representation we want to achieve, I'm going right down to the Java code because I thought that was the most informative way of describing this. This is the implementation of a narrative interpretation for a story. It has a story name, which corresponds to the one we've seen appearing as argument. It has a representation of the linear sequence of statements that describes the story at this level, the narrative at this level, but it also has this data structure which holds a set of embedded stories, or may hold. This may be empty, of course. If the story is simple, this is empty, but if there's an embedded story, it will be stored here. And it's the way these are stored here is as narrative interpretations themselves. So this is where the recursion comes in. And there may be several, as we've seen in the example of the Arabian Nights. So each one needs to be indexed, and the index, this string appearing here as index for this map, is what actually links the embedded stories that are held in the map with the point where they appear in the discourse of the frame story. So, and again, an example here on the left, we have the discourse, and which is flat, but on the right we have the interpretation, and this has the frame story, and which for the actual frame story is still a sequence of events describing what's happening, but some of these events actually include a reference to an embedded story, which is itself a different instance of narrative interpretation that gets stored in the map. I've tried to replicate the sequence of colors for the progressively embedded stories all throughout, so in case this helps to understand the intuitions behind it. Okay, so in terms of the procedure, and this is where it gets a little complex, but this is like the pseudocode for the algorithm I'm proposing. And what happens is when you start interpreting a story, you initialize both a draft for the story itself, which is this narrative interpretation, which has the map of additional narrative interpretations inside it, and both are empty. And there's a stack which is used to keep track of context. As you progress through the discourse for the frame story, you're basically adding the statements describing the events in the interpretation. But when you and this sort of grows progressively, and if it's a simple story, this is all that will happen. But if you find a start of story, then the interpretation to this point is shifted to the stack, and you create a new empty one, because you need a new context to interpret the embedded story. And then you go on, and basically you have now moved into the part of the flat discourse that refers to the embedded story. So you process that, and you're now adding it in the same way, but to the interpretation for the embedded story, until you get to the point where you reach the end of the story. And at that point, a number of things need to happen, which is you need to recover the context of interpretation. Was the frame story. You need to store the interpretation you now have of the embedded story inside the interpretation for the frame story. And finally, you need to add a statement to the frame story that says X tells the story to Y, and the story which has a pointer to the interpretation of the embedded story that you now have in your map of embedded stories. So this is what happens. And I wanted to show you this happening over real examples, but of course, to do this, I needed to have representations of the stories in the kind of notation that I have used. And I only had those for two different domains. One is the Russian folk tales described in Vladimir Prop's Morphology of the Folktale, which I had been using as inspiring set for some of my generators. And for one of those, this is a longer story, but I've picked out one of the narrative threads within that, which is again an instance of overcoming the monster plot, where you get the hero, which in this case is brother 2, and someone tells him, and it doesn't say who in the story, that's why there's an X. This is the general frame of the story. Someone tells the hero that the princess has been kidnapped. The hero decides to react, goes fight the dragon, but is wounded in the process. So the princess is rescued, but the hero cannot show up to claim credit. So someone else does. I save the princess by telling a false story. And what happens is when the hero recovers and appears, exposes this false hero in Prop's terminology, and basically by letting everyone discover the real story. So the interesting thing here is first that even for very simple stories like these, there are embedded stories. But not only that, the embedded stories that appear here are quite important for the plot. They actually drive the plot. They actually determine the shape of the whole plot. And that was relevant for me. It's also true that some of them are not necessarily true. Some of them are actually false and actually contradictory versions of the same set of events. Another important point here is that some of these stories are actually retellings of fragments of what has happened before. And that is important for some of the things I will say later in the discussion. Okay, so this did work, and it showed some interesting results for the Russian folktales. But I wanted to make sure that it was also relevant in a more general sense. And I did have another potential source to use as input, because I'm currently working in this project, which is about 18th century Italian opera, and working together with musicologists and us, and is trying to study the music and the narrative of these operas. So these are opera seria, and the one I'm showing you, which is one I had for which I had the encoding, is Artaserse, which is about a Persian king, and this is a sketch of only the beginning of the first act, because it is a much longer discourse. So you can see the frame story, and this is the whole the story is basically the key to the story is a conspiracy to exterminate the ruling royal family and place a different person on the throne. And the villain is Artabano, and he wants to place his own son Arbace in the throne. So the story starts with Artabano meeting Arbace, and actually Artabano tells Arbace that he's just killed the king. Which shocks the man, and he leaves. But then Artaban actually tells the audience in this sort of trick used by this kind of opera, tells the audience about his plan, which is to kill everybody in the royal family and make sure his son gets to be king. To achieve this, he goes to the Artaserse, who was the son of the eldest son of the king, and tells him that Dario, who is his younger brother, actually killed their father, and the story gets spread. So this is someone else telling the same story to other people, and this actually leads to Dario being executed for supposedly having killed his father. And then the plot begins to thicken, because someone considers that maybe it wasn't Dario who killed the king, and so on. And that's how the story goes on. There's two things that I found interesting here. One is, again, that there are embedded stories here. They are very relevant to the plot. In fact, they actually play a very important role in the story or in the play, because although it's a very clear, very violent story, no violence actually takes place on stage. Whenever there's violence, it happens somewhere else, and someone comes in and describes it by telling a story. There's another element that I found very interesting here, which is that if you actually superimpose on this view of the first act, the scene changes whenever people actually leave or come in. It appears that in almost every scene, there's someone who tells a story. So apparently the scenes are all about someone telling story to someone else. And I found that pretty interesting. So moving on to the discussion, and I think there's a number of obvious limitations to this model as it stands, being, as I said, only a first approximation. The first one is that it assumes that the embedded stories are always told as a single span. As I showed you, the way to represent embedded stories in the discourse only allows for a start story marker and an end of story marker. So you can't stop them halfway and then open them up again, which is something that obviously happens a lot in real stories. In fact, you can see in Arabian Night, that's the way every story works, because they are all told in 2 nights, and in between, Scheherazade at dawn stops the story without having finished, and then we have a little something that describes how that this has happened and how the day passes, and then the story is retaken. So this needs to be added to the model in some way. Another limitation is that when I was working on these, I was working from synopsis of the plots rather than full text. So, and this means that sometimes this obscures the issue of narrative distance. So we don't really know. We know that someone is learning about a story, but we don't actually know whether it is someone else actually telling them the story, or whether they discover from something else that they have learned, and that again would need to be looked into more carefully. But it links in with another issue, which is the current version assumes that all the stories, whether they are the framing story or the embedded story, are told in chronological order. And we know that real stories as told by people don't usually do that, or not necessarily do that, because we have flashbacks and flash forwards, or things that are told in interesting orders. Now, of course, that is a separate problem that would also need to be addressed. This is just a simple model for this problem, and there are many others related to narrative that would have to come together into a more elaborate version. But the interesting thing, as we have seen in the examples, sometimes these kind of flashback or references to something that happened before, someone like the hero, the real story of the hero being told at the end to unmask and expose the false hero, they actually references to something that happened in the text earlier. So in a sense, they are a flashback. So this same framework might actually be useful to represent anachrony as part of a more complex system. And finally, in terms of conclusions, I want to say the main conclusion here is not, hey, problem solved. Rather, it's this is an important open problem that still needs a lot of work. However, I can say that the model that I have proposed, it does provide a computational framework that captures the nested structure, and it uses a stack to represent the way in which the context for interpretation of each narrative level can be recovered in the right order as we come back from the nesting. And it allows for representing the embedded stories as part of the interpretation of the frame story, but not at the same level of discourse, rather as a specific embedded structure that also allows for more than one embedded story to happen, and it can be embedded recursively. Please keep in mind that this is just the first approximation. I'm not claiming that this is the solution, just that the solution, when it comes, and it will be much more complex, has to look something like this. In that sense, there's obviously a lot of further work to do, especially and very relevant to this workshop. We need to consider how to get from the text to the kind of input discourse that I am using, in which the embedded stories are explicitly marked with a start and end, and that is not trivial at all, as it involves a lot of inference. And I mean, in the Arabian Nights, there are very clear cases where the stories are labeled. They have a big title, and someone says, "I'm now going to tell you a story, the story of the ass and the bull," or whatever. But that's not always so easy. It's not always typographically marked. And in some cases, in the paper, I do consider the case of The Heart of Darkness by Joseph Conrad, which is a different, again, a different genre and a longer novel, where the there is also an embedded story, but the frame story is very, very short, and it just acts as a literary device to introduce the main story, which is embedded within it. And it's actually very, very tricky in that one to identify the transition points between one and the other, and what is a comment to the embedded story from the frame story, and what is actually just additions to the embedded story. And I think that's it. Thank you very much.
Thanks, Pablo. Very interesting, and I must say, a very challenging area, right? You have identified a lot of interesting problems, right? Interesting and challenging, right? I was actually, when I was reading your paper and listening to the talk, I was thinking about, how do you incorporate non-linear story structures, or, novels or stories with multiple subplots. But as you acknowledge, right, some of these things are probably open-ended at this point, right?
Yes, it's as I say, it's narrative in general is a very complex phenomenon, and it involves a lot of different possibilities. Not necessarily every narrative has them all, but the possibilities are there. They could indeed all be combined into one. But the truth is, any interpretation procedure for narrative that wants to claim any kind of generality should be capable of in some way handling each of these possibilities, even if they never all happen at the same time.
Right. So I do see Alipio has a question.
Yes.
So, yeah.
Thank you. Hello, Pablo. Nice to see you again. Great to have you here. I really enjoyed your presentation and your work. It's very challenging, as you said, and it makes us think. So I have some questions. One is that in our project, we are trying to extract narrative elements from text, and we use DRS, discourse representation structure, a kind of first-order logic representation to represent these elements. So your proposal, does it encompass some kind of representation structure that could be a competitor of DRS, or is it something at a different level?
You could definitely, I mean, in the framework that I'm proposing, there's this element I've shown you in the Java class. It's a class that is a fabula, and the fabula might indeed be represented in the form of a DRS. Now, the problem is these kind of start of story marker and end of story marker that do not occur in DRS. You might introduce specific predicates, but the problem to represent these, but the problem is that if you do, they would need to actually, I mean, they're not just representational, they actually procedural. They involve shifting stuff around in this nested structure. So I think you could extend a DRS representation to have this kind of thing. Indeed, you do need, I mean, I'm trying to work with the simplest possible notation that might work for what I need, but of course, a DRS representation in place of these small predicate with textual arguments would be much more expressive, and it would be interesting to consider the interaction between the two.
Okay. Thank you. So if I can ask another question.
Sure.
So thank you for the answer. I think that's a challenging aspect, the procedural part of it. And it's a challenge for us to include these embedded narratives, which is something that we felt also in the type of text that we work with, which is mostly news. It's common, of course, not in this spectacular sense that you have in the 1001 Nights, but in a news text, you can have say that this politician appeared and he referred to this attack that happened in Afghanistan, and so this is actually a story embedded in the story. So, and the news text quite often has this. So one thing that we did was to select news so that they had a flat narrative flow, as you mentioned. So we were avoiding this kind of embedded stories deliberately because they were more challenging. So have you considered these different examples, not from tales, but from news texts? And do you think they can they fit in your framework?
Yes, yes. I tried as I was looking, as I said, I tried to broaden the scope to make sure that the framework could generalize in some way. And I did look into news stories. Now, news stories, I find them very challenging because they have this convention by which they don't necessarily explain things in a chronological order, but sort of in an order of importance. So you get things, basically all the events in your story show up jumbled up. So again, I tried to avoid that in a similar way. I can sympathize with what you're saying. But indeed, if you consider any kind of sort of courtroom procedure or detective story or anything where you're trying to have two people presenting opposing arguments and you're trying to identify which one was the one that did happen, which might be politicians or your typical story about so-and-so claims that this, but we have looked into the facts and we're questioning that. They involve opposing stories in the same way, in a similar way to what I was showing. So they would indeed have this kind of embedded story, and you would have different contrasting, competing stories that appear as embedded stories of the actual news article. And you will also have to, in the thread for the main article, you will have to refer to these contrasting stories as elements about which the main article is making judgments. So this is, if you want, a step above that, which is not only telling stories as part of what you are saying in the article, but then saying things about the stories that you have told. Which again adds an extra level. That's fine as long as you use these sort of unique IDs to refer to the story, but it's still a challenge that would need to be considered carefully.
Okay, thank you.
All right, so I think we are way past the scheduled time. So I think, Ricardo, will you be having the coffee break or not?
We've discussed that with Adam, given we are in an online format, we may only ask people to do their break at their pace.
Right.
That we'll appreciate, and we can then stick to the schedule. Pablo, I should only apologize for saying that you were streaming from Barcelona. What a mistake of myself. Great talk, and also thanks Sumit for sharing the session. I will now ask Adam to share the next session. Adam, are you there? Pablo, once again, thanks for coming by. Okay, and for your efforts in doing this interesting presentation and in contributing in such a great way to the community. Thank you.
Thank you very much.
Yes, thank you. So I will take it from there. I apologize for not having a break. I'm sorry for that. And we have two papers now in the next session. The first one is Nectar of Missing Position Prediction for Story Completion, and will be presented by Yusuke Mori, talking from Tokyo. I hope he's here. Yusuke, if you can share your screen. Are you there?
Thanks, I'm here. Can you hear me? Great. We can hear you, but I don't see yet your slides.
Okay, I'll share it. Sorry. The sharing options is
Should
the advanced sharing option is now shown. Can I share it?
It should be a red button at the bottom. Share screen. Can you see that?
Yeah, share screen. Oh, okay. I can. Then...
Yeah, we can already see. Just a presenter mode.
Yeah. Now, which mode can you see? Presenter mode or slides?
So sorry, we also see the text to be read.
Okay.
I think you need. Yeah, now it's good.
Okay. Okay.
Please go ahead. Thank you.
May I start?
Okay. Yes, please start.
Okay. Thank you for the introduction. I'd like to show my appreciation for organizers to allow me to be here and give me the opportunity to present our work in this amazing workshop and community. Okay, oh, sorry, a timer set, okay. Now let me start my presentation. Hello, everyone. My name is Yusuke Mori, a PhD student at the University of Tokyo, Japan. Today, let me introduce our paper, The Nectar of Missing Position Prediction for Story Completion. This is a joint work with Hiroaki Yamane, Yusuke Mukta, and Tatsuya Harada. And this is the overview of this presentation. For those who will watch this presentation later, I'd like to explain what the Nectar paper is. Nectar paper is a paper with a summary of own work published in other conferences or journals that the author, in this case me, us, believe worthwhile sharing with the Text2Story community. It is expected to emphasize how it can be applied for narrative extraction, processing, or storytelling. This paper, titled as The Nectar of Missing Position Prediction for Story Completion, is a summary of our previous work, finding and generating a missing part for story completion. The previous paper was proposed in the 4th Joint Thinking Workshop on Computational Linguistics for Cultural Heritage, Social Sciences, Humanities, and Literature, which was co-held with CORE in 2020. There are 3 main contributions in the summarized paper. First, we proposed missing position prediction task. Second, we proposed a novel method for this task. Third, we conducted an experiment on combined tasks of story completion and missing position prediction. And in this Nectar paper, here is the main contributions of this Nectar paper. We summarize the 2 of the 3 main points of the previous paper. We explain our proposed missing position prediction, or MPP. This is a task to predict the position of a missing part of an incomplete story. We believe MPP has essential meaning in the context of story understanding, story generation, and creative writing assistance. Then we explain our method for MPP, and our analysis shows that highly accurate predictions can be obtained when the missing part is the beginning or the ending of the story. Then, not only summarize the previous paper as a Nectar paper, we add more insights and discussions based on the results we got the proposed method. Move on to the background of the research. The background of our study is story understanding and story generation. Nowadays, as you know, thanks to the internet, anybody can freely publish their original stories. However, writing a story is not an easy task. To write a good story, we should first consider what a good story is. If we don't know about it, we can't evaluate whether the written or generated story is good or not. On the contrary, I'd like to note that writing a story or generating a story makes us understand more about the secret of creating a story. We believe that we cannot divide understanding and the generation of stories. Moreover, our motivation is also on the creative support for human writers. In other words, our aim is human story writing assistance. As I have said in the previous page, writing a story is not an easy task. Story writers have various problems during their works. For example, they sometimes cannot complete their works. When it finally comes to publication, that doesn't make it will sell well. Writers are sometimes part-time writers. For them, they should find a good balance with their other works. Research to mimic human creativity has been for a long time, as far as we know, since the 1970s. Recent progress in natural language processing and computational linguistics makes it feasible to support human creative endeavors. To assist people in creating stories, we believe it is essential to train computers to understand and create stories. This is a creative process, for example, but we should know that how to create a story is different for media, genre, and even for each creator. Please note that the figure in this slide is just an example. First, a writer decides which genre to write. For example, mystery, science fiction, romance novels, and so on. Then the writer makes a proposal. If he or her is a professional writer, he or she may show this proposal to editors to get advice. In proposals, the writer considers what is the theme of the story, what kind of stories are sell well in the genre, who are the expected readers, who are the protagonists and antagonists, etc. Then plot is created based on the settings. Now the writer writes a story based on the plot, but sometimes writers should go back to the previous step and start over to make their works better. Our paper aims to support these steps, plot and writing the story. Now go to the related work. Before explaining our new task, let's revisit the existing story completion task. 1.1 proposed story completion, or SC, task in the field of story understanding and generation. As you can see in the left figure, given 4 sentences of a 5-sentence story, 1 sentence is lost, and where the loss is known. The objective of the task is to generate the missing sentence underlined. In this case, the 4th sentence is lost, and the objective is to generate the her teacher stated or blah, 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 here. Here, I'd like to go back in time to see how the story completion task came about. Cross-test in 1950s is a well-known assessment for readability. Some words are lost from a text, and the test takers fill them. A cross-test applied for story and narratives. Narrative cross-test is a well-known application of the cross-test to stories. Then story cross-test is proposed as a more difficult task. From an original 5-sentence story, the last sentence is excluded. The first to 4th sentence remains presented, and the objective is to select an appropriate sentence from 2 options that complement the missing last sentence. As our story is for story understanding and story generation, here we introduce 2 tasks of story generation, 2 subtasks of story generation inspired by story cross-test. In other words, cross-tasks that generate rather than select. There are 2 tasks, story ending generation and story completion. Here is a challenge we tackled. There are some tasks of completing incomplete stories, as I showed in the previous page. Story ending generation and story completion. In story ending generation, the last sentence is lost and it is known. In story completion, the case sentence is lost and the K is given. Previous sentence level story cross tasks require user to have prior knowledge of the missing parts. The case where the missing part is not known was this is what we concerned. And our missing portion prediction aims to fill this gap. Our objective is finding a missing part in the flow of a story to complete an incomplete story. This is essential for story understanding, story generation, and creative support for human writers. As I have said, there are 3 main contributions in the previous paper, and there are 2 of our main contributions of this next paper. There are 2 of the 3 major points of the previous paper is summarized. Our proposition of missing portion prediction and our novel method for missing portion prediction and further analysis. This is a story completion, the same slide I have shown. And this is our proposal, missing portion prediction. In existing story completion task, the position of a missing part is given. This is thought as a priori knowledge. However, this is not always the case, we believe. Our task fills this gap. Our new task aims to predict the missing position before that. Please have a look at the figure in the left. In the story completion, where the missing is known, underlined, but in some cases, where the missing is not known. Our missing portion prediction focuses on predicting where is the missing. Now, I'd like to explain in more detail what the case actually is we imagine. We envision a situation where the writer and editor are collaborating. A writer will write a story and share it to his or her editor. Then the editor read it carefully, read the story carefully, and advise the writer where and how to revise the story to make it sell well. In this case, the editor advised the writer to insert a sentence to the original version to add more information. Our main goal is to create a model that fulfills the role of the editor in this context. This slide shows the formulation of our proposed missing portion prediction. We define large S as a story comprising n sentences. Small s with numbers indicates the sentences. Input is an incomplete story consists of n-1 sentences, where k represents the position of the missing sentence. Any information regarding k is not given in MPP. And the objective of the task is predict k from S prime. For your reference, the objective of story completion is to generate Sk from S prime and given k. Then this figure shows our proposed method for missing portion prediction. Given a full sentence incomplete story, the model treats each sentence by sentence encoder and gets sentence embeddings. Then these sentence embeddings are fed into the context encoder to get the context embedding. Context embedding is fed into the linear layer, and classification is done for missing portion prediction. In this case, 5 class prediction is done. Moreover, this method can be easily expanded for story completion. The same context embedding is fed into language model, and it generates a missing sentence. Now, outputs from the 2 modules and given incomplete story are combined to show the completed story. We conducted 2 experiments in the summarized paper. And in the next paper, we focused on experiment 1 and analyze further. Experiment 1 is for missing position prediction. It is an experiment in which we investigated part of the proposed method that excludes language model to show the desired context encoder. In this experiment, we used rock stories as a dataset. This is a large-scale story corpus, about 10K stories proposed with SCT. It is a collection of non-fictional daily life stories written by hundreds of workers belonging to Amazon Mechanical Turk. Not only for SCT, but it's also widely used in the story generation tasks, story ending generation, and story completion. Sorry, I wrote 10K, it is a mistake, 100K, sorry. It is for our proposed missing position prediction task, we randomly split the dataset in the ratio of 8:1 to obtain the trained validation test sets. For each story, one sentence was randomly excluded to create an incomplete story. The trained set is about 80K stories, and the validation test is about 10K stories. This is other settings of experiment 1. Excluding language model, we use sentence bird as sentence encoder and GRU for context encoder to treat sentences as a sequence. As a comparative method, which not treat sentences as a sequence, we used maxpool. More information about the training settings here. Training epochs is 30, and optimizer and the batch size is 256. Which experts we used among the pre-trained experts. To obtain the 5-class prediction, we used another linear layer to receive the context encoders output with 256 dimensions and outputs 5 dimensions. Now let's move on to the experimental results. This is overall accuracy. Prediction accuracy shows as mean plus minus standard deviation. As you can see, GR context outperformed maxpool context. In the next paper, we show only the result of GR context. Note that the prediction accuracy is shown as mean plus minus, and the chance rate is 20%. And these are heat maps show the accuracy for each position. As you can see from the heat map, the performance is lower when k equal 2, 3, 4 than that of k equal 1 or 5. Here is the discussions regarding the experiment. When the first or fifth sentence was missing, the accuracy was higher than when the second, third, or fourth sentence was missing. In other words, the beginning or the ending of a story can be easily predicted when they are lost from the original story. This result appears to be related to how rock stories was corrected. They corrected the story as the story should read like a clear story with a specific beginning and ending, where something happens in between. So the stories in the data set have a specific beginning and ending. Thus, it is likely that if the beginning or the ending is missing, our method can interpret it as unnatural. Let me move on to the further analysis section. In this next paper, we conducted further analysis on our finding in the summarized paper. The beginning or the ending is easy to predict as missing. We started 2 hypotheses. First, the second to fourth sentence in the 5-sentence story in the dataset are represented by a similar sentence embedding, so it cannot be divided. And the second hypothesis is that if part of speech post-tagging is applied for each sentence, a different trend may be observed. In this slide, the similarity of embeddings in the middle sentence is shown in a heat map. For each story in the training set, we calculated the cosine similarity among the sentence embeddings of 5 sentences. Sentence embeddings by sentence part. Contrary to our hypothesis, the sentence embeddings of the second to fourth sentences were not more like each other than to the first and fifth sentences. This is a slide for the hypothesis 2 post-tagging. Post-tagging of words in each sentence was performed for all stories in the training set. For each sentence number, we took the average number of times each tag appeared in that sentence. The focus is on whether there is anything special about the distribution of post tags in the first and the last sentences. And you can see pronoun here. Sorry, let's see the cursor. Please see the pronoun of the first sentence of the pronoun, the adverb and adjective for the last sentence. The focus is on whether there is anything special about the distribution of post tags, as I have said in the previous page. And in the first sentence, the appearance of proper noun is remarkable. And in the fifth sentence ending, although not as prominent, adverb and adjective occur frequently. Conclusion in the summarized paper is that to overcome the limitation of the conventional story completion task, we proposed missing position prediction to predict the position of the missing part based on the given incomplete story. And in this next paper, the further analysis suggested that the distribution of post tags may play a significant role in prediction accuracy. Further, the prediction model, the model we propose to pay attention to words with these tags is a subject for future analysis. As a supplement, there are 4 minutes left. So experiment 2 of the summarized paper, I show the results quickly. We conducted the task. We conducted the task connected missing position prediction and string completion and conducted human evaluation. Same data set as experiment 1 and use these models for our proposed method. For human evaluation, we first done the correction test to choose workers with ability in evaluating stories. And then we conducted the pairwise evaluation task. The qualified workers were given 2 similar short stories and asked to choose which story gives the impression of being a complete story. This is a result of human evaluation in experiment 2. We used 200 stories, and the most frequently chosen answers by 5 workers were considered as their agreement. And our proposed method can generate a story that is as good as or better than ground truth story with 26% probability. Here is the generation examples. In the first example, the autocompleted story was evaluated to be better than ground truth. Missing position prediction was a success, and a contextualized completion sentence was generated by story completion part. In the second example, the autocomplete story was rated as equivalent to ground truth. This is a failure case. In this example, autocompletion did not work. It succeeded in missing position prediction, but it failed to generate a contextualized completion sentence. The failure to generate an essential word, in this case, context, is pointed out. Here is the conclusion of experiment 2. Thank you for listening. Our code for missing portion prediction is publicly available at this URL. Please feel free to contact me if you have any advice or questions. Thank you for your attention again.
Thank you, Yusuke. That was very nice and I think informative presentation. Is there any question from the audience, perhaps? I see someone raise hand. Hugo Sosa, I will allow you to talk. You should be now able.
Okay, can you hear me?
Yes.
Okay, good morning, everyone, or good afternoon, I don't know. So first of all, thank you for your presentation. It was really good. And also thank you for introducing this new task to the community. It's a really interesting task. So thanks. My question is regarding if you have already put this in some kind of production or give it to a writer to experiment with it, because it seems to be a tool that can have a real impact in the world or in the writer community. So my question was that if you have any experiment of that type.
Thank you for the question. We haven't opened the production outside, but we are now trying to make a production so that writers can use our missing portion prediction and story compression model. We'd like to, in the near future, we would like to show it to the community. Yeah.
Okay, yeah, because it seems a really cool tool that can be really useful for many people. So thank you.
Thanks.
Thank you. Any other question from the audience? I think from panelists, right? Yeah, Ricardo, go ahead.
Yeah, Yusek, thanks a lot for this clear presentation. And
thank you.
Okay, so evaluating these kind of systems is a difficult task, and I noticed that you used rock stories, which is a data set that we considered to use in a project that we are conducting right now. We are particularly interested in data sets with the features of rock stories, very short texts. 5 or so.
Yeah, 5.
Are you aware of similar data sets involving news articles and which still are very short in its nature, or not?
Sorry, sorry if I misunderstand your question. We hope to at the first step, we use rock stories, 5-sentence short stories. We'd like to expand this method and task to more variable ranks of stories and other other domain of text, such as news articles or SNS and comments or like that. So in this time, we set a limitation of 5-sentence stories as the first step, but in the near future, we'd like to expand it more variable situations.
Mm-hmm. But during your research, your investigation, you were not aware of any other data set that resembles the characteristics of the rock stories? No.
In today's presentation, I just talked about the rock stories. We also considered writing prompts or some other long story data sets. But regarding the writing prompts in particular, it is I think it is too long. So it is sometimes used with trimming, trimming the first 200 words or something like that. So there is no specific ending in the data set used when the data set is used. So missing portion prediction is applied to the trimmed data set. Then it must find that the last part is lost because Rust bus is trained, so it is not good for the task setting. So we should use a complete story or a complete plot for this task.
Thank you.
Any more questions? I don't see any hand raised. So then I will quickly ask my question. Did you consider other variants of your setting? For example, the case where there is no need to add any sentence. There is no missing point that is required. There's one setting and another setting. What if you also have a sentence to be included somewhere? Not only you need to know where to include it, but the sentence is also given.
Thank you for pointing out your concern. That is a very important point, we believe. In this case, we use we set the limitation one sentence lost, but we are now also trying to expand this task to k. K is null, or there is no missing sentence. The sentence is complete, originally complete, or there's multiple sentences lost, and maybe there's too many sentences, and the sentence should be cut to make the story more better. So there are many things in this. In this case, we said, sorry, I have said the editor AI. The editor have many things to do, not just pointing on the rack, but there is too long or something other point. But in this case, we focus on one particular task of the editor. But in the future, we'd like to approach many more other tasks.
Thank you. Okay, great. So thank you for the speaker, Yuska, thank you. And let's move on to the next presentation. I would like to ask next presenter Taraf Al-Rashid, I'm sorry for pronunciation, to do the setting already. And he will present about a pilot study on annotating scenes in narrative text using SceneML. I don't see yet.
Yeah, can you see me now?
Oh. Can you show your screen slides?
Okay.
Sorry, I mistook. Yeah. Taraf, please. Sorry.
Okay. Can you see the screen now?
Yes, we can see and hear you.
Okay. So I am Taraf Al-Rashid. I am a PhD student at the University of Sheffield. The first part, I would like to thank the workshop organizers for organizing such a workshop that let us meet and share our work despite the pandemic. I also would like to thank the paper reviewers for the reviews and comments that made our paper to become better. So I am supervised by the Professor Robert Lizaskis, who is co-authoring me with this paper. So today I'm going to represent our work on a pilot study on annotating scenes in narrative text using SceneML. So have you ever thought of the idea of automatically segmenting scenes in any narrative text or in any narrative? And why did we came up with this idea, or why do we do automatic scene segmentation? So first of all, this kind of research can support or can aid narrative studies such as automatic text illustration or automatic story picturing. It also can support aligning text and movies, to support automatic image description or automatic narrative generation. So first of all, in order for us to automate the process of scene segmentation or segmenting any scene in any narrative, we need a manually annotated data, and in order to manually annotate scenes in any narrative, first we need a stable definition of a scene or a formal definition of a scene, because sometimes when you ask people, what do you consider a scene? Like, for example, is it or when do scene change? For example, is it when a character moves or enter a scene? Is it when we are taken to another location, or is it when we are taken forward or backwards in time? So that's why, first of all, we need to set a stable definition. Then we need to set a set of rules, a set of guidelines that can make people to annotate scenes following these kinds of rules and guidelines. So scene ML or scene markup language is an annotation framework that defines the scene and defines a framework for an annotation tool. Please note that this is a previous work on another paper. I'm here just going to give a brief definition and a brief explanation what is scene markup language, and then I'm going to talk more in detail about the pilot annotation exercise itself. Then I'm going to give an example about the annotation. I'm going to talk about results of agreements between annotators. I'm going to give some discussion on manually analyzing the disagreement between annotators, and then I'm going to give a conclusion and the future work. So CML stands for Scene Markup Language. That, as I said, is an annotation framework. CML defines the scene as a set of as a unit of a story that has three elements: time, location, and characters. So scene has only one time, one location, and can contain a set of characters. Any change in these elements indicate a change in the scene. Scene markup language have elements. First, it has entities. The main entity is scenes, and it is the main element in CNML. It is abstract discourse elements. That means it's not annotated explicitly in the text. Then we have SDSs that are scene description segments. These ones are the actual strings of text that comprise a scene. So each scene can consist of at least one or more SDSs, but each SDS can belong to only one scene. Then you have characters, times, and location. And as I said, each scene must only have one time and one location. Then we have relations. So after we define scene, after we annotate scene and find scenes in any narrative, then we can connect these scenes together. We have four types of relational links. First of all is the sequence relation links. The sequence is the scene when two scenes come after each other. So a scene change happens because of a change in a location or characters, but the action follows directly from the preceding scene. Then we have the analysis relation. The analysis relation is when we are talking about a flashback. So, for example, here we have a scene that are two people are talking together. Then the boy is explaining a task or an event, for example, swimming or riding a bicycle that happened in the past, for example, yesterday. So this conversation would be considered as another scene that happened in the past that will be linked to the current scene through an analysis relation. The third relation is prolepsis or flashwords. It's when we are taking forward in time. So we are talking now in the future. So for example, let's assume that this girl is talking about her future plans to travel and talking about what she's planning for traveling. So this conversation also here would be considered as another scene and will be linked through through a prolepsis or a flash forward relation. Then we have a concurrent relation. This one links between scenes that happens at the same time. So we are going, we have two threads of story that happening at the same time. So these scenes we are going to be linked through a concurrence relation. We have other relational links that link between the other entities to the scene. So we have links that link between character and the scene, time and the scene, or location to the scene. Here we have an example. Let's take this simple story. For example, John and Tommy are walking down the West Street, heading to the supermarket. While they were talking, they remembered a year ago when they traveled together to Spain and had a lot of fun there. As they approached the supermarket, they found a little girl. So this story, applying that scheme to this story, would be divided into 3 SDSs. So as you can see here, we have John and Tommy, the characters. We have the West Street as a location. Then we have a second segment. And why is that? Because here we have a different time and a different location. Then we have a third segment that is linked to the first one because the events here are happening at the same location of the first segment and at the same time, and we have the same characters. So the first segment and the third segment are connected together to confirm the first scene. The second segment on its own confirm a second scene because we have a time change and a location change, and it will be connected to the first segment to the first scene through a flashback relation. And as we said, flashback relation because here we have a time change that took us to the past. So here I'm just going to list the aims of our pilot study. First of all, to assess the viability of scene segmentation task and the adequacy of our guidelines. We also need to see how can we improve our annotation guidelines or our annotation process. We also need to see if there is any problems with our approach, with our guidelines, or with our task. So, starting our pilot study, we had chosen 2 chapters of the children's story, Bunnies from the Future. That story is targeted for reading ages from 10 to 13. We have chosen chapter 3 that is 124 sentences long, 2,756 words. Chapter 4 consists of 65 sentences, 1,775 words. We have recruited 3 annotators in addition to one of the authors, that is me. Most of them were postgraduate students, good speakers of English, and they were non-native speakers of English. They were asked to annotate SDSs, character, time, location entities found in the given text, that is chapter 3 and 4. They were asked to follow the guidelines that were created based on the scene ML. They were asked also to use the BRAT annotation tool. There were two simplification to the pilot annotation exercise, or let's say two limitation. First of all, the annotators were asked to not annotate the scene abstract discourse element. And that's because Brad didn't support zero span annotation that is needed to annotate the scene that is abstract discourse element. This problem was circumvented by linking all the SDSs that belong to the same scene together through a new relation called same scene as. So whenever any two or more SDSs are linked through a relation called same scene as, then we can know that these SDSs belong to the same scene or confirm the same scene. They were also asked to not annotate any relations. So relations between scenes are not annotated here for this pilot study. First, because for this pilot study, we were primarily concerned with determining whether or not the annotators were able to find scene boundaries and can find SDS boundaries or can find the other entities, for example, time, location, or characters. Given that for our text, almost all scenes consist of a single SDSs, so even the need to link the SDSs together using the same scene as relational link is low. This is just an example from the Brad annotation tool, an example annotation that shows where are the scenes annotated, where are the locations and the time entities. So now let's talk about the results. The inter-annotator agreement results. It's actually pairwise. So we took each pair of the annotators of the four annotators and measure the agreement between them for each chapter 3, and chapter 4. So here K1 stands for the kappa score for SDSs. So we measured SDSs differently than the other entities. K2 stands for the kappa score for all other entities together. So in general, you can see that most cases are fair agreement, that is 0.21 to 0.40, to moderate agreement, that is 0.41 to 0.60 agreement. We have a few cases of slight or substantial agreement. We can see that annotator 3 agrees more with annotator 4. These two pairs agree much more than any other pair of annotators. You can also see that agreement on SDSs is higher than agreement on entities. So annotator 3 and 4 achieved 0.72 for K1 for chapter 3 and 0.95 for K1 for chapter 4. There's another table that shows the percentage agreement results for each entity type by token. So, for example, we take K2 and we look in the details of that. Here we can also see that annotator 3 agrees more with annotator 4, and this pair agrees more with than any other annotator pairs, scoring 0.73 for character and 0.88 for location and 1 for time. Please note that all here in the table refers to the outside tag, and you can see that the outside tag has the highest agreement score, and it will always be high as most tokens are outside of any entity. I'm going to summarize the results of these two tables. As I said, most cases show fair, that is 0.21 to 0.40, to moderate, that is 0.41 to 60 agreement. Few cases show slight or substantial agreement. Agreement on SDSs are higher than agreement on any other entities. Agreement scores actually aren't as high as we want it to be. Entity scores, the K1, the agreement on entities, are dependent on agreement on SDSs. This is an example. So, for example, if annotator 1 annotated 2 SDSs, annotator 2 annotates 1 SDS. So the story just, this is at the beginning of the story. Annotator 1 annotate 2 SDSs, annotator 2 annotate only 1 SDS. Then annotator 2 will have twice the number of entities than the other annotator. That's why the agreement of SDSs is higher than agreement of entities, and agreement of entities are dependent on the agreement of SDS. And that's why we can see that also on the second table, that annotator 3 and annotator 4 agrees much more than any other pair of entities, because they also agreed much more in the first table. So let's move to discussing the results. So here, the table summarizes the numbers, how much they agree, but we want to know why there are such disagreements. So we manually analyzed the annotations of the 4 annotations, trying to find the disagreement between annotators and trying to analyze them and find the causes of such disagreements. So we have found 2 underlying causes. The first one is the lack of understanding of either the guidelines, the task, or simply English. The second one is the lack of clarity, specifically in the guidelines. Lack of clarity or specificity in the guidelines. I don't know if you can hear me now. Can you hear me?
Yeah, there are some voice issues. Maybe you speak closer to the mic.
Oh.
But we generally can follow, but sometimes it stops.
Okay. Okay, these are often not easy to distinguish. So here we are. I'm going to give some examples on the causes of such misunderstanding. So 2 people, for example, some annotators annotated 2 distinct location entities tagged in the same SDS. This clearly contradicts the definition of the scene. We have examples of lack of understanding English idioms and usage. For example, here the statement, "How on earth had he?" etc. So this is an idiomatic expression. Earth here was annotated as a location of the SDS. Very clearly in the statement, it's not a location of the SDS. There were some English, general English understanding. For example, sorry, alt cap had an attack of the wobbles, dashed embarrassing. So dashed here is considered or is annotated as embarrassing. So people are telling me that my voice is not heard clearly, so I'm going to take off the earphones. So examples, here I'm going to give some examples of lack of clarity and detail in the guidelines. So annotating definite or including definite articles and annotating entities. For example, the Stone Ages versus Stone Ages. So some annotators annotated the with the entity. The other example, do you not have good fabrics in the future? So this was a question in the SDS. So we have a scene. We just have a question in a conversation. So here the future, it was just a question in a conversation. The future here didn't refer to the time of the SDS, whereas one of the annotators annotated as the time. We have a confusion regarding tagging characters. So should we annotate the fullest form, the first mention, or every mention? Here we are going to give an example of lack of clarity in the guidelines. We have seen transition segments, for example, and soon I emerged back into the corridor looking like a new man. So should this statement be annotated as belonging to the preceding or succeeding scene? Is it a scene on its own, or is it a part of no scene? Or is there a new element like called scene transition should be added to the CNML? When minor characters suddenly appear or disappear from any SDS, should that encounter a scene change? So this was the causes of disagreement. Here I'm going to conclude and give some future work suggestions. We have presented a pilot annotation experiment that annotators are asked to use the CNML to annotate the given text. From the results, we have found that the task is feasible, but we need to change our process and our guidelines. What need to be changed? First, annotators need to be better trained. We should do a trail annotation exercise, and then the annotators should be filtered based on their understanding of either English, guidelines, or the task. And the third one, the guidelines need to be refined and improved to overcome the confusion. So once agreement between annotators has been assured at a higher level, then we are going to extend the annotation exercise to include all the ML elements. We are going to apply the scheme to a wider range of text or media, for example, historical or contemporary fiction for adults, or non-textual narrative genres such as films. We are going to investigate automating the process of scene segmentation after getting sufficient manually annotated data. And finally, we are going to investigate applying this scheme to languages other than English. Thank you for listening for my presentation. Sorry if you have any audio issues. If you have any questions or suggestions, I'd be happy to answer to. And these are my contacts, email and or Twitter account. If you have any question, you can reach me after that, after the workshop. Thank you.
Thank you, Tarfar. I think it was quite clear despite some minor voice issues. Very nice presentation, very interesting. And I would like to ask if there is anyone who has a question among participants. I think there is one from panelist, Alipio. Go ahead.
Hi, hello. So thank you for the talk. Very relevant, very important for the task of narrative extraction. And so I may have missed a part of it. You are using or proposing CNML, so this is a markup language, but I don't think I've seen any example of the actual markup. So is this the output of this of your breadth annotation is an annotated text with a markup language? So this is a very specific question. Sorry for that, but it's related to some things that we are doing. That's why I'm interested.
Yeah. No, actually, the primary work here is the pilot study. So the pilot annotation is the primary work here. The CNML is given in detail in another previous paper that has published before this workshop. So that's why I only give like a brief definition of the CNML. So you can understand the background of the pilot annotation before I talk in detail about the pilot annotation.
Okay, so your annotation is basically selecting a part of the text and annotating it as a scene. So that's is it as simple as that? Of course, it's not simple for the annotator, but in terms of annotation densities, it's just selecting a sequence of text and saying this is scene 1 and then another and this is scene 2. Is that it?
Yes, we can. Yeah. You can annotate which paragraphs or which sentences. However, the scene, the SDS long. So we ask them to annotate the SDSs and annotate each entities, for example, characters, times, or location that belong to each SDS.
Okay, and is your data set, your annotated data set available for researchers?
It will be available once we have finished with all annotations, because this is the first pilot annotation exercise, and clearly there were some disagreement between annotators. So we are going to refine the guidelines, and then we can create another annotated data set.
So just to finish, I imagine you're also developing work on automatically identifying scenes. Can you tell us a little bit about that?
Yes. So first of all, once we are happy with our guidelines, once our guidelines are stable, then we can begin another stage of annotating scenes. So when we reach the agreement that is reasonable between annotators, then we can start another annotation exercise that can enable us to gather as much scenes and entities and relations between them as possible. And then we are going to build a model based on these manually annotated data, for example, using machine learning to train these models using the manual annotated data, and then we can automate this process.
Thank you.
Thank you.
Ricardo? Cannot hear you.
I just forgot I had this with me. Tarfa, congratulations for your work and for this clear presentation. Despite the voice issues, we could understand everything. Also, Alip, you made some very interesting questions. This is kind of related with the work that we have done in our research group. Alip, you will present a similar setting, and during the afternoon we also have here some elements in the audience that have participated in a similar task of annotating on Brett. However, in our case, we do not deal with scenes, but with events. I would also like to ask you if the data set is available, but Alipio has already asked that. So I was wondering about another thing. To what extent do you plan to make use of the temporal information, if you plan to do that within your task? I understood that you already tagged that information on the data, but do you plan to use it to your particular within the particular task that you are dealing with?
Yeah. So the main definition of a scene. So how do we actually encounter a scene change, or how do we let annotators to like say that here we can stop the scene and here we can begin a new scene, depending on these temporal entities. So these are important because whenever we have like a time change, allocation change, or characters change, then here we can encounter a change of a scene. So yeah, and as I explained at the scene markup language, that there are some relations that link between these entities to the scene containing them, so that we can more easily encounter a scene change.
What are you currently using to identify the temporal expressions? Was it a manual process? I know you resort to annotators, or was it a semi-supervised process, for instance, resorting to idle time temporal tagger or so? What did you use?
And until now, it is manually annotated by annotators.
Okay,
yes.
Okay, thanks.
Yeah, because we only need to annotate only one time and only one character in each SDS. So yeah, if we do that automatically, automatically can multiple times or multiple occasions can be annotated in the same scene or in the same SDS. Of course, we can do that and let annotators to select the ones that are relevant to the SDS. But yeah, but for now we are doing it manually.
But did you notice some issue from the annotators on understanding the temporal references, or they did not complain about that fact in particular?
They didn't complain, but I have seen some disagreement regarding annotating such entities, and as I said, it was because that some of them didn't quite understand how to link between the entity and the SDS.
Yeah, which is a particular difficult task indeed.
Yes.
Okay, thanks a lot, Tarfa.
Thank you.
Thank you.
Just a comment from my side. When I saw these agreement scores, I thought they are rather low. But once you show examples of the data, I understood the task is very difficult, and this agreement is reasonable. And just one comment that when I Google about such markup languages, I found there might be some others like Fiction ML. So you probably would be good at comparing with them and finding differences of your proposal.
Thank you for that suggestion.
Thank you. Okay. So I think we have to decide what to do, Ricardo. About next session.
Yeah, I think we should move forward. We already have Yannick with us, and Rudolf is also here on the stage. I think this passage from Tarfa to Yannick is great, because Yannick was the guy behind the scenes of the idle time temporal taggers. So I give a great welcome to Yannick. He came from Bosch, and he took his PhD at Idle Time University. It's a pleasure to have him here. We often collaborate with him. Yannick, please, now the floor is yours, and you can share the session.
Yeah, thank you very much, Ricardo. So voice quality-wise, is everything fine?
Yeah.
Okay, great. Okay, then, yeah, thanks for having me to chair a session in your great workshop. I think it's really a pleasure to be here today, in particular because we also have two very interesting papers in this session now. And the first one will be a project description, and the second one will be a demo paper. And yeah, I think for the first one, Rudolf is already in the panel and will be able to start in a second. So the paper of Rudolf is actually about Theater 1.0, interactive generation of theater play scripts. And yeah, the paper is authored by a highly interdisciplinary team. So Rudolf comes from Charles University in Prague. and has a bunch of nice collaboration partners in this very interesting project. And we are looking forward to seeing your presentation now.
Thank you, Yannick. Good afternoon, everyone. As you can see, this is a large collaboration of several institutions from various backgrounds. So the title suggests what the talk will be about. So interactive generation of theater play scripts. So we managed actually to put automatically generated theater play on stage. So, okay. So first, let's just show the faces behind the name. The whole team. On the left side, you can see the linguists. There are theater experts, and the right are waiters came up with the idea. And so why did we decide to do that? So the motivation for automatically generating
can I very briefly interrupt you, Rudolf? So yes. Maybe some of us have some audio issues. So sometimes your audio is here and sometimes not.
Okay, I can.
Can I get some feedback also from the other panelists, maybe?
Yes. I can try a built-in microphone if it's better.
Yeah, way better.
Can you hear me better now?
Yes, thank you.
Okay. Okay. Yeah. So the idea was to celebrate basically the anniversary of first theater play about robots, which years ago, like our topics were checked.
It was better when you had the headset, I think.
Okay, I'll try to put it back again.
Well, if I may suggest, I don't know if it is a problem with the microphone, since you had the same problem with and without the headset. It could be a problem of internet connection.
Okay.
If you turn off the video, maybe it improves. I'm not sure.
Might be.
But I don't know.
Let me try. Yeah, something I can do definitely.
Now, actually, now you are listening you very well.
Okay, so let's hope it will stay. So we decided to celebrate the anniversary of the first theater play about robots by trying to put the around and to actually have a robot to run a theater play. So actually, it wasn't a physical robot, but some artificial intelligence system, of course. And, this was mostly successful. So a month ago, we actually premiered the first theater play was written by AI, so from any previous. So this is a project presentation. So I have to admit that the research part is not very or anything. So a lot of it will be just for future research, because we're in the middle of the project. So far, we largely about how we hacked to model to generate something that looks like. And then we built a web application around that, which I will show a short time ago. And then we used that web application to which was in the end performed by professional actors. So also snippet from the actual end of my. This is the project, and this is also the outline of my. So let's get to the part. So here we really decided. Well, it was kind of first attempt. Okay, let's try how far we get just with using GPT-2 model, because a lot of tasks like news or fake news, and so let's just try it, and we actually expect wouldn't work so well, and we would some more symbolic approaches. In the end, we did, or we haven't yet, because it turned out that with some limitations to even scripts. Surprise for us, but well, we went with what we had. So the base approach, it's very simple. So GPT will happily take any which looks beginning of a document and try to generate a content for what we do in the project is that we input that looks like a basic beginning of a script or a scene in a way. So some description of the situation, and then start of a dialogue which kind of produces. And then we just put GPT to generate a continuation, because we actually wanted to stage the Czech language, so we then machine translate the there's no GPT not. So let's just show some output already. So when we push the input, so there's a girl hitchhiking and a man her a ride. And actually, we've had some people complain that our plays with sex and violence too much. Said, well, yes, the model just keeps changing, stuff like that. Well, it's text written by people, so people are biased. So when you hitchhiking, you immediately think about some. But what is good is that it keeps to, well, the structure, the topic so far. So this is what it's based on, really. And, there is, of course, a number of issues with it. So I'll start with issues that go resolved. It might not be ultimate solutions, it's rather hacking, as I said. One is actual characters, where what we've could in the sample that we showed is that tend to appear randomly, and the old characters tend to appear randomly. Well, might be well, but every few lines is modified the probability of GPT to predict for various tokens, so that it can make lines by the characters that are present. There we a lot of repetitiveness that often the same line again and again, and sometimes going into an endless loop. But it's sufficient to just increase the penalty for repetitions just slightly. If we increase it too much, it disallow repeating the same word again, so you would quickly run out of verbs and prepositions and articles. Repetition penalty. And there is just some back off to. The most interesting part, like research, was to fight the limited context of GPT-2. So GPT-2 is quite powerful in the sense that it has a context of 124 subwords, so in often like 800, which means that it can maintain consistency of the story well for some time, but it's far from sufficient for a whole theater play or even a whole scene, which is usually several pages of text. There would be inconsistencies on the long run. It would, from the topic, just forget everything. Here we managed to use a very simple approach that improved the results significantly. That whenever it's too long, it doesn't fit into this 124 subwords anymore. We apply just summarization. we use an existing library to identify the most important lines in the we have so far, and we keep 5 lines plus the last 12 subwords, so that we have some short distance consistency as well as long distance consistency. So we the immediate context and the previous context actually works pretty. So we plan this a bit more to explore more options in the summarization, but it managed to mostly problem of long range. And then there was some hacking of some minor machine translation issues, but the machine translation issues are not yet addressed. These are that we might have to look at here, but we managed to avoid some of the hardest problems. We have many more unresolved issues or plans. What is that we just are able to generate individual scenes. So well, as I said, well, a few pages of text, but not a whole play. So the photo we put on stage was actually assembled from 8 scenes generated independently. So the plan is to take a hierarchical approach, probably to generate and expand it and then expand the fine-tuning GPT-2 by training special models just for the engine. So we also considered using some symbolic representations of the structure. So far, well, the GPT was so successful that we take this path, or at least not try to see how far we can get just using text representations. And the obvious benefit is that it's super easy. Well, it's not okay. It's possible to harvest data from the super easy to find actually theater plays online or theater play outlines, but this, so we are trying to avoid really annotating these. There's still a lot of character kind of perspectives. So we one model generate the text for all characters, so it doesn't take into account the fact that maybe characters have different positions, different. Cannot work with the similar to what Pablo said, so that some character might say something which is actually not. So other character might disagree with that. The theater experts on the team basically saying that the system is similar to a naive child believing everything is want to this into the character embeddings to the personality. So now something that that is highly experimental is working with traumatic situations, which is a classical concept of trauma. Where, trauma typically doesn't work in situations that you can say a scene is actually a sequence of dramatic situations, like an intruder where somebody comes and then you pass into a different situation where maybe somebody makes a request and 5 or lines. The drama experts are really about dramatic situations being the building block of drama. We're trying to annotate theater plays with the plan is then to automatically to generate in the. There seems to be basically no useful data on that too. There are various machine translation issues like gender, which is expressed but not lightness or the limited content standard. And then there are the hard issues where we can in a meaningful way. Like the question of whether the play is about something, whether it's something meaningful, that's hard to even from the what is this play about? Well, everybody will say something different, so it's hard to computationally. It's also importantly missing the visual information, which is super important in theater play. It's important to understand what is actually happening on the stage. This is often not really clear from the script, and we've been told that usually the director himself what to do on the stage, kind of independent of the script. So definitely in theater, subtext, which is not annotated anywhere. So this was about the internals. So now the second part of my presentation will be just more about stuff. So now a short video of a demo of the application. So let me show you how to use Text2Story. We'll add a new scene. I'll call it Master's Death, and I will copy paste some input. It's the morning. The robot enters the room of his master. He's real old and sick. The robot sees that his master is not doing very well this morning. He sits at the edge of his bed and takes his hand. Robot: I remember how you jumped on this bed when you were little. You were full of beans. Master: we both know I am dying. So I submit it. So now the Text2Story tool gets this input text, and the GPT-2 model hidden in it starts generating a continuation of this text. It all takes like half a minute, so I'll skip forward a bit, and we get the result. So we can see the input that we entered, and we can see a continuation generated by the model. Okay, it starts to be about some killing. Interesting. And you can also see that it gets automatically translated to Czech language by a machine translation system. Now, the user has several options. One option is that if the user likes what is generated, so they can simply click continue, and well, it always generates 10 lines, so and then stops. So after clicking continue, it will generate another 10 lines. And here is some further output. So the scene now goes on. So we have now 20 lines in the scene. And again, if we like it, we can just continue. If we don't like it, we have further options. Maybe we don't like what was generated. So let's see, we like the first 3 lines, but not the continuation. So we can click the X here, and the text from here on gets deleted, and another option is generated by the model. And so this is the output, and the first 3 lines are kept, and the 4th line, now that's a new continuation. And this is version where repetition is not strictly forbidden, so sometimes the model keeps repeating itself. So maybe we can use the 3rd option, which is to manually enter some input when we feel that we need to push the model in a different direction. So let's see what the model now generates. So we do see what we saw before, and now there is the line that we entered. So it's colored gray, similar to the prompt, so that we know that this is manually entered. And the model now picks up the input with this line, and this pushes the generation in another direction. And that's basically everything. That was the process of generating script. From the application to like this booklet, which contains the real script. So there was some further. So the first part was really generating the individual scenes in application, where this was my professional dramaturge. Well, he would sometimes choose. Time to time, he would add a line manually, but there was some further. So some parts were, sometimes there were some small, like characters or something. And, then to check that. We're in the process of analyzing the amount of the. But so these are some estimates. Change bit. So as for process in the application, so the manually entered texts were just something like 3% of the script generated, of lines being thrown away to in the post-processing. About 50% of the lines, 15% of the lines were deleted. And some small edits in total. This meant about 1% of the script. Like 1/3 of the lines was still, 1/3 of the lines are intact, and 1/3 has some. In the translation, there was actually a lot of problems. It's hard to say like one number, like what percentage of the script automatically generated and what is written. If we just count, well, word-based, if word was generated by the system, of word was inserted or changed by the human, so then we can say like 90% of the script is. But it makes much more sense to look at this detailed analysis than just the one. I would say. The thing is to really put it on stage in a theater. So it's important to understand that only the dialogues were generated, but everything had to be done manually. So like the music, everything. There was really a professional team to put it on stage with dramaturgists, etc. This a month ago. You can find reviews online. The theater stage when possible. So the final thing, I will play part of a trailer. The whole trailer has like 6 minutes, so I will just play 2 minutes. You can want to watch more. And I'm sorry, the sound may be a bit louder than my speaking, so turn down the volume low because I.
Nevěděl jsem, že jsem schopen těchto pocitů, ale miluji vaše laskové křivky. Miluji tě.
Je mi líto, ale já nejsem robot.
prosím, máš na vás.
Omlouvám se, já nejsem tak sexy jako ty. Jsem jenom modelka.
Jak dlouho ještě? Jen pár minut vydržte. Už brzo umřu. Už brzo umřu. To bylo velmi dobré obětí. No, užil jsem si to. Skvělý čas. Víš, musím tě toho tolik naučit. Bude mi trvat hodně dlouho, než to vysvětlím.
Okay, so as I said, it's available on YouTube if you want to look more. So that's the end of my presentation. So well, more research points. We hacked GPT-2 to something that looks like scripts, and then we used that to eventually generate a play that was performed. As I said, we're in the middle of the project, so there should be one more play in a year from now. So project on its way. So thank you for attention, and I'm happy to take questions.
Yeah, thank you very much, Rudolf. I think it was a very nice and impressive presentation, despite the fact that we had some audio issues in between a little bit, unfortunately. But nevertheless, I think the story was nicely conveyed. So I like a lot the combination of AI and art. And as you nicely demonstrated to some extent there, AI might be sometimes also considered as art. And yeah, you nicely highlighted the reasons for that. So I would start with basically asking to the audience if there are any questions. So Alipio.
Yes. So so thank you all for the great talk, and it's very, very exciting work that they've done. I've seen it before, and it's really thrilling and even troubling, right? So you see these dialogues evolving, they get into you, and you feel something. It's funny because it's what we read, what we feel, coming from dialogue generation. There's nothing, but we can imagine feelings and emotions, things going on between the characters. That's part of it. So one more technical question, although I've thought of or tried to provide some general guidance to the dialogues. So, for example, so I would like to go blue. I would like to go to a crime scene, or be happy, or have a. I guess this is harder to do because it requires deeper reasoning. But you thought of it, and you can share your views about that.
Thanks for the question. So, we have several ways of trying to so still the most thing is definitely the prompt that beginning, so this kind of guiding the dialogue in some way, and we're now experimenting with preparing kind of an outline for what should be created, and then inserting lines from the outline one by line into the it's manual, so that you can outline that in the middle section, something now there starts a function. This is inserted. We plan to have this automatically generated and automatically created. And then, so this is still going in there. And then something else we've seen in some picture here, I don't remember yet. was that we can do some kind of domain adaptation of probabilities of GPT-2. So it's really just the next token, what the next token should manipulate is, so you can just boost probabilities of that you do with what you inject into the dialogues.
Okay, thank you.
Okay, thanks. So I would also have a question, and this basically also goes into the direction of this script production part. So you mentioned that you basically allow for, well, I would call it a human in the loop approach, right? Where you basically can influence the direction of the dialogue. And can you elaborate a little bit on? So if I understood correctly, you are able to influence the dialogue in between by typing in some text that you want to have basically in your dialogue. So how did you actually do that for the final script? So did you have this as one director basically, where one person really decided yeah, into which direction the dialogue should continue, or was it a team decision somehow?
Yeah. So yeah, thanks for the question. So it was kind of both. So the main person behind was who is one of the from the theater. So the one who actually operated the tool, actually 15 scenes. Together, the theater team decided to choose those. And before that, they kind of decided on a it could be a robot. This is how the input that the scenes kind of. But then really operating the tool, this was just one person. So it becomes way to go, and okay, adding into which 8 times or in so this was this was good because it meant that the scenes are kind of coherent because the person leading to coherence in some way. And yeah, we call it a human in the loop approach. Stage definitely is not like mature enough to on its own so that it would be useful for anything. So to minimize the impact of human inputs, but wanted to have some human to generate a play that actually the will enjoy.
And so this was also the way how you basically aimed at having kind of, well, different emotions for the different characters, or is there any way to basically fine-tune the model in such a way that the different characters, so the different actors basically show different characteristics with respect to their emotions?
So that's something, yeah, we haven't done so far. We hope to achieve something like that with the embeddings, which in the literature, and we plan to kind of cluster characters in theater plays, like a positive, negative character, maybe top character what we find useful. But it's hard, and we've discussed this with the theater guys, and they said, well, it's not like there is one character who is angry. It's like developing the emotions in the situation, and hard to capture. And this is something that annotated in the data and is hard to annotate, because if we ask the experts, so label the emotions with each of the lines, so then so this is really done kind of in the so that the actors and the director decide how to interpret the text as unchanged as possible, but they decided what kind of emotions to put. It was really hard for them, the director and the actors, that it was hard to identify with characters because it doesn't make sense to them. They cannot find a for them or something.
Okay. So we also have one more question from the audience. I don't know if I have to make you a panelist to be able that we can actually hear you.
You don't. Who is he or she? I cannot find it.
So I just
here.
saw it in the chat, but I also cannot see him as an attendee at the moment.
No, I can't. It's me. I'm already a panelist.
Okay, great.
Ah, okay, I see. Okay, thanks.
Sorry,
Okay.
I'm in
Good,
the
then go ahead,
wrong
please.
window. So, hi, Rudolf, and thank you very much for the talk. I really enjoyed it, and it did help me understand the system a little better. But I have one question regarding the sort of the general approach to the generation, especially towards the end. I mean, these you giving the prompt at the beginning, and then the thing builds forward all the time, right? And you can sort of drive it in these ways that you've described. But of course, for this kind of thing, for a play to be successful, the really important thing is how it sort of converges towards an ending, and you get this feeling of closure at the ending. And so the question goes two ways, really. Is there anything in the process that you've put in that sort of leads it to the ending, or is it something in the driving that makes you go to the end of it? Like, when do you decide that this is enough and this is finished for a particular scene, and when you decide that for the end? Because I think that might be very important to get a good play versus just anything.
Yeah, that's a great question. I actually forgot to put this point into the unresolved problems. So the complaint that we're getting from the operators of the system, that it opens the situation but then doesn't really the situation. Well, it depends. Sometimes it does. Well, GPT-2 can generate the end of text token, which means that the model end here. So sometimes we manage to get to the end of text. And the situation typically, usually it's not something dramatic. It's something like the characters decide to leave and say goodbye, and then this is the end. So it's really not a real climax or anything, but well, at least it ends. But that's
So
this is actually where a lot of where was it? So that adding a line was something the operator didn't use, so he used it like in some of the scenes this wasn't used. I would say in half of the scenes, manually adding a line into the script was actually the way how the church put it to what situations. So to shift the topic or to open a topic, or rather to topic. So by adding either one line or one more remark or on what's happening. So this was a kind of a way to push it to some kind of an ending, but it was hard to and how to thought about generating the script from the end towards the beginning. So it would be generated line by line, but with a fine line. And obviously the trained for that, so we would have to. We haven't this way. We still think it would be worth trying out because, well, it can begin in any way. It's not so important how it begins, but how it ends. Yeah.
Thank you.
Comment of the system.
Okay, Thank you again very much, Rudolf. I think it's also a great opportunity for everybody in the audience to actually watch a theater play during Corona times. So looking forward to doing so. And yeah, thanks again for this nice presentation. And yeah, I then would basically hand over to our next speaker, who is Hermann from TU Braunschweig, who will be talking about demonstrating narrative bindings, linking discourses to knowledge repositories. And so Hermann, the floor is yours.
Thank you. Can you hear me well?
Yes.
Yes.
Seems so. Okay, perfect. Then I will start my presentation. Okay. I will present you demonstrating narrative bindings, linking discourses to knowledge repositories. So this is a joint work with Dennis Nagel, Morris Kunz, and Wolf Thilo Balke. And it's a demonstration for this workshop. So the first question is obviously, what is a narrative? And I think, like all of you know, finding one narrative model that fits all use cases is nearly impossible. And for our research, we aim to model scientific discourses. So for us, a narrative is just a story, or more precisely, an argumentation in which knowledge is shared. So this is our vision on narratives. And we see that narratives have three essential components. So the first component is factional knowledge. So factional knowledge consists of relations between different entities. So if you have a look on the right side of my slide, then you see that we have here two green circles, so aspirin and headaches, and they are both important biomedical concepts, so entities, and they stand in a relation. So aspirin is used to treat headaches, is some kind of factional knowledge here. And indeed, factional knowledge might also include type information, so for example, that aspirin is a drug or something like that. On the other hand, we have some more dynamic component of narratives, and we call them events. So like this blue circle here, so we treat a patient with a drug. This is something which happens in time, which is performed, and which has a temporal component. So it's basically some labeled state or a change of a state, and we denote them as events. And the basic backbone of our narrative is formed by narrative relations. So how do events and entities play together? So which entities are involved in which events, and how the events belong together. So for example, one event might happen before another event. I really appreciate this talk, the talk this morning about nested narratives. And we also thought about it that in a narrative, a whole narrative might be used as a subnode, for example, so a sub-story in the narrative. And we talked about that in our original paper, so modeling narrative structures and logical overlays on top of knowledge repositories. But for this demonstration, finding narrative bindings against the flat narratives is difficult enough. And so we ignore this nested version of narratives for this talk here. So let me give you an example. I talked about a narrative consisting of factional knowledge, events, and narrative relations. And in this case, I modeled a biomedical scenario. So we have aspirin, a drug that is usually administered as a tablet and which treats headaches. Now, an event might happen. So a patient's treatment with a drug, and in this treatment, aspirin might be used and administered as a tablet and is used to treat the medical condition headaches. This event might cause another event, like a side effect or the observation of a side effect. And this adverse effect might include another medical condition, like some toxicity. So here we see the different components and how they belong to each other. But for now, our narrative model is just a syntactic representation. It allows us to design lines of arguments, but it just in a syntactic way. The next questions are, how can we validate whether the narrative is plausible or not? So in this we means, let us we get a narrative and we are interested in the question if it's senseful or if it's just nonsense. So how can we validate this plausibility here for the narrative? The next question would be, what is shared in the narrative? So what are the narrative semantics? For this talk, I will focus on the first question and investigate the issue of plausibility for narratives further. So validating a narrative's plausibility. We understand plausibility here in the sense of evidence. So we are searching for evidence that supports a narrative's relation. If we reconsider our previous example, then there was a factual knowledge that aspirin treats headaches. This relation could be bound against a database like drug bank where drug information is kept. So this means just we have the relation and we aim to create a binding against some underlying repository which supports the narrative's relation right here. So a narrative binding is basically a link between a narrative relations, like this treatment, and a knowledge repository. This might be a document, this might be a data set, this might be a database. So we just talk about arbitrary knowledge repositories here. That means, in sum, that we understand our narrative model as a logical overlay. Someone can design his discourse in our narrative model on a syntactic level, and then narrative bindings can be used to give evidence for the different parts of the discourse. So for example, here we might see, okay, aspirin treats headaches. It might be a prime candidate to search in a knowledge graph, and we might find an entry in the drug bank or on Wikidata for it. Both events in the center of our narrative have some temporal component. So they happen in time, some patient is treated, and the side effect is observed. This is a prime, these are events and dynamic behavior, and we might find them in some study, for example, where this situation is described. So this narrative relation might be bound against a clinical trial or a study. And the observation of an adverse effect could be bound against a data set where large-scale experiments are performed. So we treat 100 patients with this drug and we observed how many times the side effect occurs or occurs not. So here we could give evidence by binding the relation against a data set. And for this talk, I will stick to these three different kinds of knowledge repositories and discuss the challenges and open problems. So the question for this talk is clear. We have a narrative and a set of knowledge repositories given, and our goal is to compute narrative bindings automatically. So how can we do it? And as I already said it, we consider three different kinds of knowledge repositories. So let me start with the first one, document collections. So we understand a document collections as a collection of text documents. So for now, we completely ignore figures, tables, etc. in the documents. We are just interested in finding bindings from between some narrative relation and natural language text. And we have two different options which we could, or ways which we could go here. So we could go bottom up and perform some information extraction. So we first convert the unstructured information, the natural language text, into a structured information. So maybe into a graph representation. And we could do it in two ways. We could do it by supervised relation extraction, but therefore we have to define the domains and the entities we want to talk about, and this would require training data. On the other side, we could stick or build upon open information extraction, but open information extraction usually results in heterogeneous extractions. So we have a lot of synonyms for predicates. For example, we might have aids and treats, and both stand for a treatment or something like that. So we have to clean this output, and this is difficult. The other way to look at this problem would be top-down. So given a narrative relation, we are interested in finding relevant text for this narrative relation. So we could understand the narrative relation as a query and perform some information retrieval. Prime example would be textual entailment. So we go through text snippets and ask a system whether this text snippet supports a narrative relation or not. And to give you understanding and a feeling how it works, we build a prototype. So a prototype for narrative query graphs, which aim to find narrative bindings against text documents. So let me give you an overview about our prototype. We are interested in biomedical use cases, so we stick to PubMed. We select the subset of PubMed, which contains information about drug. So we have around 6 million different documents in our prototype, which contain information about drugs. Then we perform an entity linking and information extraction and get document graphs. So each document is represented as a graph structure. We clean them and load them into a structured repository. On the other side, the user can formulate her information need as a graph query. So she can say, okay, I'm looking for the information that aspirin treats headaches. Please find documents for that. Then a graph pattern matching is performed. The matches are found and structured visualized for the user. And I call them narrative query graphs because in addition to entities, we allow also variables in this node, in these nodes, and I will show you what this means. So let me go to the prototype. So this is just an overview of our prototype, and now I can enter a query. I can say, okay, I'm looking for information that aspirin should treat headaches. And I could enter this information and perform a search. Then the prototype responds with a set of documents. In this case, we find 44 documents, which supports our narrative relation. So narrative bindings, at least. The user gets a list of these documents, and indeed, he can click on the provenance button, and then the match is explained to the user. So in this case, we say, okay, in this document, we found a sentence where we see headaches, where we see aspirin, and where we see therapy as a connecting relation between both. And that's why we assume that this document might support the given claim. We could also search for other situations. For example, metformin is known to treat diabetes. And if we perform a search like that, then I can click on search and we'll get around 4,400 documents which support the given narrative relation. We can add more fact patterns. So I can say, okay, I'm searching for documents that should include that metformin treats diabetes and that metformin is administered in a dosage form. And instead of saying I'm searching for tablets, I can say, okay, I'm interested in an arbitrary dosage form. So just some dosage form here. And if I click on search, then this string will be interpreted as a variable. So the user is searching for administrations in some dosage form, but not concrete. And then the results are aggregated. So we find 100 documents that contain the information that metformin treats diabetes and that metformin is used orally. We find 553 documents which supports the treatment and that metformin is used as an injection. So here we can get entity-centric overviews over the literature if we play around with variables in our queries. And we also work on an enhanced visualization. So for example, I've prepared a larger example right here. Metformin treats just some disease. Then we could say, okay, let us give the user an overview about how the diseases are structured and which categories are treated. So in this case, our prototype says, okay, we find 6,000 documents which talk about nutritional and metabolic diseases. Then I can click and I can go through the subclasses. So into metabolic diseases, and then I will find the glucose disorders, I will find diabetes, and I will find the specialized versions of diabetes and can go right to the documents. So here I have some taxonomy-based visualization. This was just a small demonstration of our prototype. We currently evaluate the prototypes by performing interviews and questionnaires with 8 biomedical experts and plan to publish the results in future. So this was our prototype, the last live demonstration of narrative query graphs. And now I want to move on to bindings against knowledge graphs. So knowledge graphs have the major advantage that they are structured repositories of knowledge. So typically, knowledge graphs are encoded in the resource description framework. So basically, every information is encoded as a fact. So subject, predicate, object. And we could use query languages like Sparker to find suitable bindings against the knowledge graph. But one problem here is that if we have a narrative, then we have just text labels for the nodes and for the relation. And the first step which we have to do is to link the narrative nodes and relation to precise knowledge graph identifiers to obtain a suitable Spark query, for example. And on this slide, I give you the example that we could link the text label Albert Einstein to some concrete knowledge graph identifier, or map the relation leads to an Wikidata property. But this might be easy in some situations, but there could be a lot of problems on this way. So the major problem is that we have homonyms available. So if we just search for the label Albert Einstein, we will get the corresponding entity ID Albert Einstein, but also the entity ID for his brain, which is a different entity in Wikidata, for example. So here we have to handle issues like heterogeneous issues, like homonyms and more. The next step, or the next kind of repositories, are datasets. And if you have a look at the research of the Google dataset researchers, then you will see that datasets usually do not have a common structure. So we have many different formats, CSV, JSONs, and more. We have no metadata available often, so there's just some CSV dump, but no clear description what different columns means, for example. So these are the common issues if we work with datasets. And to have some starting point, we decided to build an algorithm which works with relational datasets only. So we say, okay, we only care about datasets which have a relational structure, so where the data is encoded into tables. And therefore, we design a two-phase algorithm. So the first phase is to go through the dataset and to understand where can I find the narrative nodes, and where can I find the entities and the events in the dataset. And if we, for example, can identify a row where we have aspirin and headaches identified, then this row might be a candidate, which is used in the second phase of the algorithm to support a narrative relation between both. Then we must understand whether the treatment relation is shown in the row or not. So first phase, find entities and events. Second phase, try to link the relations. But of course, this is just the first step in the direction of computing bindings against datasets, because in future, more data formats should be supported and more. So here's a lot of space for open research. For our research, we see two major applications of narrative bindings. So our vision is that a user can formulate his scientific discourse as a narrative model, and then our system should compute bindings against different types of knowledge repositories automatically. And we see that we can support two major applications with it. So the first one is test a hypothesis. A user has heard some story or has heard some argumentation, and she's interested in whether she could validate the hypothesis or not. So she could write down her ideas as a narrative model, then click on a button, and our system searches for narrative bindings. If we could bind all narrative relations, then the system could say, okay, your hypothesis is valid, we find the suitable bindings. If some relation could not be bound, then this could mean that the narrative is not fully supported or maybe wrong. So maybe there's place for new research, or maybe there's just some nonsense narrative. So this is not quite clear yet. The second part is to infer new knowledge with narratives. For example, if you consider our previous example where we talked about side effects of aspirin treatments, then we could say, okay, let us replace aspirin and the side effect with two variables. And then let's play around. Let's try to use another drug instead of aspirin and try to bind the whole discourse. If we find bindings for the whole discourse, then we say, okay, this pair of variable substitutions fits, and we could support them with evidence via narrative bindings. And if we could not find narrative bindings, then we say, okay, this is a substitution for a drug, but we could not find evidence for it. So maybe it's just not right here. So let me come to a conclusion. We design narratives as logical overlays. We believe that the integration of different knowledge repositories into a single one is nearly impossible. So we argue to keep the sources separated. And then narrative bindings could be used as logical overlays on top of them. So a user can formulate his discourse as a narrative, and our system validates the plausibility by binding it against different knowledge repositories. And in this talk, I show you a demonstration of the automatic computation for narrative bindings, but there are there are many open questions. So the first question would be, how good and how useful are these narrative bindings in practice? So, and this is where we currently plan to investigate more research into. Yeah, thank you for your attention, and I'm open for questions right now.
Yeah, thank you very much, Herman. Very nice presentation and impressive demo also. Yeah, so let me check if there are any raised hands. So Ricardo has a raised hand.
Okay.
We cannot hear you yet.
Can you now?
Yeah. Yes.
Great.
Yes.
Thank you, Yannick. Herman, congratulations for your work. Very interesting. And I also enjoyed the demo part. I was wondering, what do you use an IR model to determine which are the most relevant documents for the query that you issue?
Mm-hmm. We perform an open information extraction and combine the open information extraction with entity linking and a word embedding. So entity linking helps us to precisely identify the subjects and the objects, and we use the word embedding to find synonyms. So for example, therapy is similar to treats, and that's the reason why it's found. Currently, this is just a graph pattern matching right now. So we prepare the extractions and clean them a priori. And in the live ways, we can just find documents which have that fact included. So there is no real information retrieval with ranking there. But we play around with the latest Roberta model for textual entailment and plan to enhance our prototype, for example, by implementing a Roberta-based textual entailment model there. But currently we have no ranking. Every document supports the given claim.
Okay. And that leads me to another question. But before that one, so just for curiosity, for word embedding, do you use a pre-trained model that you fine-tune? Because this is a very specific scenario of applied to medical documents. So I was wondering. So what do you use? I didn't find out during the slides if you use some pre-trained model for the...
We use the pre-trained biomedical word embedding.
Okay, biomedical. Okay, and the other questions related to you were saying that you don't apply no ranking scheme as for now. So I noticed that for some queries you have a huge number of documents that were retrieved, which may obviously be cumbersome for the user. I understand that this is an initial work currently at the part of the demo, but in the future, do you plan to somehow apply some ranking scheme, or at least summarize the information that you are presented to the user?
So indeed, for now, we rank the documents just by their publication date, so latest documents first. But in future, we plan to design metrics which work on the story. So if a fact is contained in the main story, or for example, just in the related work section of a paper. If it's just contained in the related work section of a paper, then this paper should be ranked in the bottom of the list. But I think this could be an interesting component if we understand the document structure, especially if we talk about full text, to rank them with regard to where the fact is mentioned within the story. So does it belong to the main story, or is it just some side information? And this is indeed a really, really big problem.
Yeah, it is. Okay, thanks a lot, Yannick. I think we have here
thanks
some...
for the nice questions, Ricardo. Maybe are there some further raised hands?
It seemed to me so, but...
Yeah, so...
yeah, one from the participants, Florina.
Florina. Okay. You should be allowed to talk now.
Yeah,
okay.
She is now.
Now it should work. Thank you very much for this presentation. It was very interesting for me, and I have lots of questions. but the main questions, which actually has to do with the domain of your work. So you concentrated on this biomedical data and drug things. And my question was, since you're looking at this treatments, do you leverage these PICO annotations like population, intervention, comparison, and outcome? This is very much used in medical publications, and usually you see this already in the abstract of the papers. And related to that, which is actually even more interesting for me, is are you able to detect multi-word terms, like not aspirin, aspirin, but multiple? And do you do that in some automatic way, or do you work with a gazetteer type of list of words?
So maybe I start with the second question. So for the entity linking, we support multiple words, so diabetes mellitus, for example. And if we think about predicates, that's a quite difficult question. We design an own graph-based extraction method. So given a sentence, and we have two entities, we find metformin and diabetes in the sentence, then we perform a dependency pass on that sentence. So we get the grammatical structure of that sentence and perform a shortest path search. And then we look on every word which is connected in the strongest grammatical constellation. And if we find a predicate in that, then we take the fact as an extraction. But we also have a vocabulary for other terms, for special keywords. So for treatment, therapy, or something like that. And currently our vocabulary consists of 60, around 60 terms, yes. Yeah, so this was to your second question. And there we could support words which are longer. And I think the first question
it was about the domain, because what I mentioned about the population intervention and so on, this is very domain specific to the medical documents, to the trip database, for example. They have this kind of information there. But your method might be maybe applicable to other domains, like yes. Let's just take computer science in the information retrieval domain. But I am really very, very skeptical of using text entailments there, because all the methods in text entailments are trained on various data sets, and that knowledge is not transferable. So that's one of the latest results, I think, in the last year, I think, where it was shown that it's extremely sensitive to the training set. So how do you expect that this will behave in your work?
So my goal for my own research is to mostly rely on unsupervised techniques. So don't use pre-trained models. For our extraction pipeline to compute these document graphs, we can mostly rely on unsupervised methods for now. We play around to integrate things like textual attainment, like you mentioned, but indeed we have similar results. So textual attainment in some domains, it works really, really well. And there are some other domains where it's just not applicable, because models are pre-trained and are just pre-trained for a domain and does not work in the biomedical context, or vice versa. I would agree to it. So if we talk about supervised methods, especially pre-trained language models, then it's hard to estimate whether a technique which is suggested for a specific task can be transferred to another domain. And for my research, I try to rely on mostly unsupervised methods. So the whole toolkit of which this prototype was built is currently evaluated or currently under review for a conference. And then if it's accepted, then we will publish our code and hope that it can be transferred to other domains to allow such prototypes, for example, in the computer scientist domain.
That's really cool. I like that. I will follow that.
Yeah.
And my last question was related to the picture you showed on slide 6. And I hope I'm not taking time from other questions. So here, when let's take just the middle leads to arrow. What happens if this leads to actually finds some kind of correspondence also in the data set orange circle, or in the knowledge graph purple circle? Do you disambiguate somehow between these three sources?
This is a really good question. If we would find it, then we would just keep multiple narrative bindings. We do not rank narrative bindings. Then we would say, okay, for this leads to relation, we have evidence in a document, we have evidence in a dataset, and we have evidence in a knowledge graphs. So we would take all of them. But indeed, if we talk about something like these events, then events is a really broad topic, and there are a lot of different opinions on that. Some people argue that events have a temporal component and can only be valid within a story. And some other people, like the Wikidata researchers, for example, put events like elections or other event types into their knowledge graph. So there are a lot of different views upon events and where we could find them. Yeah.
Yeah, I think to maybe just add as a maybe final question on that. So first of all, I think there is probably sometimes the need to take into account negation and speculation when you do information extraction, right? So probably you need to deal somehow with that. But more importantly, with respect to the temporal aspect, I mean, in particular in science, right? So things change or knowledge changes over time. Yeah, and so you basically don't know today what the side effects of some COVID-19 vaccines will be after a couple of years or so. And so the question is, do you somehow try to take care of the temporal aspect, and also in particular when you have maybe conflicting information from the different knowledge sources?
So with regard to your first question, we have a not and a may mode for our extraction. So we can ignore extractions which would contain a not. And for the second part, this is indeed a very, very broad topic. So we have published a paper about that, and we estimate it as context compatibility, because two narratives might completely have a different context. So in this example, tweets can be found here for headaches, but it requires a specific dose. And this dose might not be observed in this study. So to ensure that the different bindings can be used within a single context is ongoing research, obviously. So for some domains, like the biomedical domains, you can fix them and say, okay, we have just those, and those must be in an interval, and then all bindings are context compatible. But this is not transferable to other domains.
Yeah. Yeah, maybe some kind of a slot filling approach. So, for example, if you have like a medicine and it treats a disease, and then you have some slots which are allowed to be empty or not, or something like that, could go into the right direction. Yeah, but again, thanks a lot for this very interesting presentation. I think we are running a little bit out of time. And for that, I think, yeah, once again, thanks a lot. And I would briefly hand over to Ricardo, I guess, and thank the two speakers again. Thank you.
Yeah.
Thank you, Yannick. We are a little bit ahead of schedule, but that was not your fault. It was due to the interesting sessions and discussion we have here during all the morning. When we are a little bit late, but we plan to return back at the schedule, which is about 45 minutes or so. So we still have a couple of minutes for our lunch break. Okay, see you at 2:50 p.m. Italy local time. Okay, thanks. See you. And have a good lunch.
Thank you. See you. Enjoy your lunch, everybody. Bye-bye.
Thank you. Bye-bye. See you in a couple of minutes.
Modeling social media narratives about caste-related news stories. So the first paper will be presented by Alipio. And Alipio,
yes.
If you wish, please go ahead.
Sharing.
The Zoom is all yours.
Thank you. So can you see my slides? Okay, good. So I'll start. So good afternoon, everyone. So it's great to be here in Text2Story workshop. Actually, it's the first time I'm presenting a paper in this workshop. So as João said, the paper is Breadth of Ease. It's a tool in the pipeline for visualizing narratives from annotated texts. It is joint work with Evelyn, Alexandre, Inês, Brenda, Sergio, Purificação, Antonio, and Ricardo. So it's a big team. We are working together, people from computer science, linguists, and we come mostly from Inestec, University of Porto, also Universidade Federal do Rio Grande do Sul and the Instituto Politécnico do Mar, and importantly, Centro de Linguística da Universidade do Porto. So, so narratives, as someone said already in this workshop, they're not. It's not easy to define a narrative. There are different assertions. We are using this one. So it's a narrative text is characterized by the chronological succession of events, causality relations between the events and actors. Narratives are found in many domains, mostly literature, in particular popular culture, like popular sales, journalism, which is our main focus of attention, also in health with diaries, clinical diaries, and in finance and in other domains. So they are important, and they are an important object in our lives for communication and for representation of our wishes and our stories. So it is important to automatically extract narratives from text. So this, as you know, is a challenging and relevant task. And there's a huge lack of densely annotated data. So if you want to go into the details of the narrative elements, the links between the narrative elements, it's not easy to find data corpora that are annotated with this kind of dense annotations. So moreover, narrative annotation efforts are complex and they are hard to validate. So if you annotate at this very dense level, it's very complex and it's very hard and laborious. So in narrative extraction from text, at least in our approach, in our project Text2Story, we identify narrative elements such as actors, events, and temporal references, their attributes, and the semantic links between them. The result is a structure that can be represented in a formal language, for example, and from this structure we can produce different representations such as diagrams or texts. So the advantage of this uniform representation is that we can have multiple ways of representing the narrative afterwards. So the task of corpus annotation is hard and laborious. Here we can see an example of a breadth annotation visualization. So this is what you see if you use breadth. Oh, sorry, I don't know if you're seeing this. This is what you see if you use breadth, and you have to label some elements, you have to link them. So this is the kind of dense annotation that we're talking about. We have actors, we have events, we have the links, so you have lots of links, and after a short period of time, it becomes very confusing. So this is a very short text with lots of annotations. So to annotate, you need first to choose a semantic annotation framework, then to adapt it to a target language, in our case, Portuguese. You have to avoid overloaded notation, although this is hard to avoid in some aspects. And you have to check and inspect annotation because you can make mistakes. So existing annotation tools like Breadth and Prodigy are easy to use. You can find them freely, at least you can use free versions of many of them. So they are great tools, but they do not enable easy verification in this kind of dense annotation situation. So this goes alongside the visualization of narratives. So we see as a final product of narrative extraction the possibility of visualizing the narratives in different ways, so that they can be shown to different audiences. And here you can see an example of a visualization. This is a standard message sequence chart that has been adapted to visualize annotation. So this is from a different work, but we are using the same kind of visualization. So actually, we developed more or less in parallel as this work by Bhattacharya et al. And another work that we found that also is using MSC or message sequence charts. So this is only one possible type of visualization. So in the annotation process, visualization can also be useful because it enables visualization of the result of the annotation, not of the extraction, but the result of the annotation. It can help the annotator to find these errors. So our proposal is Breadth2Viz. It is a tool and it is a pipeline to produce visualization of narratives from annotations, which enables the human annotator to validate the labels assigned. So currently Breadth2Viz is under development. So we have a working version, a demo and code that we are sharing. and it is in developing alongside our narrative extraction pipeline. So this is basically done in 2 steps. The first step is from annotation to formal representation, and the second step from formal representation to visualization. So dividing this pipeline essentially in 2 steps allows us to focus first on the part of the representation, and secondly on the part of visualization, which is done not from the original text but from the formal representation. So Brett2Viz basically supports the high-level visualization of narrative annotation done with Brett. So it is specialized on Brett. It implements this pipeline from text annotation to visualization. Text2Story is the project where this work is included. And we are currently annotating a corpus of new stories in European Portuguese in collaboration with a team of linguists. So the main contributions are an extensible framework to generate visual representations of narratives from annotated texts, and the use of formal logic-based language, discourse representation structure, as an intermediate language to the visual representation, an online interactive demonstration of our pipeline, and available code. So in more detail, from the Brett tool, the Brett annotation tool, we obtain a .ann file. So here in the Brett annotation tool is where all the human work is. And this is the result of Brett. So basically this is a text file with a predefined structure according to the semantic framework that we define here in the configurations of Brett. And this then is automatically transformed into a discourse representation structure, which can then be represented in multiple ways. And we are showing MSC representation, message sequence charts, and knowledge graphs. So one important part is the annotation scheme, which has been carefully defined by us using standards. The annotation is done in 3 levels: referential, temporal, and semantic role labeling. We are using ISO standards that are mentioned here, and we have to do some adaptations of these standards, including in the number of tags and the types of attributes due to multi-layer annotation, properties of the Portuguese language, and also the genre of the corpus that we are using, which are news. So these are normal adaptations that have to be done, but mostly we are using the standards that are defined. So in our annotation scheme, we essentially have 3 types of tags: actors, events, and timex3 for temporal expression. So actors is like a man or an object like a pistol. Events are like robbed, and timex Friday and yesterday, 2020, etc. And we also have attributes with different values for these different categories. Then we have linkage between these objects. We have between the actors relations like referral, like the synonymy, antonymy, hyponymy, etc. Object relations, which are from between linguistic units, and these represent things like, for example, here you have, this is in Portuguese, but this is the assailant, this is the thief, and here you have a link saying that they are the same. So this kind of relation is very important given by the annotator, because it allows us to have information about co-references and different ways of addressing one particular actor. And then we have relations between events and actors, and these are the semantic roles links, and these are important to associate the actors with particular events, like here crime and occurred, the thief escaped, etc. And then we have temporal links that account for the chronological ordering of the events. So all these things are annotated manually, and then what we do in Brett2Viz basically is to first transform this into the representation language, which is DRS, and then to visualize. So the two steps of the pipeline are implemented as two modules. One is brought to DRS, where we go from annotation files to the DRS representation. And the second module, DRS2Viz, where we go from the formal representation to the visualization, and this is deployed as a web application. So in the first module, we parse this .ann file. So you can see here a .ann file. This is produced by Brett from manual annotation. In each line, you have one particular tag. There's an identifier, the tag, the span, and the text that corresponds to this particular annotation. And you have here attributes for this actor. Then you have an event. You have attributes for this particular event, etc. So this is only a small part. So a very dense annotation gives a large number of annotations, a large file, or relatively large file. This is only a small snippet. So from this, we build a dictionary with the linguist elements found, and this dictionary is going to be used to construct the representation, the declarative representation of the narrative elements. So then we have to do things like assigning symbolic variables to each event, etc., so that everything is correctly described in the DRS representation. Then we transcribe to first order logic and DRS. So actually DRS is a specific type of first order logic with some extra declarations. And here is a small snippet of what DRS looks like. So you have an event A. So the information about what is an event, the event A is given before. And then this the event class of A is occurrence, the tense of A is past one, etc. And then you have here a semantic relation with agent T3, which is defined as something. Here we don't see in DRS, but we see here in the .ann, the T3 is a man who is an actor. So the discourse representation structure is something that has been around for a long time. It has been proposed in the linguistics domain, and it allows us to declarative represent discourse. So in our case, we are using this particular structure to describe events, properties, actors, time expressions, or the things that I have referred before. So the DRS is generated automatically from the .ann, and it is a high-level abstract representation of the narrative. So since it is a high-level representation of the narrative, it can be used then to be transformed to different types of representations, so visualizations, or even to generate text in another form, not the original one. And it doesn't require to go back to the original text. Besides, it can be used for reasoning. We are not doing that currently, but we can use the statements in the DRS to perform reasoning at a logical level. So, and this is again the same example of DRS declaring one event named A and some attributes of the event. So the DRS2Viz module, the second module of the pipeline, has this parser component and the visualization engine. The input is DRS, the output are the visualizations in the web browsers. Currently we have MSC and knowledge graphs. Actors are represented as nodes in these two visualizations, and events and relations are represented as links between nodes. So the parser basically extracts these actors, events, and relations and puts them in the adequate structures, and they keep track of the identifiers and the lexical items that represent them. So basically here you see this example, and one important thing to say is that when we are visualizing is that we have to identify the actors. for the nodes, the events for the links. And we also have to identify different words corresponding to the same actor, because in the text the same actor is referred to as different with different terms like thief, man, assailant. So they are grouped together to be in the same node. So we are not selecting for now a single label for the nodes. So basically here we have we can have a group of labels for one particular node. For example, here we have a couple, who, them. So these are different labels for the same node. So this is a message sequence chart visualization. So here we have the nodes, the actors that are involved in this particular narrative. Then there's a timeline that goes from top to bottom. And the horizontal lines represent links, relations between the actors, and they can represent events, and sometimes they can represent relations, like here you have part of or meronymy. So these come from different annotations. So, but the events are here, so you can see that a man robbed in Avenida da Liberdade, which is in Lisbon, and he robbed a couple who was inside a car, and this helps the annotator in particular to visualize what has been annotated. And in this case, you can see potential problems that can happen. For example, here you have in this node a couple, and then here you have again a couple who was inside the car, and this seems to be the same actor. So this is a hint to fix the annotation, go back to Brat and fix the annotation. So this is the kind of information that we want the annotator to get from the visualizations. And the other form of visualization that we have is the knowledge graph. So the nodes you have, in the nodes you have the actors, and the links you have the events and the relations. And from here you can get essentially the same kind of information. So this is a very small story, and it gives this particularly small representation. But if you have a not so large text, you can get a quite large graph or MSC chart, which doesn't fit the screen, so you have to navigate in that screen. So to conclude, Brad2Vs is a tool and a pipeline that visualizes narratives from annotations produced in Brad. It is a two-step modular pipeline, from narrative annotations to the DRS formal language, and then from DRS to visual representations, and currently visualize the narratives as message sequence charts and knowledge graphs. So if you want to try or to extend Brad2Vs, there's an online demo on this URL. You can try our example. So because you need to have them annotated in our semantic framework. You can check out our project webpage and get in touch if you are interested. And you also have a GitHub repository in this link. So the links will be available. They are in the paper. You can find them in the paper, and they will be available in the presentations as well. So for future work, this modular pipeline enables extension and adaptation to other scenarios. Other visualizations that we are currently working on, such as timelines or story trees or icon strips. Other types of representations, for example, simplified textual narratives. So it's a kind of transformative summarization. The annotation scheme can also be adapted to other needs, but this requires more effort. And narrative extraction algorithms may also be plugged as automatic annotators. That's actually what we are doing. So it's more or less the same pipeline, but in the beginning of the pipeline, instead of having the human annotator, you have these automatic narrative extraction algorithms that output the annotation in the same format as the Brad annotation, and this automatically produces the visualization that we have. And if we have different types of visualization, we just have to choose one of them. So thank you. Before I finish, if I have some more time, I can show you just quickly, can give you a view. So I don't know if you're seeing the...
Yeah, we are.
You are? Okay, great. So let me just... Okay, so this is the tool. So this is actually the example that we have in the paper. So this is a very small example that was produced for the paper based on a real one. Here you can try other examples with more text. So for example, this one, actually this is the original text. So here you have the annotation. So as you can see, it's a lot. So this is what comes out from the manual effort. The aim of extracting narratives in our project is to automatically obtain this from the text. Okay, so these elements, and here you have the actors, the events, the attributes, the time references, etc. Some of these elements are quite hard to obtain, so these represent many different problems and many different difficulty levels. Then you have the DRS from this. So this is obtained automatically from the annotation. So here you have first order logic representation and DRS, and you have the identifiers, etc. So actually you can use this, as I said, for inference, because they're basically first order logic statements. This is the MSC visualization, where you can see that now this is a bit larger than the example that I've shown. And this was obtained automatically from the DRS, and you have the graph representation. So this is a knowledge graph. We are using existing libraries for visualization. So we're just putting the information in the correct format so that this can be visualized. And we are currently working in different kinds of visualization. So thank you. Now I finish.
Thank you. Thank you very much, Alipio. So we already have a question from Laura Dietz. So Laura asked, we are currently struggling that open information extraction tools are struggling to understand complexity, complex written text as found on Wikipedia. Can you share your experience on how Brett can handle complex text?
So Brett can, if I understand the question, Brett can handle any text. The problem is not Brett. Brett is an existing tool, existing annotation tool. But then when you want to perform annotation, you have to define your annotation framework, your annotation scheme. So which are the tags, the attributes, etc. And so that's what we have done. So Brett can do it. If the question is, can Brett Viz handle this complex text? You can extract, the aim is to extract actors, relations between actors, temporal references, temporal relations between events, and events. So the annotation framework contains pretty much everything that is necessary for that, including sentiment. So there are also some attributes for sentiment. But the thing is that you can extend the semantic framework. So if you need, that is done in terms of the tool. It can be done on Brett by adding text.
Okay, so we have another question from Pavel Brazdil. So I'm going to let Pavel ask his question.
Sure.
Pavel, please.
Good. Okay. So Alipio, thanks very much. It's interesting. But what is the criteria of success? What is the validation? You know, sort of you finish the project, you will get some network, some visualization, some DRS. So anything that's output is good enough, or do you have some criteria to you know, how do you validate?
Yeah, that's an important and difficult question. So validation can be done first at the level of the annotations. So if you have, we are collecting these annotated texts. So the first thing that we have to do is to check if we can reconstruct the annotation. So this is previous to the visualizations. Then the different visualizations, visualization types, they are oriented towards different audiences. For example, if you have journalists and you are producing infographics like the ones we have seen in the morning in our key talk, of course not that, with that level of sophistication, it would be hard. But if you have, if you are producing automatically infographics from news, then the journalists or a panel of journalists would have to say if these infographics are good or not good, or a panel of readers would have to say if it is working or it is not working. So at that level of visualization, the validation will have to be done with the human panels. Either the people who are producing or being supported in producing visualizations, or the people who are consuming the visualizations for obtaining information.
Yeah. So I think Laura's question and Pavel's question and at least the one I have here popping in my mind is all related, because so if you have a full story with several paragraphs, it becomes too much information, and at some point the visualization tool needs to decide what should be shown and what should not be shown. Like in Google Maps. In Google Maps, we don't have the name of all the small villages that exist, so they just start to show up when we zoom in. And so what would be a good criteria for BratVis to summarize, like I don't know, I'm thinking out loud, okay? So bear with me. So if an actor shows up in multiple paragraphs, then probably that actor should be at the top level visualization. So have you thought about this problem?
Well, yes, we have discussed that, but we haven't done anything in specific about that kind of issue. So one thing is if it is a long text, then you have it is convenient to split the text in scenes. For example, as we were watching this morning a presentation about scene segmentation. So this can be done by looking at location, by looking at time. So you can, or looking at the characters that are, or the actors that are involved in this particular scene. So you can page. So there's some, it's a way of paging your story, and you can have different scenes with different charts. That's what I imagine. So that's one thing. The other thing that you were asking is about the importance or the relevance. Okay? So that's a different problem. It's which are the important events, and that's basically a summarization problem. So you have to determine who are the important actors and what are the important events. So maybe one of the events is not important.
Okay.
And this is also a studied problem with which still needs lots of contributions. We have sort of done that with the Tell Me Stories application that we have, and what we have used was basically keywords. So keywords given a sign of importance to the text, to the sentences, or you can generalize that to events, etc. Or you can try to learn that if you have an annotation about the importance of events and actors. So that's definitely an important question, which I think are two different things. One is the paging and segmentation, and the other is the reduction and summarization.
Okay, okay. So we have one more raised hand. Ricardo?
Yeah. Thanks. Great questions. If I'm allowed to add some inputs, great questions and great answers. And really enjoyed the presentation of Olipio. Indeed, all those questions are related to the difficulty in tackling these problems in long documents, or of the complexity of Wikipedia documents, and that's one of the reasons that. For which we are dealing in this project with very short documents, as is the case of the documents that we are working with, and similar data sets to the ones that we are using are the rock stories, for example. The other thing is that Olipio told that one possibility in the future is to summarize that information using tools such as Tell Me Stories or other similar tools. But indeed, this is a very challenging problem, and you are more than welcome to join us in this task in the future, and to contribute with your ideas.
Thank you very much. I will definitely try this tool. So I don't know if there are any more questions from the audience. Oh, sorry, no. Well, in that case, I think we can move on to the next paper. Is the author here?
Yeah, I have seen him. Just let me.
Prashant.
He was here.
I think he's not
here.
Yeah, he's not a panelist yet.
Yeah, okay.
He just said he's here in the chat.
Yeah, I already promoted. Okay.
Hi, can you hear me?
Yeah,
yes.
We can hear you.
Okay. I will just share the screen right now.
Okay, so.
Can you see the screen?
Yeah.
Okay, cool.
No, but okay, good.
Oh, okay. So hi everyone. Today I'll be
Go ahead.
Okay, yeah. Okay. Hi everyone. Today I'll be presenting my work on modeling a cast. I mean, let me just go back and. So today I'll be presenting my work on modeling social media narratives about caste-related news. Before we get into the details about my work, we need to know about the caste system. The caste system in Indian subcontinent is one of the longest surviving social grouping mechanism characterized by hierarchical gradation of purity. And this has led to systematic discrimination and oppression of many communities. And broadly, as you can see in the diagram here, these are the caste names or the Varna names, which is prominently used, and how the access and ownership to resources and opportunity decreases substantially across this hierarchy is what is shown here. And the government of India has actually recognized historically discriminated communities as scheduled castes or scheduled tribes, often referred to Dalits and Adivasis, who are much more indigenous people, and other backward communities as OBCs as well. So although social media has open avenues for civil society, law enforcement agencies, NGOs, and people belonging to different social groups to raise awareness about caste-based practices that continue to date, the social media also offers space for caste people to perpetuate their prejudice and demonstrate hostile behavior towards specific sections of populations they consider unequal. Some of these casteist tendencies may also arise from kind of privilege, ignorance, or implicit bias, or targeted campaigns. So prior research has primarily actually focused on work related to endogamy and their qualitative interviews and surveys, or even hate speech detection in terms of their casteist ways on social media, or even analysis of caste in newsrooms, to list a few. But however, there's a vast gap between its prevalence in our day-to-day life and sufficient NLP efforts towards understanding or tackling any kind of issues related to casteism in social media. So in our work, we construct a corpus called sensor using a data processing pipeline that aggregates caste-related news stories from mainstream news sources and then maps these news stories to social media comments, basically from Reddit, which is a publicly available data source, and then extract the value judgments or representing different user opinions for a particular news story. Finally, we apply different learning strategies to infer the different value judgments and effectively generate counter narratives. Kind of a goal is to actually generate counter narratives to user generated comments. So these are our threefold contribution in this work. And then going forward, so how we collect our data, I mean, how we actually have this data collection pipeline is basically what we begin to explain here. So for our data collection process, we use two data sources, primarily the traditional mainstream media, which is from the media cloud, is the data, kind of the content analysis platform that we use here. The media cloud actually tracks millions of news stories published online and creates an instant analysis of how digital news media covers the topic of our interest. Notably, a media cloud also allows users to choose media sources or collections and support kind of Boolean queries that match these sources stories as well. What we do next is, like, given those stories from the media cloud, it actually have these, since actually media cloud permits Boolean searches, we construct a Boolean query containing keywords related to general mentions of caste names related to the categories, as I already mentioned, and also government recognized group names like or their abbreviations to look up. And then common references to discriminative practices and also forms of oppression in the forms of caste discrimination or even untouchability or even manual scavenging. And what we do is that, and then we also have other keywords or terms related to the discourse about legal provisions and affirmative actions being available. So what we do is that we, as you can see on the left, there are these specific media cloud queries that you can write, which includes these logical and Boolean operators that you can use. And then as you can see on the right, there is a search term which contains these, you can type in those terms automatically there. And then once you have that, you also can also select the media source that you really want to, which is actually a lookup for the English language specific digital news sources that you want to take a look at, and create a keyword-based search for such caste-related news stories. In this work, we specifically focus on English language news stories for the media collections in India, and then also at both national level news stories and state and local level stories as well. And then what we do is that the figure actually on the right shows the percentage of caste-related news stories normalized weekly over a two-year period from January 2019 to 2021. We know that the peaks refer to kind of key incidents related to the caste that created kind of a national level debate. For example, the initial peaks in the first week of January related to a kind of a prominent constitutional amendment for affirmative action towards a particular set of upper caste community. That's pretty much what is actually shown in the peaks as well. So since we actually use keyword-based source, news stories, keyword-based search, news stories might not be centered around caste yet picked up by this aggregation method due to mere occurrence of some random terms like of the term caste itself. Hence, this collection could contain other stories that are not centered around caste. So we need to clean up this data to actually have a much more reliable source of information related to the caste itself. So what we do is that we actually train a simple binary classifier to identify caste-related news stories. Given that it's actually a pre-processing step, we annotated around 1,000 news articles to verify if it's caste specific or not. So we fine-tune a BERT-based model for this, and then we utilize the representation from the class to a special token, which is the CLS token, and then predict the label probabilities. And then we obtain an F1 score of approximately 89.6%, which is actually better than many of the other baselines. And we apply this classification to the noisy collection that we obtained using the previous keyword-based search method. So with respect to the social media sources, we actually used Reddit for this purpose. And then we use the PushSwift API to collect the data for it. And then what we use is that we also list out the endpoints which we used for collecting the comments related to each of the news stories as well. So what we do is that for those news articles which were shared on Reddit, we use a Python module which actually we are able to access the Reddit's API and extract the user-generated Reddit comments related to those news stories. Next, what we do is that we choose only those Reddit posts containing specific references to URLs from those aggregated news stories dataset. And note that several media houses might report the same incident repeatedly, but however, not all of them get equal attention on Reddit. So the major incident related to those news stories might get discussed with a single reference to the media story. For those news stories, we actually get all the comments and then deduplicate it and then kind of map them to the news stories automatically. And here's the data set statistic that we have at this point. We are able to get approximately 868,000 comments related to different Reddit posts containing the news stories related to the cast itself. And then what we do is that towards interpreting different narratives that news stories might lend itself to, it is important that it is important to understand varied opinions of rightness or the wrongness that the users might express on the social media based on their beliefs and values. This judgment of rightness or wrongness of something or someone or the usefulness of something based on a comparison or relativity is referred to as a value judgment. A value judgment is a claim about something's moral, practical, or aesthetic worth. For example, sentences like, "That's very righteous of you to help him," or "It's unfair to treat someone like that," or even the sentence in this table where it says, "It is good to have an intercaste marriage." All this kind of passes some kind of a judgment or an opinion which is normative, and which means they evaluate things concerning certain standards and norms. Humans linguistically express such value judgments in many ways. So we explored FrameNet, which is actually a tool which is available from the University of Berkeley, California, and to systematically identify and extract comments containing expressions of value judgments. So particularly, we choose abstract frame called a social behavior evaluation, involving a speaker judging behavior or action against pre-existing social standards or beliefs or any type of behavior. So other frames which inherit are highlighted here in blue, like attitude description or beyond questionable, or even like disgrace situation or morality evaluation. All these are different kinds of frames which actually contains lexical units that provide various means of expressing value judgments. So we extract comments from the Reddit comments that we actually aggregated to get different value judgments related to the cast-related incidents reported in the news story. And you can see the table where there are some relevant expressions extracted from the Reddit comments itself, containing lexical units provided in the corresponding frames. And we show that here is the complete data set, data statistics with the value judgments as well, related to the comments that we get. Now what we do is that we get into the modeling, which is actually an ongoing work currently. And so first we begin with the Reddit posts, the comments from the Reddit post related to the news story. And then we feed the comments actually to a universal sentence encoder model. We apply the specific model because of its improved performance in semantic similarity tasks in comparison to other kind of transformer-based model like the BERT. And then we obtain kind of these representations. Since we have like 3 or 4 representations or 3 or 4 comments here, we just are highlighted with the 3 different representations. And then what we do is that once we obtain these representations, what we do is like to identify high-level topics associated with cast discourse with those news stories. We conduct kind of cluster analysis using agglomerative clustering, hierarchical clustering, using position-weighted universal sentence encoder. And then what we obtain is basically, here is what we display, the T-SNE visualization of sample stories and cluster labels tagged manually representative of the most common words present in the stories in the cluster. So, and then what we do is that we extract different expressions of value judgments from their associated edit comments. And then what finally we do is that, for the new stories in each cluster, we extract different expressions of value judgments from their associated comments, and we aggregate and cluster and classify them based on the positive, neutral, or negative tags at the cluster topic level. So we use a sentiment analysis tool called Vader for this purpose, which is kind of a simple tool that, that actually gives scores of positive or negative valence scores. And then based on that, we have positive and negative value judgment expressions extracted from the Reddit comments for some of those categories. And you can see these are the kind of the prominent 5 categories that we get as clusters from this related to the caste-related narratives. And let's say, for example, the caste-based murders, there is an overwhelming negative sentiment, which is kind of understandable that people are overwhelmingly against it. It's not a kind of divided opinion on those issues, but there are still like a lot of divided opinions when it comes to discrimination or intercaste marriages, where people there still believe on one of the sides where they are completely opposed to the intercaste marriages, or even like people do take sides in case of discrimination complaints or new stories about discrimination issues. And as a part of our ongoing work, what we're currently doing is that we investigate ways to identify or generate value judgments by taking in the news stories or user comments and see if it actually contains a value judgment, or what could be the possible position in which it could automatically fall into. And then for this purpose, we actually use any kind of language model or simple transformer-based models to encode the input text for this purpose. And then what we do is that next we are currently experimenting with different controllable generation methods towards generating counter narratives given a news story and a comment and its corresponding value judgment, inferred value judgment. And for this purpose, we actually are exploring 2 methods. One is based on retrieval-based techniques and generation-based methods, where for the latter we are exploring both data and decoding-based methods. These are basically based on pre-trained language models, including a domain adaptive pre-training strategy, or kind of a plug-and-play language modeling work, which actually uses a controllable generation technique to fit in and then operates on a pre-trained language, and by modifying the current and old hidden states to provide necessary control attribute. So our evaluation, what we are actually trying to use is both automatic and manual evaluation metrics. I mean, in terms of the generation, we probably look in for beyond just the automatic metrics like the root scores or kind of the blue scores. We're also looking for how well our model performs in comparison to other kind of pre-trained language models for generating counter narratives. And this is the state of the work at this point. And we hope to produce more counter narratives for different kinds of, beyond just caste-related news, but also for other kinds of news, because this kind of tool is kind of extendable to other news stories and other types of issues as well. Thank you so much for listening, and feel free to contact me on this email address for the progress in this dataset, and dataset will be released very soon. Thank you so much.
Okay. Thank you very much for a very interesting talk. So there is plenty of material for socially related questions and technically related questions. Yeah. So very, very interesting. Yeah, so do we have any questions from the audience? Well, people are still warming up. I will happily start with a few questions. So, yeah. So do you have any idea how many stories are below the radar in terms of your keyword-based crawling?
You're saying that how many stories are missed out?
Yes, yes, yeah.
Okay.
Yeah. Do you have any idea? Because sometimes it's just the implicit bias that exists in a given comment or in a given story. Just the wording.
Yeah, true. I mean, for this, actually, what I do is that we did have like a in-house kind of a team which actually worked on various different kinds of keywords that people might use. I mean, we did consult with journalists as well within the group, where we actually had people who actually include like possible keywords they use later when they actually report a caste-based story. So those are stuff we did have consider, but I mean, I think we do miss out on a lot of regional stories. I mean, regional stories which actually are much more in different languages. Since India has like 20 different languages, official languages, there are lots of news stories which are not getting reported in the English mainstream language as well. So I'm not saying that our data set is going to be complete coverage, but it's going to have a decent number of coverage as much as the English news stories are covering, because we did have English kind of speaking journalists who actually report on stories, and it's from their input that we did collect this kind of keyword base. Yeah.
Okay. And I was also curious about how you classify the pro-cast comments versus the no-cast comments. So how did you do that? Okay. Was it manually?
This specific, okay. Regarding this, I wouldn't say it's pro-cast or anti-cast. It's pro that particular topic or anti-particular topic. So it's more like specific to that positive, and it's more like towards that particular cluster. Within that cluster, is it like a negative sentiment or positive sentiment? In that is what is being conveyed there. So for that, it's not it's more. There's a tool called Veda, which is more of a sentiment analysis tool, and it calculates the positive and negative valence, emotional valence. So that's what is being calculated here. So that's how we do that, and it's an automatic tool. It's not manually done. Yeah. I think I'm muted, yeah.
I was muted. Yeah, sorry. So I see. I understand. So,
sorry to interrupt. There's a question in the Q&A.
Oh, thank you. I was not paying attention to that. So there's a question from Florina. Hate speech is often in mixed language. Do you handle that? That is a.
I mean, at this point, it's English language. Yeah, it's not. We do not handle other languages yet. Yeah.
Yeah. So at least for me, probably one of the most challenging aspects was the value judgments generator.
Yeah.
Could you please elaborate on that, because there's a lot of ethical implications, I would say, about that part of the work. So
yeah.
what can you give us more details?
Yeah, sure. So this one is actually trying to see. I mean, let's say, I mean, people use. I mean, what we do basically is like use these kinds of FrameNet-based lexical units to actually go and identify these lexicons. Each of these lexicons are associated with, let's say, you can see those different the underlined text where you can see what kind of words would be used in this case for situations, or what could be used for morality evaluation. So yeah, there are like lexical units which could be used in certain scenarios. For example, for morality evaluation, you have dishonorable. So it is dishonorable to marry. So it is good. So you use certain specific lexical units for specific kinds of frames, as I mentioned here. So what we do is that we look into these kind of lexical units and their usages in those comments, and try to see what fits into these kinds of framing, and then extract those sentences and the comments which contain them. So those actually form various different opinions that people hold. It's more like beliefs of individuals, which is specific to those people. So it doesn't mean that, let's say for the people who use the morality thing, it doesn't mean the moral values itself, right? Because it is just people's opinion that's being passed on. So that's what we try to emphasize here. So that's why we use like value judgments and not moral judgments here. So that's the difference that we try to bring in. So there's a work recently from social chemistry from LNA as well, which actually focuses on morality, but that is more on ethics and morality, which uses these kinds of similar, I mean, terminologies of, but it's more like manually annotated data set, which they try to use for calculating, capturing those morality, moral aspects, but we use these kinds of FrameNet things to capture the different opinions. So it's more like, how can you use these value judgment as a way of capturing multiple viewpoints towards a particular issue? Is like what we try to do here.
Okay, thank you very much. I don't know if there are any other questions from the audience.
Mm-hmm.
Thank you so much. You mentioned, if I'm not mistakenly, several times the use of a keyword extractor algorithm. Am I wrong? What do you use? Just for curiosity, what do you use in that stage of selecting the keywords?
So as you can see, as I explained earlier, what we do is that there's this media cloud work from our lab as a team. It's actually publicly available in MIT Media Lab, which is MIT mediacloud.org, which actually has which aggregates millions of news stories each day across the world from many other digitally available news stories. So you can actually give like Boolean search queries to it. And then like based on keywords, what you do is that you collect like different keywords that you want to look up and search for. And then you actually combine them using logical operators like and, or, all those different things. And then so you make a search query and then search it. And then you get all the news stories containing those keywords. So that's pretty much.
So I misunderstood. I thought you were using a keyword extractor, but actually you are using keywords on the Media Cloud API. Okay.
Yeah,
I get it. Mm-hmm. Okay, John. It seems there's one more.
Yeah. There is one question from Herman Kroll.
Yes. I'm just wondering about. It's impressive work, but how's the quality of the different steps? So for example, we all know how good sentiment analysis will perform on established benchmarks, but if you apply it on a specific domain, it can have several issues and won't work. And like you said, you perform a BERT-based classification, you have some sentiment analysis. Have you investigated your performance at these steps? Some more details about that maybe would be interesting for me.
Yeah. So what we do is that, I mean, once we actually did that kind of a thing, before we actually started generating, trying to run our generative model for counter narratives, what we're trying to do is like have a mechanical Turk annotation, trying to evaluate, do a manual annotation of how well our model is performing. I mean, identifying those specific narratives. So we have sampled around 1,000 different stories, and also along with their different versions of like different perspectives, like positive, negative things later to that. And we do see like considerably good performance. It's approximately 85% accuracy with those performance at this point of time, but still there's like scope for improvement for that, but it's not too really that bad. So we do have good results out of it at this point of time. And I mean, we'll be making the data set public as well very soon, once we have at the end of this project. So yeah, it will be available for evaluation.
Thank you.
Yeah.
Okay, so I don't think we have any more questions.
Okay. Thank you so much.
Thank you very much for your very interesting presentation. And Ricardo, back to you then.
João, thanks. And I should tell you that we reached the peak of the audience under your charge. So I'm wondering if you should continue or not. We are close to the 50 attendees right now. And
it's the papers, the scientific papers. Congratulations to the authors.
It was also very funny. Adam just noted that we were listening on the background, chickens and birds screaming from your place, which is very, very funny. Okay, so now
apologies for that, but
you don't need to apologize. Now it's time for Mark. Okay, now with a good background, correct, with the correct background, I would say. Directly from Miami, Mark, it's now up to you. Thanks.
Great. Thank you. So I'm chairing the next session, and so it's my pleasure to chair 2 papers from Nitin Agarwal's lab. So can we ask, is Thomas Marco here, or Nitin?
I'm here. Can you guys hear me?
Yes, great. Okay, so we will hear the paper Narrative Trends of COVID-19 Misinformation by Thomas, and take it away.
All right, perfect. So let me just share my screen very quickly. Here, can everyone see that?
Yes.
Okay, perfect. So thank you and welcome. I'm Thomas Marcoux, and this is our work on the narrative trends of COVID-19 misinformation. As you said, this is a work by Dr. Nitin Agarwal's lab, Cosmos, the Collaboratorium for Social Media and Online Behavioral Studies. And this was realized, this is the partnership between our home university, University of Arkansas Little Rock, and the Arkansas Attorney General Office. So this is a work that was realized early last year to address COVID-19 misinformation and provide some tools to to fight it on a computational and a legislative level. So first of all, this is what we are talking about. So we generated what we call topic streams. And the idea behind those was to have a visualization for the chronological evolution of COVID-19 themed misinformation over time. So I added a little sample here to give you a quick idea. And you can see, for example, that if you look at this first graph on the upper left, so these are the misinformation narratives that were linked to these keywords: China, government, lab, Russia, used and created. And they essentially are linked to misinformation pieces that are connected to where the virus came from. You know, was it man-made? Was it a terrorist attack? Was it planned? And what we see, if we look at the chronological axis here, is that these misinformation were very high at the beginning of the year and then went down. And then if we look at that bottom graph here, so this is a graph that is linked to scams, hoaxes, identity theft attempts, basically everyone trying to cash in on the panic. These types of misinformations and false informations were on the rise a bit later in the year. So this is what we've seen. First, discussion on conspiracy theories, where the virus came, and once that dwindled, came the I would say the direct threats to the population, and this is what concerned us in our partnership with the Attorney General. And so this is the motivation behind this study. Number one, we want to help policymakers make informed decisions, science-based decisions based on what type of misinformation they are facing. Number two, of course, we're talking about impossibly large data sets. We could be, and I'll go into details, of course, about what our data set here is for this study, but we could be looking at Twitter posts, millions of them, maybe news titles or YouTube videos, and of course, no single analyst or even fairly large teams of analysts could be looking at all of these entries manually. This allows us to discover some misinformation narratives or latent topics that we could not have otherwise noticed, and etc. This is also useful for not only policymakers, but people like us, the information community, anyone interested in shedding some light on misinformation. So for this particular study, to produce these visualizations, we have created a manually curated corpus. And for this, this was exactly 243 pieces of misinformation. And that were gathered by our data curation team using multiple news aggregators, third-party fact checkers. It's not really, we try not to make it our business of what is truth or not. So we kind of went with the scientific consensus and tried to, cross-check information as much as we could. And this has been made available, the data set, at our COVID response website. So I will quickly show you that so you're able to navigate this if you would like to. This is our website. And so again, this is done in partnership with local legislation. And the main purpose of this was to educate, especially people that are not as digitally literate as others, such as the elderly, or maybe people that don't have access to education, etc. And this is also kind of again made to be accessible, hence the long format, it's like a phone screen. And so here are all of our misinformation pieces. We kept updating that set, so now we're at over 600. And if you visit it here, it's very simple. If you come across information such as, does hydroxychloroquine cure COVID? You have all your information here with some details that tells you where the misinformation can be found, who believes that it is false, and a kind of a long description, as well as this title. And this title is our dataset. So for every single one of these misinformation pieces, we took these titles, as well as themes, because we're trying to compare titles and curated keywords, and we noticed that they perform similarly. So what this means is that we don't need very precise keywords to obtain meaningful results. So because we were able to perform our study with titles, we could extend it to news titles, YouTube video titles, or maybe things like more chaotic, like tweets and comments. And to kind of finish giving you a short tour of this website, it also includes tips that were shared by official sources. So for example here, these three come from the Attorney General's office. And this may seem obvious to, I'm sure, a lot of you, but the core of the study was to kind of educate those that needed most. And also our reports made to the office are available publicly here, and they go into a little bit more detail about this study, which I will explain to you now. Right. So next step, to get into the meat of the study. So a lot of you are probably familiar with topic models, which are a subset of natural language processing. And this is the engine behind this study. I'm sure a lot of you know about it. It's not a new technology. We simply applied it here to our COVID-19 corpus. And the idea behind topic models is, given a usually very large corpus, we try to divide this corpus into n given topics. So for example, I have shown you earlier, given our 243 misinformation titles, we identified one topic that was centered around where the virus came from. So mostly conspiracy theories that were dealing on was that made in a lab is an attack, etc. And then we had this other topic, if you remember, that was dealing with scams and attempts at taking advantage. Hydroxychloroquine is another big keyword that comes up a lot. So as I said, topic modeling, it is a bit of an old technique. So it's originated in the 80s for a very quick history lesson with the LSA model. And we are now using the more recent 2000 LDA model, or latent diacritic allocation. Of course, it is still being, and the reasoning behind this model is because this was kind of this study was a bit of a quick order because of our partnership. And so this was the topic model that I personally was most familiar with at the time. However, we have some newer, more modern models such as HDP and HDLA, which uses a neural network core for much better performances. And this is a very quick look at how LDA functions here. This is very well done. And actually, let me go back for a second. This is a very good Medium article that explains the basis of LDA. But this gives anyone not familiar with NLP a very quick look at the function of this study. So these documents are actually all titles. And here, for the sake of simplicity, they are presented by a token. For example, here on the document 0, we have this little bread picture that is characterized by topic 2. As you can see here, these numbers are probabilities. So this token has a very high chance of being associated with topic 2. And then if you look at the document 0 here, we see that document 0, of course, sorry, it's a little bit hidden by this, has a very high chance of being associated with topic 2. And as well, document 3, that has equal parts of all tokens, is equally spread out among all 3 topics. So this is what it looks like applied to real data. So here, for topic 4, these are our probabilities for each of these rows. And the difference here, and this is the simple method that allows us to create these visualization, is that each document is indexed by its appearance date. It's hard to know exactly when a piece of misinformation surfaced, especially if it is on social media. So here, for our dates, we went by the date that we found an article to debunk it, and usually gives you a pretty good estimation of when that piece of news or fake news has become relevant. And yes, so you can see here the probability chance on the left, on the y-axis, and you can see that these are not very high, and this is usually fine because we're mostly interested in patterns. And I only have one line on this chart, but to keep things simple. But if you want to superimpose multiple topics, so here we have only one topic, but if you want to have multiple topics on one chart, you could see which one is dominant. And as I have shown you early in the presentation, you could see which ones are showing movement over time, etc. And for our future work with this particular tool, so we are very happy with the results. Our partners also thought they were interesting. So of course, first of all, the tool is getting some updates all the time. I just pushed one yesterday. We want to make it public, so we would like, for now, this is a Python app. If you are interested in working with topic models, we used Gensum, which is a famous natural language processing tool in Python. But we want to make this available on the web for the public. Number 3, we will integrate the more advanced machine learning-based models such as HDLA, as I mentioned earlier, a more recent topic model. And as well, I don't know if the presentations are made available, but this is an article that is called topic modeling going beyond tokens, excuse me. And what this means is that we will replace the current method of identification for topic models, meaning that for now, we have these keywords that I've shown you earlier, China, Russia, lab, etc. And this article proposes methods to make these topics more human readable. So instead of having a list of keywords, they would be summarized into one idea, one phrase that is with semantic meaning. So putting all that together, the end goal of this tool is to have public, a very performant topic model that, if you point it towards, say, a Twitter data set, will give you a very meaningful list of topics ideally applied to fake news here for our purposes. And yeah, that concludes our presentation. Thank you for your attention, and I'll take questions if there are any.
Thank you, Thomas. Okay, it seems we have a question here in the chat from Regina. Ricardo, are we promoting these people so they can just speak their questions?
Yeah, we can give them privileges to speak, or promote them to panelists. I'm not seeing her. Who is she?
Regina?
Okay, Virginia, could you please raise your hand so that I can see you here in the list?
Doesn't seem to be in the...
Okay, great. And now we can, Regina. Oh, so Regina is actually going to speak, to present a paper. I'm going to promote her to panelists. Welcome, Regina. You can also speak and ask your question. Thanks.
Regina, are you
Hi
there?
Yeah, I'm there. Sorry, I realized I should have put that in the Q&A. Can you hear me okay?
Yes.
Yes.
Awesome. I just wanted, thank you so much for sharing your work. It was really interesting. I just wanted to know if the tool had any, if it accounted for the evolution of these narratives over time, because I think there was a lot of change in some of these like misinformation claims, or if they were considered to be like separate claims.
Do you mean did they come from the same actors? Did we identify the source of them?
Yeah, and potentially. I think less so about who's spreading the misinformation claims, but simply more like, for example, let's take like some of the like conspiracy theories. Like in the beginning, they said like, oh, who is for QAnon? Like who is Q? Does that, and that was like changing and evolving over time. And so I wondered if your tool said like, this is the same claim, this is how it changed, or if the tool would say like, these are separate claims. Does that make sense?
Oh, it makes sense. So, I mean, well, just to make sure, so you mean, so one single narrative could see changes. For example, I guess to go back to my example in the slides, you would say, oh, the virus came from Russia and then it came from China, but it's kind of the same idea. Is that what you mean?
Yeah,
Okay.
Exactly.
No, unfortunately, no. That's a good point. What I would say that would be considered a topic, because it kind of deals with the same ideas, but so to be honest, no, it wouldn't, because it would group these changes into the same topic. Is how it would behave. Because it's kind of a shift in subject. No, well, or rather, the subject is the same, but the object is different. So it would they would remain in the same topic. Yeah. So sorry to say, we would not be able to catch that.
Okay, Herman.
Yep. Thank you for your great talk. I was wondering about the structure of the narratives. So, for example, there might be some narratives which are partially included in some others. Think about, we say one narrative says, okay, all politicians will insert microchips, and another narrative say, okay, only Angela Merkel will insert microchips. And have you elaborate on that? So did your data set include such relations between the narratives, or did you investigate in the thing at all? So
so not in this study. However, I will tell you this, and I don't know if my lab director may be in the audience. We have a separate tool called Block Tracker that I believe takes into consideration what the questions are sounding like. So what we are working on are narrative tools that are a bit more advanced than that, and that would include kind of a zoom in feature for these keywords. So to take your example, if you went from microchipped, you could select a microchip narrative and then observe your corpus and select keywords such as Angela Merkel or Bill Gates, I think is one. So yeah, very pertinent questions. It is not included in this topic streams study, but we are taking into consideration for future tools.
Okay, thank you. Really cool.
Okay, great. Are there any other questions? Chat here. Adam, do you want to speak your question?
Yeah, just a comment shortly. You can also consider topics over time or temporal embeddings for your future work, except of LDA.
Thank you. I noticed in the chat, I made a note. I will.
Okay, great. So thank you very much, Thomas.
Thank you.
And we'll move to our next talk, also from Nitin Agarwal's lab. Mohammed, you were here earlier. There he is. Ricardo, can you promote him?
Then. Mm-hmm.
Mohammed? Oh, wait, it's restarting, probably.
Can you hear me?
Yes. And Mohammed, you said you had a co-speaker. Is he or she?
He should be online. His name is Haider Al-Rubai.
Haider, can you raise your hand so we can promote you as well?
Okay.
Okay, great. Haider, are you on?
Hey, yeah, I was unmuted. So hi, everyone.
Great.
Hope everyone is doing well.
Okay, great. So this paper is titled Stories from Blogs, Computational Extraction and Visualization of Narratives. And so Mohammed, Haider, take it away.
Can you see my screen?
Yes, we can.
Yeah. So hello everyone. I'm Mohammad Nihal Hussain. And like Dr. Finlayson mentioned, I'll be talking about our paper, Stories from Blogs, Computational Extraction and Visualization of Narratives. So this paper primarily focuses on showing a tool that can be used for visualizing narratives from blogs so that an analyst can look at those narratives and get a gist of what's being disseminated, what's being said in the blogosphere. So after the long day of the presentations of this workshop, I'm sure everybody is very familiar what narratives are, and everybody have a lot of definitions of narratives. So I'll not go over that. I'll briefly explain the narrative extraction algorithm that we use. So this algorithm was published in last year's Text2Story workshop, and we build upon that. And this is being used in the visualization tool that Haider will demonstrate in this lecture. So the algorithm that I'm going to talk about builds on the premise that the narrative text can be represented as directed graphs. By directed graphs, I mean like semantic triplets of subject, verb, objects. So to extract the narratives, the algorithm starts with the blog post. So the blog post could be about an event related to, say, migrant crisis or the Venezuelan crisis or the COVID-related information and so on. So from these set of blog posts, we extract all the entities. We primarily, like I said, we focus on subject, verb, objects. So we are trying to understand who are the actors in this and what are the actions. So to extract those actors, we identify these named entities from the text. Once we have these named entities, we run topic modeling. In this algorithm, we use network-based topic modeling to see the relationship between those entities. But we also intend to use some of the things that Thomas just explained a few minutes ago. Once we have those, the topic modeling done, we have the distribution of entities over topics. And then we also have distribution of documents over topics. Now for each document, that is for each blog post in this case, we extract the most representative blog topic. And for that representative topic, we extract the most representative entities. So by this process of extracting the most representative entity from the most representative topic of the blog post gives us on an average 2 to 5 entities per document. Instead of that, if you would have extracted all the named entities from the blog post, on an average, you would get around 25 to 50 entities per document. So once we have those, we then focus only on these, since these are, like I said, the most prominent entities in the blog post. And we try to extract content from the blog post that is specific about these entities. So generally speaking, we should be identifying a few sentences or multiple paragraphs of text that is about these entities. But for this algorithm, we currently only focus on the exact sentence in which the entity was mentioned in the blog post. So we do sentence extraction, and once we have the sentence extracted, we do phrase extraction. So we try to identify the noun phrases and the verb phrases from the text. To do the same, we use POS tagging. And once we do the POS tagging, we then do chunking to break down the text to get us phrases of nouns and verbs. And then we have a custom grammar rule that was designed for one of the data sets that we had analyzed before. So for that, using that grammar rule, it's giving us relatively decent narratives that will demonstrate in a few minutes. Once the narrative is extracted, these are later scored using traditional TF-IDF. So this way, the narratives that are most common in the corpus are ranked higher as the dominant narratives. And the narratives that are not very common are ranked lower, more like a fringe narratives. So the evaluation data set also comes from one of the previous studies that was published at Text2Story. So this was a data set on the European migrant crisis. This data set contains around 22 blogs, and from those 22 blogs, we were able to extract more than 6,000 blog posts. From those 6,000 blog posts, we extracted more than 30,000 entities. You can go over the paper if you would like to know more about what the data set is about and what were the initial findings, if you visit the Text2Story 2018 website and get details of the paper. So once for this data set that I mentioned, the European migrant crisis data set, we had help from some of our annotators in the lab, and we asked them to extract list top 5 narratives for each blog post. The inter-annotator reliability was around 0.82, so that is relatively very high, indicating that there was very high overlap between our annotators. The accuracy of the model that I just explained was around 67%, indicating that the model was able to extract the narrative on 67% of the narratives from the text. Before I jump into limitations, I'll let Heather give you a demonstration of the tool itself. And after that, I'll give you more details of the limitations and the future study. Heather, you can go ahead.
All right, so I'm just gonna start to share my screen because, all right. You know, I've never used Zoom before, so I'm just giving it a permission.
Never used Zoom. Where have you been?
Yeah, because I have like, yeah, I do have multiple computers that I'm using. So this one doesn't have it. So I just realized.
I see, on this particular computer.
Yeah, so and this, but all right. So I have to leave the meeting and then get again. So sorry about that. Just.
Oh, okay. So
I think he'll be here in a few minutes. So I'll jump ahead and give more details of the limitations part. And once Heather is back, he can talk about the visualization. So the narrative extraction algorithm that I just explained has to be improved. So the grammar rule, like I mentioned, is very tailored for the data set that we use. That was the European migrants data set. But we need to expand it so that it's more generalizable and it is able to extract narratives from multiple about different events. Also, like I mentioned, the current focus in this algorithm is only on the exact sentence where the entity is mentioned. So in the complete post, there might be several sentences where the sentences are about the entity, but they not exactly mention it. So that needs to be accounted and that needs to be added to the algorithm. Apart from that, the visualization, I was hoping Heather would have demonstrated before, because there are a few bugs in that, so we are still trying to improve and fix those. Apart from that, the current the current test subjects that I should say, the students who are evaluating this visualization are primarily have a background of using this block trackers tool already. So they have an idea of how the tool works, the UI and UX on it. So the learning curve was not very high. Whereas if this tool was tested by general audience, the learning curve might be significant. So that we are trying to expand on our evaluation, expand on our test subjects. And as you will see in a few minutes, there are still a few bugs that needs to be fixed. And we are still working on that. Apart from that, the UI is designed in a way that the UI and the extraction algorithm are completely independent of each other. So we are also looking at alternate methods to extract better narratives, like implementing some of the other works that were explained in this workshop today. Once we have any other algorithm, we can directly then feed the output of the algorithm into the visualization tool to visualize those. I would like to thank everyone for listening to me, as well as the funding organizations who have funded our work. I have a few links on this website. On this slide, the block trackers, the link that you see, btracker.host.ul.edu. It's about the tool that Thomas mentioned in the last presentation, as well as the narrative visualization that Heather is going to demonstrate is part of this tool. Apart from that, we have some other tools in the lab that we are developing, focused on YouTube analysis as well as on network analysis. That being said, I hope Heather is back.
Oh. Peter, are you here? I don't see him in the list. Do we need, Hader, can you, if you're in the participants, the attendees, can you raise your hand? I don't see him there either. Okay, well, why don't we move to questions then? I think there was a comment from Laura. Laura, can you raise your hand? Or if you're
Can you guys hear me?
Yes, we can.
All right. I don't know, maybe this was like a little off topic. I think there was sort of like connecting to the discussion with the previous paper. And I think it's sort of like an underlying theme of a lot of, social media processing, in particular narrative detection, is like to use topic models, or like some need of, here's a pile of text, and we somehow want to identify what are the different topics and the different dimensions that's like being discussed here. I want to say a few things about topic models. In particular, I usually don't recommend using them, which is sort of like sometimes a little bit, provocative, but I really think we have better technology now. I think I'm equipped to talk about this because I wrote my PhD about like 10 years ago on the topic of topic models, in particular topic models for social media, topic models for citation graphs, and it's been, I think it's an interesting problem that has been looking at over the course of my research career in, here's a pile of text, how can I extract topics? So, and I think even like, 10 years ago, it was like typically the kind of like evaluation measures that we use, like complexity, they're not really extremely well correlated with what humans would identify as topics. I think they're a crutch, they're okay, but they don't really say, this is a model that really identifies what humans would identify as topics. I think topic models would find something, but they usually find topics that, a blind man with a cane would find. Like if you have 20 news groups, the topics are like so clearly identified that whether you use a k-means clustering, an agglomerative clustering over like language models or topic models, you would all find some reasonable topics. So I think with respect to like finding like really big clear signals, yes, you can use a topic model, but you can also use just k-means. It's probably just as good. And I think, yeah, I think topic models, they had a lot of appeal because they're sort of customizable to like topics over time. We had Dirichlet processes claimed that you can learn the number of topics along with it, which is not quite true. You still have to set a hyperparameter that is essentially determining how many topics you get. And, you know, like networks and graphs could be integrated, which was like what my work was about. So I think what we have today, which is much better, is you use BERT, you use a benchmark for clustering of your choice. And of course, you need to have that, right? Which is sort of like what made topic models so attractive is because you don't need any training data. But as we know in machine learning, garbage in, garbage out, if you don't give it training data, you usually don't get a good model. So the better model is to create some training data, even if it's just little, use BERT, use a Siamese network on BERT, you fine tune that network with your true data. And if you're interested about like some work, there's some work from Niels Reimers and Irina Gurevich from TU Darmstadt who were doing that. And I think their work's called Sentence BERT, and I really recommend to like read it. We currently have a manuscript under publication that does something more to that, especially if you have a particular query or particular topic that you want to know subtopics of. And so that hopefully that's upcoming, and that includes a comparison to topic models on a ground truth where we want to identify fine-grained topics such as like section headings on Wikipedia, for which we can create a large benchmark for training. And on those, we find that topic models do not correlate at all with that kind of like setup. So that's really like the problem where if you want to identify fine-grained topical signals, LDA is just too blunt of a sword to do it. But with BERT, we can do it. And my hunch is that even if you're interested in like larger macro topics, you might be better off, even if you just annotate, let's say, a few text documents with your large scale topics. I think you will probably get a lot better performance than any of the unsupervised models like topic models. And I could go on and on for that. So you have to stop me now, otherwise you get a lecture on topic models.
Okay, we're stopping you, Laura. Okay, I see Hader's back.
Yeah.
Mohammed, did you want to respond?
Oh yeah, thank you so much for your comment. I'll definitely explore that. And I'm sure Thomas is also listening, and he will also look into that and how to use that into his topic streams tool. Thank you for your comment. Heather, you can go.
Hader, would you like to take a minute or two to present your piece now that you're back?
Sure. Yep. I'm sharing the screen right now. All right. Okay. So can you see my screen right now?
Yes, we can.
All right, perfect. So continuing from first, my name is Haidar Rubai, and I'm pursuing PhD in information science, and I'm the second author of this paper and part of the Cosmos team. Continuing from what Nihal had said earlier in the presentation, after the narratives were extracted, we did construct a visualization tool that makes it easy for the user to know which narratives are related to which keywords and which posts mention those narratives, and to explore more into those top 5 narratives. So what we did in the lab is that we built this thing, we have 4 columns. First is the keywords column, as you can see over here, and the narratives is over here, and then the posts, and finally the preview one. As you can see over here, every column can be sorted by date, relevance, or alphabetically, anything. And let's say that we are interested. The first column is the list of keywords that are extracted from those narratives. So let's say that I'm interested in Trump. We can just click on Trump, and we see the narratives that are related to Trump. let's say that we click on the first narrative and we see the posts that are related to this narrative, and we can just click on a post to see the details of the post. And yeah, so as you can see over here in the preview, these are the results. Yeah, so users can also edit a narrative. Just to correct a narrative, maybe, or just to edit it, like they can just click over here and they can just edit the narrative. Yeah.
Okay. Oh.
And yeah, so the narrative was corrected in the database right now. Yeah, and also like, as you can see, this is China. And also users might be like interested in tracking like multiple entities or keywords. So they can just select multiple keywords, and they can just merge those keywords. And as you can see over here, this is a group of the keywords of the narratives, and they can just click on the keyword on the collection, and they can see the narratives that are related to those keywords collectively. And as you can see over here, the BuzzFeed News is taking up the narratives because it's the most prominent out of these keywords, and we can just see the posts that are related to the BuzzFeed News, and these are from the extracted data that Nihal discussed earlier. And the users can also delete items from a group. Yeah, so I have just deleted, like, let's say Americans. Okay, so yep. So that's pretty much what the tool does, but also like users can search for keywords, let's say virus. Sorry. Anyways, it's like, let's say that we click on Zika, and these are the narratives that are related to Zika virus, and these are the posts that are included. Yeah, and we can also make groups out of these. Yep, so this is what we've been trying to do for visualizing the narratives and most prominent narratives. And as you can see over here, we took like the top 5 narratives for this. So, I have to say that our team is working hard on this. It still has some bugs to fix. But in the future, it's a work in progress, and in the future we intend to finish it and make it like more robust.
Okay, great.
So,
Thank you very much.
Thank you so much. Yep.
Are there? Okay, we've got a question from Ting Su. Let's see if I can figure out how to.
Yeah, I'm figuring out how to make this.
Okay. Ting, can I think we're giving you permission to speak?
Yeah, hi. Thank you for your demonstration of this. I don't really have a question. I just have a comment because as you can see from my name, I'm Chinese, and I just feel like this tool is awfully biased against China. And for example, if you search H1N1 CDC Airbus, that was supposed to be like at least 5 years ago, maybe, if I remember correctly. And all about in everything currently you show, it's about coronavirus this year and past year. And when you click the China America Fed and something like that, and all the top posts and narratives are about like China pretty much killed a bunch of Americans because of coronavirus. I just want to mention that that's what I saw from your presentation, and I just want to mention that I think in this case, it might be very important to focus on the bias issue and make sure that the system is not awfully biased, because, you know, it's actually quite a big problems right now about racism and everything, inequality and everything like that.
So Tim, it seems to me this tool is intended to investigate disinformation. So I'm not surprised that there's lots of disinformation in the interface, but I'm a little confused why you'd be concerned about that.
Right, because well, the narratives, I didn't like, okay, sorry, I didn't see that, well, I didn't know this tool is only focused on fake news, like disinformation, because for example, the current one, the show, one Senate Kamala Harris is introducing a bill to address the racial disparity in coronavirus cases. Is that a fake news?
Yes, so
The sources are all fake.
Like Dr. Finlayson mentioned that this focused on the blogs, and there's a lot of misinformation on the blog. So these are not from the mainstream news. So when we extract narratives from the blogs, you tend to get a lot of misinformation. So the tool is intended for the analyst to be able to analyze the blogs and get a sense of what disinformation narratives are being spread out.
Right, okay, sorry, I misunderstood completely. I'm really sorry, but yeah.
And we respect your opinion.
Thank
you.
Do we have any? Oh,
it's
sorry.
wrong. Sorry, I'm not saying it's wrong. We're disagreeing with you. I just like, you know, just
because the sources, all the sources are fake. So yeah, that's why. But even if they say something that is right, but the source is fake. So we just need to know this. But no worries.
Okay, Herman.
So I'm not. Thanks for your talk. First of all, I'm not sure if I missed it, but did you handle paraphrased information? So, for example, now your narrative states that the CDC agreed to publish race. And how do you find matching documents? Just if the phrase is included, or is paraphrased information also handled in some way?
So the paraphrase information is kind of handled. So I would say like I said, we look for the primary entities that are being discussed, and then we extract the phrases around them, and then we merge them based on some similarities. So yeah, the exact phrase that you see might not be in this post that Heather is highlighting, but a similar text would be present in the post. Does that answer your question?
Okay, so you expect that, for example, in this case, CDC is expected to be in the text, but it must not be agreed. It can be some verb which is similar to agree.
Yes.
Okay, thank you very much. Yeah, okay, this handled my question.
Okay, are there any other questions? If so, raise your hand. Going once, going twice. All right, well, thank you very much, Mohammed and Hagen.
Thank you.
That was nice. Thank you. Thank you so much.
And I guess I will turn it back. I'm not still the chair, am I? I am?
We'll no, not you. Thanks, Mark, for sharing the session so smoothly. Now it's time to welcome Bruno Martins. Hi, Bruno, from Portugal, also directly from the University of Lisbon. I have the pleasure, our pleasure, that you join us here, and it's now time for Bruno to share the session, which will consist of one paper. Thank you, Bruno.
Okay, thank you. So, well, thanks again, and it's been a pleasure to be here attending the workshop and now chairing this session. Hope you all attendees are also having a good time. So as Ricardo just said, this is a shorter session, right? So we have a single presentation. So Regina, I think she's here with us as well. Regina works on computational social science at the University of Chicago, okay? And the paper from this session actually focuses on establishing comparisons between different social media sources, in this case Twitter and Parler, and analyzing differences in discourse and in the messages that are exchanged in these two platforms, okay? So Regina, could you try sharing your screen, see if everything is working okay? Okay, okay.
Wow, classic mistake. Can you guys see that okay?
So we're seeing the browser, and now there's another tab with the presentation. So it seems to be okay.
Okay, and it's full screen for you and all that good stuff. Awesome. Okay, so thank you for the introduction, Bruno. I'll be talking about a different story, how conservative narratives diverge between Twitter and Parler. And this work was done in collaboration with Dr. Onur Savish, who I'm not sure if he's here, but hopefully will be joining us for the Q&A section. So let's get started. So on January 6, 2021, months of social and political tension culminated in an attack on the US Capitol. Mobs fueled by election fraud conspiracies broke into the congressional building, and they made their way as far as the Senate chamber and stopped just short of the House floor. New York Representative Alexandria Ocasio-Cortez said in that moment, "I thought I was going to die." And while no member of Congress had any injuries, there were casualties. There was one Capitol Hill police officer and 4 rioters that were killed in what is now called the storming of the Capitol. But how did we, and I mean the US, reach this point? A great many factors initially surrounded and then fed this frenzy. And one of those factors was a chaotic information landscape or election conspiracies, such as the belief that the election was being stolen, mingled with pandemic misinformation, which the WHO deemed as a secondary infodemic. One of the reasons why we decided to look at Parler was it seemed to be an insurrection incubator. While Facebook and Twitter and other social media platforms began to moderate misinformation, Parler really grew in popularity in this time period as an unfettered platform for speech. So what is Parler exactly? Parler, as you can see here, looks a lot like Twitter. Some would say it is a knockoff of Twitter. But we have an example of a tweet versus its counterpart on Parler called a parlay. And those similarities don't end there. There are timelines of posts on both platforms, and then instead of retweets, they have echoes. So Parler was started in 2018 as a free speech platform, hence the name. And by the time of the US presidential election, it was estimated to have about 10 million users, according to the Washington Post. Eventually, though, it was banned from the App Store and AWS hosting. This was after the storming of the Capitol, but it is now back online and in full force as of February 2021. So let's take a little overview of what we'll be talking about today. Our research question is, in what ways do narratives diverge on Twitter versus Parler for conservative public figures? And we broke this down into 3 sub-questions. The first is the content from conservative public figures more or less biased on Twitter or Parler? Do we see divergent behavior from the same group of people? 2, what websites are commonly shared and which of these sites are the most influential? Does this vary by platform? And finally, how similar or divergent are the topics across platforms? And I know we just had a discussion about the use of topics, so happy to take more feedback after the session. So we took a look at a particular population. We were interested in public political figures that maintain accounts on both Parler and Twitter. This included both elected government officials, such as Senator Rand Paul, and it also included media figures, such as Sean Hannity, who is a Fox News correspondent and host. This sample skews heavily US politically right and hyper-nationalists. We did try our best to find a equal group of people on the political US left, but we struggled to find people who were moderated, or not moderated, who were liberal and also had accounts on Parler. We did try a variety of different methods for this paper. We looked at distribution of media bias scores, We created citation networks looking at influence of sources using PageRank, of course. And then we also tried taking a look at the topics using an LDA approach. So talking a little bit about the data collection process, we used the Twitter API for user timeline collection. So any post from a user since they joined the platform, and that ended up with about 28,000 tweets. And then a Parler was a more involved process, and we created a Selenium scraper to do like the headless browsing and to scrape about 1,800 parlays. So a much smaller data set for Parler, but of course it's a much newer platform. And the timeline was all posts on either one of these platforms for these users until December 22nd, 2020. Of course, there were some data challenges, as with the active moderation doing data collection on Twitter and also AWS shutting down Parler. So to talk a little bit more about the media bias ratings, for background, we use media bias fact check, and we extracted URLs from posts and did domain matching to news sites. And then we computed the bias, and our bias range from -10 to 10, starting from extreme left to extreme right. Now this is to represent the deeply divided two-party system within the US right now. And I included on the right a Pew Research graph that just shows some of the variation within the two-party system. And the media bias fact check system that we're using obviously comes with like certain levels of subjectivity. And this is for all like media bias ratings. But it was used in many other research projects, including the Iffiness Index from the University of Michigan. Okay, so tackling the first question, is shared content more biased on Twitter or Parler? We looked at the distribution of these media bias scores, and we found that they skewed more right for Parler than on Twitter. This indicates that on average, websites did share, websites that were shared on Parler, such as news sources, were more likely to be extreme right in their political leanings. This actually aligns with the current characterization of Parler as a haven for extreme far-right speech. However, this characterization does not hold true for every political public figure. So when we broke it down by figure, we saw some interesting patterns. Here's an example with Senator Ted Cruz. He showed a bimodal behavior on Twitter. And he leans right, but also leans center left. And then on Parler, he moves more to the extreme right. For Rand Paul, who is a libertarian Republican, he was also bimodal on Twitter, and he was more, center left, and then to the center right on Twitter, center right to right. And then on Parler, he moves to the extreme right. For Governor Kristi Noem of South Dakota, she showed quite divergent behavior. So on Twitter, she looked to be left and center. Center, I want to say, yeah, she was mostly center and some right. And then on Parler, she was extremely right. And you can see the divergence in this distribution. And then Sean Hannity, who is that Fox News host, he showed absolutely no change on Parler and on Twitter. And that's because he only shared his own websites. So he was a very strong self-promoter in this time period. So taking a look at influence on these graphs, influence through citation graphs, which we generated through the classic NetworkX package. We created a Twitter graph, which had about 643 nodes and almost 900 edges. And the graph that we're showing here is filtered by at least 1 degree. And for context, the color is community, which we'll talk about in a little bit. And then the node size is dependent on influence. And you can see here that Twitter.com was a highly shared source. Obviously, people are talking back and forth on Twitter. And then also based on influence, Mark Levin show. So he's another public figure, and Senator Ted Cruz. They seem to be quite influential according to the citation graph. So we used the Girvan-Newman community detection algorithm for our community clustering. And we found 4 distinct communities. One that was very, very large, it was about 500, and then 2 much smaller ones, 63 and 42, and then finally one small one, which is a subgraph of 4. And then analyzing the top 2 communities, we found that the average media bias to be around 3 and 1. So that's very center or a little bit to the right. And we found this again in the top 2 largest groups. So let's take a look at Parler. Again, what sources are influential on this platform within this community of users. And we created a graph with about 125 nodes, 168 edges. And then this is also filtered by a degree of at least 1. And this time we color coded based on whether it was a source, like a shared source or website, or if it was a user. And the node size is again influence. And we'll be talking a little bit more about PageRank influence. And as many of you already know, this is based on incoming connections to a node with respect to edge weight, or at least in the way that we calculated it. So these are the top domains by PageRank. And we looked at the most commonly shared links and influential sources on Parler, which is this blue graph over here. And we were surprised to see that it included both politically right and politically left sources. So for example, you can see that Newsweek and New York Times were on this list of top domains by PageRank. Now, it's not a super high influence score, PageRank score, but it is at least on this list. On the other hand, taking a look at the top sources on Twitter, we see that there were no left-leaning sources that were considered to be influential. And actually, it appears to be quite right with Fox News, Breitbart, and some of the like West for Texas, which is Alan West, who is another public figure, Republican public figure, his like personal blog. So if we were to offer some interpretations, we thought that this behavior was perhaps due to the nature of Twitter. Because Twitter has a variety of political communities, it's not just a Republican audience. Conservative figures on Twitter may feel compelled to evangelize conservative content at a higher rate. Maybe they're really pushing to convince and persuade people. Another interpretation is that liberal content may be less likely to receive engagement on Parler, and maybe that's why it's shared at a lesser rate. Maybe it's a combination of these two, and it's not an either or situation. So we then took a look at topics and how they diverge by social platform. I think for coming from computational social science and from before that, like journalism and social science more generally, we often do move to topics, topic models, because it's a very intuitive model. I mean, the Bayesian model is easier, I think, to grasp than some of the really complex, like deep learning models, which can be a bit of a challenge for interpretation. But I'm definitely open to learning more about some of the methods that are out there, and I've learned a lot actually from this very workshop. So with the context that we understand that this is a crude hatchet on what might be like a more nuanced problem, we did decide to take a look using LDA, and just to give some characterization, high-level characterization of these posts. And then these models generated using the classic NLTK and GenSim. We did create some coherence graphs here, so we could take a look at the coherence scores as the number of topics increase. And we found that for both, it seemed that an optimal number would be around 10 topics. So here's an example of some of the top words per topic. And then we also did a little bit of manual labeling here, very light labeling. This is for Twitter, and the topic model for Twitter demonstrated a wider range of subjects and topics than Parler's model, which included COVID-19, the election, accusations of censorship and foreign policy. We didn't put those labels here. We decided to keep them like more general for just this viewer for this particular workshop. And then we wanted to focus on topic 4, which here is labeled as Hunter Biden because it explicitly mentions him. And for background, I don't know if everyone's familiar with the whole scandal that erupted around Hunter Biden. Basically, there was a New York Post article that contained a lot of misinformation, disinformation about Hunter Biden during the election. And actually Twitter started to moderate those posts, and any tweet that contained that New York Post article was actually removed. So taking a look at Parler, the corpus was a lot smaller than Twitter's, and it mostly focused on election conspiracies. And topic 0 we thought was interesting because it also focused on Hunter Biden. And through a manual inspection, we saw that it had terms like USB handoff and full suitcase. Both were details of the New York Post story. And so we thought that this was an interesting overlap between the two platforms. So even though topic 4 from Parler and topic 0 from Twitter were both related to Hunter Biden, again, through manual inspection, they were actually strongly decorrelated at a 0.98 index using a Jacquard distance. So it was not very likely that words in one topic would appear in that other topic. This decorrelation of across platform topics may indicate that though users on Twitter post about Hunter Biden, the conversation diverges pretty radically on Parler. Again, this is like a mixed method approach using just the manual inspection of all these different topics. Okay, so moving to the conclusion here, what are some of the takeaways from this? We found that conservative political figures shared content on Parler that leans extreme right, which aligns with current characterization of the platform as a haven for conservative right groups. Despite the distribution of those sources, we did find that liberal sources were more likely to be ranked as influential on Parler than on Twitter. And our topic model analysis indicates that moderation may be one driver of divergent behavior. Again, talking about the different ways that the Twitter topics around Hunter Biden seem to diverge pretty radically from the Parler topic. Now, there's a lot of future work that can be associated with what we've done here. And I also want to stress that this is a pretty exploratory initial work into the platform of Parler. Some of those future questions I'll let you guys read here. Are users more likely to share left-leaning content on Twitter because of the diversity of political communities on Twitter? Or is it because right-leaning content tends to be moderated? Does Parler content lean extreme right because the platform is unmoderated, or more because such content drives user engagement? There's a lot of questions around like user behavior and what are the effects of moderation? And there are also implications for internet speech. You know, as we continue to segregate social media platforms, and we see that with the rise of Gab, Vote, Parler, and others, does this reinforce echo chambers, and what are the effects of those echo chambers? There's also great policy questions around the US Section 230 and the European Union's GDPR, like how to regulate content. And there are also like questions around cancel culture and big tech consolidation. So all this to say is thank you so much for listening, and I hope I didn't run over time.
Okay, thank you, Regina. So there's already a question here. One of the panelists, so in this case, I think Alipio, you can directly go ahead and ask your question.
So, okay, thank you, Bruno. Thank you, Regina, for the great talk. It's great to have this combination of computing and social sciences and the study of civic movements. I have a few questions. Will be selective. So one of them is quite simple. Have you used models for labeling left or right? Did you use labeled data to train models for that? Did you use a pre-trained model? How did you do that?
So we only focus on sources shared by a user because that seemed to be a strong indicator of a particular bias. And it may not be that a user, if a user shared an article, for example, from the New York Times, it may not be because they believe the contents of that article, and they may not be like indicating support for like left-leaning media bias, left-leaning news sources. But rather we just wanted to look at the patterns of sharing of information. So like how do people disseminate information, and what does that entail? What could that possibly mean for the political state?
Okay,
so I think Alipio. So in your work, you use this media bias fact check tool, right? So I think Alipio was trying to ask if you have some clues regarding how that website actually assigns the bias scores. You see?
Yeah, so for that one, they have a group of volunteers that do that, and I think it's not. So I don't know if you guys are familiar with All Sides media ratings, which they use a mixture of like surveys and consensus. For a media bias fact check, I think it's a smaller group of volunteers that do that like manual inspection, and definitely is also it is quite subjective. The reason why we went with that one was because the list was more was larger and more comprehensive, and it also included like more up to date like more up to date sources, and I think after taking a look at some of the ratings ourselves, we were like, okay, we think that this aligns with the characterization. And again, like that is, I think, a part of the mixed method approach of qualitative. But you know, if you have any recommendations for using like the content of posts to create the media bias ratings, please, like happy to take any feedback and suggestions.
Okay, I was mostly interested in knowing about data that has this information already labeled. But as I understood, this is a study, right? So you took the data and you have your research questions and you wanted to answer them. But are you planning to have an online tool that people can actually use and see these things for themselves?
You know, this is one of the, I haven't discussed this with the owner, so I'm kind of going like off the leash here. But in computational social science, one of the things that we struggle with is like, in order to do this work, are we also perhaps exposing more people to misinformation, disinformation? And like, are we also giving them the tools to then like, to really then like to fact check that information and to engage critically with it at the same time? So for example, studies have shown that if you expose a reader or expose a user to misinformation, it takes like 5 more true facts for it to be dislodged. And even after that, they're still going to remember the misinformation because it's novel. It tends to be more novel. They're going to remember that more than the facts itself, even if it's been corrected. So I think there's some ethical considerations to the sharing of what could possibly be misinformation, disinformation. Of course, if owner is online, I don't want to speak out of turn. That's hopefully he might have some thoughts as well. But at the same time, I think that like the tools that we saw, especially from Dr. Arguel's group, I think are really important for policy and decision makers. I think it's just for us, we're still trying to balance some of the considerations. I think it's already a chaotic landscape, you know?
Okay, thank you.
Thank you, Alipio. So, well, if some of the other attendees have a question, you can raise your hand or just write in the Q&A. In the meantime, I'll just ask another one. So, I mean, your work is quite interesting in showing that the individuals behave differently in the two platforms, right? That's really, really interesting. And you kind of also raised some hypotheses for why that is happening. But I mean, at this moment, have you thought about possible strategies to test these hypotheses? I mean, how could you really try to understand what motivates users to behave differently in these platforms?
Yeah, so we're currently going through some concurrent studies around the effects of moderation on Twitter. And we are experiencing some challenges. So for example, even if you pull tweets from Twitter's like its public API, go through like the official channels. If you try to pull tweets from a user suspension period, like the time period where they're moderated, you can't get that information. And the implication for this is, on one hand, that's great, right? Like they're making it impossible to get more like misinformation out into the public sphere. On the other hand, it's really hard to then observe moderation practices. So I think I guess what I'm trying to say is that that's a great question. So I think many of you know that there was like a data dump of Parler. So like all of Parler was like scraped and then made available to researchers and to basically anyone who had it. And that happened actually right in the middle of this paper. We're also debating whether or not to use that data set and to try to do like a much larger scale study of this. But there are, again, like ethical considerations with using that data set. I think it also includes some like personally identifiable information. So I would love to be able to validate these findings further. And I will say that right now our population, our sample population is quite small, and so we're not going to try and generalize this to like a larger group. But if possible in the future, it'd be great to do a large scale study, depending on whether or not we can get that data access.
Okay. Well, thank you again. Thanks to all attendees for listening as well. So I think right now we have a coffee break, right, Ricardo? But yeah,
Correct.
So back to you. So.
Yeah. Thank you, Bruno. And also thanks, Regina, for your great presentation and for raising this interest in the audience. We should have a break, I will say, about 6 minutes, and we should return back to the keynote with Leila Zia, just trying to contact her. And if everything goes well, in 6 minutes, we will return, okay? Thank you.
Okay. Thank you.
Thank you, Bruno, once again. Hi, Leila.
Ricardo,
yeah,
I have to run to go give my talk
okay,
at 11 here. So I hope I can make it back for the wrap up, but if I don't, it looks like it.
Okay.
I mean, great job. And really smooth. I think it was a good selection of papers.
Yeah, thanks for sharing the session and for being part of the organization.
Yeah, my pleasure. I mean, I feel like I didn't do much, but yeah, I mean, you did everything practically, right? You and
it was great to have those discussions, and we still have some things to do, and your feedback will for sure be very important. As for now, we will surely miss the background you have, so you can leave, but stay. Just let the background be there. Okay?
Yeah, this is actually Miami. This is like a
Oh,
particular
you are
hotel
on the balcony. Great. Oh, that's awesome.
on the beach. Yeah, I mean, my view is of the bay, so it's not as impressive as this, but at least people can pretend that I'm not actually near this spot. Oh, hey, Pablo, how's it going?
At least.
All right.
Okay. Also, have a nice talk. Okay. And thanks.
Yeah. Thanks. Appreciate it. Talk to you soon.
Great. Leila, you are here. You were able to log in and to find the Zoom just in time. Awesome.
I am so happy. Can you hear me okay?
We can listen to you very well. Happy.
Okay, that's great. I don't hear you very well, but I think that's my issue. So I'll work on it. I still have a few minutes, right?
Okay. Can you hear now? It's probably some kind of echo, no?
No, the echo part is okay. It's just the volume is not very good. But let me play on my end. I still have a couple of minutes. Is that correct?
Yeah. So you still have. We are just doing some coffee break. This session got a little bit more than expected due to the questions we have. Alipio, in the meantime, will also join us.
Hello.
Hi, Alifu. How's it going?
Hi, Leila. Thank you for being here. Great to have you here.
Anytime. Thanks for bearing with my last minute changes.
And it must be dawn there, right? Still listening to the birds, or is the day?
It's almost 8 a.m. I think, right?
Yeah, you all were super nice to me, so it's actually very comfortable right now. It's 7:45 here in the morning, so
good.
Yeah.
Alipio, you might misunderstood because at the beginning we were speaking of putting Leila at 5 a.m. So we managed to that's why you were saying that it's done.
Yeah. Now I remember. Yeah, you're right. And we fixed the schedule. That was nice. So, are we starting at 45 or?
Yeah, just give 1 or 2 minutes because we have just gone to the coffee break. 2 minutes, I would say, and then we should start.
Or the whatever break.
I think we should start.
The star break. Yeah, so people, I need a break. So I just went out for a while. I brought some water.
And Leila, can you hear Alipio well?
Yes, actually, I had a very basic problem, which was the volume was relatively low from my headset. So,
okay. So
technology got me again.
We are here since our morning, your night yesterday, and we have seen so many good presentations and also keynotes from a Portuguese reference newspaper, and we're very glad to have you here again. And to almost conclude this, you will not conclude because after that we will still have a great presentation. And the awards, the wrap up and the awards. So you will not conclude, but almost. So it's the beginning of the day for you, but almost the end for us.
Yeah, as I was going to bed last night, I was thinking, oh man, by the time I reach these people, it's towards the end of their day. So yeah.
Indeed.
And I do look forward to seeing you all in person. It's I look at the workshop landing page and the beautiful photos and imagining where we could be all together in one place. And yeah, missing you all.
We are missing that part, that social part, and being able to hug people. I miss that. A funny thing today, that's my daughter, she has her birthday today, and I still haven't had many chances to give her a hug.
Congratulations.
The fact that I'm here.
Congratulations.
Happy birthday to her, yes.
Happy birthday.
Thank you, thank you. You know, Leila, here in Portugal, I don't know if in US it's the same thing. It's Fool's Day in Portugal. Is that
yes, April 1st?
April
That's
1st,
how we do it. Yes.
It's the
I
same.
think it's pretty universal.
False Information Day. Yep.
Haider, you are in the right research direction, because you were talking about fake news, so it's False Information Day.
Exactly. So it's our day. We should celebrate in the lab today, but I don't know. Nobody is in the lab. Okay. Yeah.
It's the day where you can informate, misinform, and be fun.
Yeah. And about hugs, we don't have it over here.
We don't have it either.
Yeah, I was thinking about that. Ricardo was talking about hugs, missing hugs, and that. Okay, but we are in a hugging culture, not the whole.
It's true. It's true.
For the record, I'm missing it too, right? I think the last time we have hugged anyone was probably March of 20. Not anyone. I mean, of course, the immediate family is fine, but it's like, yeah, I'm missing other people's.
Me too. So we should restart. I think for the last part of our workshop, I have looked at the Wova app and noticed that we had a cumulative number of more than 100 participants over all day. Now we have the pleasure to have with us Leila Zia, which will have an interesting conversation with Alipio Jorge. Alipio, and Leila, the floor is now yours.
Okay, so maybe we should stop sharing this screen. How do you do that?
I should also add that after this conversation, we also have some times for attendees to participate in the discussion and just some questions to Leila.
So, Ricardo, can you stop the sharing of this?
I'm not sharing. So this is the Margarida. Are you there? This is the SEER host. Okay, she's okay. Thank you, Margarida.
Now we have. Okay, good. So, welcome back to the workshop after this very, very short break. I hope you had time to do whatever you needed to do. So it's a great pleasure to have here Leila Zia. Thank you, Leila, for being here. Leila is the head of research at the Wikimedia Foundation, the people who make knowledge free. So I like this slogan. A foundation that operates Wikipedia, Wikimedia and its history projects. Her research interests include quantifying and addressing the gaps of knowledge in Wikipedia and Wikidata, understanding Wikipedia's readers, and studying the contributor diversity projects. He's been a co-chair of WWW 2019, and she currently serves as the program committee co-chair of the Web Conference 2021, which used to be WWW. She had a PhD from Stanford University in management science and engineering. So thank you, Leila, once more. So the format of this keynote will be conversation, so kind of interview, but also we have here some questions for Leila, but of course it can go in different directions, so who knows. So I'll start with the first question, and since this is a narrative extraction workshop and we are working in NLP, clearly Wikipedia and Wikimedia swim in lots of text. What can natural language processing and in particular narrative extraction do for Wikimedia? So do you use NLP currently? What tools, what techniques or solutions do you use there?
Thank you so much for the invitation and a nice introduction. I'm really looking forward to this conversation, and wave to you all attending remotely. I wish we could be in one place. I'll jump into the question by maybe giving you some context about how Wikipedia, how research and development in the Wikipedia space is being done. I would say Wikipedia and more broadly speaking, other Wikimedia projects. I'll give you the context first and then come back to answering the question. The context that I want you to know is that my answer is going to be incomplete, and that is okay. Wikipedia is part of a broader Wikimedia movement ecosystem, which is a highly distributed network of editors that you see the result of their work on the Wikimedia projects, but also volunteer developers, chapters, user groups, affiliates, and this network, because it's very highly distributed and the decisions are being made in a very highly distributed manner on this network, it is very hard for me to be able to say what exact NLP is being used across the network. What I can comment on are the things that are closer to what Wikimedia Foundation does as one of the entities that does research and development in this space, in this broad Wikimedia space, and puts basically code into production for Wikipedia. So on that front, you can imagine some of the NLP kind of types of tasks being used and the research and development being done towards them on Wikipedia today. But I would say that not enough or not a lot, right? So the examples that I can tell you is Wikipedia is primarily today is giving back more to the NLP community than receiving back, and we can come back to what are the reasons for that. There are some examples that that's not the case. For example, in the search space, you can see that the information retrieval is definitely a space, like how you do search on Wikipedia benefits from the NLP research, the work of the NLP research community, and of course can be improved also significantly. Another example that I can say from our own team is that we have done some research collaborations with Leibniz University in Hanover in Germany, and we have developed a neural network model that can detect which statements in a given Wikipedia article are in need of citation. So generally, editors make a choice whether the statement is common knowledge and doesn't need a citation on Wikipedia, or whether it needs a citation. This is done by humans today. And the question was, can we automatize this process, right? So we have developed a model, and that model is available today in English, Italian, and French Wikipedias, not all Wikipedia languages. And that model is being used by a bot that is developed by a volunteer developer. It's called Citation Hunt. So Citation Hunt uses the result of that model and tries to improve Wikipedia. Maybe another example that can be interesting for your community as an example of what doesn't immediately work, which I would expect to work in the Wikipedia ecosystem, is automatic translation. So automatic translation has improved significantly across the board over the past 15 years, or even more accelerated in the past 7 or 8 years. And we have a hard time within the Wikipedia ecosystem using the automatic translation technologies. Again, like I'll come back to this later, but a lot of the technologies are being developed outside of an encyclopedic space. So the translation is potentially good for language pairs in a general context, but they're not really developed for the use case of Wikipedia, which is an encyclopedia with a particular encyclopedic language. And they also cannot really easily scale to all the different language pairs that we would like to see these systems scale to in Wikipedia. And of course, there's OCR, another branch of NLP that is being used as part of Wikisource, another Wikimedia project, to be able to bring more sources to be used in Wikipedia. I'll leave it at that with some of the examples that exist today.
Okay, thank you. I would like to also suggest to the audience, if you want to ask questions in Q&A, so you can write your questions, and we hope we have the chance to ask them to Leila as well. So please contribute with questions if you like as well. So next question is about summarization and visualization. So one of the things that we like here in this community is to grab texts and transform them into visual timelines and visual summaries. So do you envisage doing something like that in Wikipedia? Would that be useful?
Yeah, so I'll say this is not something that is being done automatically today in Wikipedia, as far as I know. Now, the fact that it's not being done, it doesn't mean it's not useful. Part of it means that we didn't have enough people who had interest in developing such technology for Wikipedia, right? And doing kind of the extra mile of testing with the readers and making sure actually this is useful for the particular Wikimedia languages or Wikipedia languages you're talking about. When I look at the data that we have, we know that depending on which Wikipedia language you're looking at, somewhere between 15 to 45% of the time, readers come to that Wikipedia language to read an overview or summary of an article. So generally, I would say text summarization is something that can be useful for these languages. Now, Wikipedia editors primarily consider the lead paragraph, which is the first paragraph in a given article, as the summary of the article. And one question I put out there for you and your community is, do you consider the lead paragraphs in Wikipedia articles as a summary of the article? Or the technology that you develop gives other leads to what should go in the lead paragraph of an article? And I would start from there and then look into what you can do with timelines. I would also say that Wikipedia is inherently open. So while a particular kind of technology and research representation may not end up on Wikipedia itself, you can have tools or technologies built on top of Wikipedia and Wikipedia data, and you can surface that technology. And I'd encourage you all to do that, because that's a fundamental reason that Wikipedia is open. The data is open, the technology is open, to allow you to do this and not be so constrained to just being on Wikipedia.
Thank you. So the next question is the opposite direction. So what can Wikimedia do for narrative extraction? So in particular, there are great approaches like wikification that the community is using, or entity linking. And what other resources do you have that can be useful for this community of narrative extraction from text?
Yeah, so I'm not sure what are all the different things you know about Wikipedia and Wikipedia data that is available. So I'll say some things which may be repetitive, but hopefully there are things that new for you and your community there. I'll say in terms of entity linking, it is important to not think about Wikipedia itself, but think about Wikidata as a language-independent knowledge base that can basically capture the catalogs, the entity catalogs. I emphasize on Wikidata in this context because I think the language independence is important, and it also allows for the introduction of new entities that sometimes are more limited in the different Wikipedia languages. In terms of what Wikipedia or Wikimedia offers to your community, I will say it's a lot, right? If you compare with what is available from other platforms on the web or on the internet today, there are many choices and options that are available. Particularly, I would say data is something that is available. If you're working with Wikidata, data is under the CC0 public domain data licenses. And if you're working with Wikipedia, it's the CC by SA3. So you can access, for example, the XML dumps of every Wikimedia project, which includes all the content that is available on these projects, all the public content. If you go to dumps.wikimedia.org, MediaWiki APIs are another asset that can be useful for your community. So I encourage you to look into them if you have never looked at the APIs before. There are compute resources available. If you're doing research and development in specific areas that are going to benefit Wikimedia projects, Then Wikimedia Foundation offers humble cloud service operations where you can have access to compute resources. And I encourage you to check out Wikimedia Cloud Services to see how you can use those resources, especially if you're coming from low resource environments and communities. There are research and software grants, I would say, compared to what many of the R1 universities are used to. These are smaller grants. The whole of the grant can be 500K, divided across many research and softwares, but these grants are available for researchers to, in lower resource environments, to use the grants and do research and development for the purposes of improving Wikimedia projects. And I'll say last but not least, what Wikimedia and Wikipedia offers is a volunteer editor community, right? And volunteer developer community that is dedicated and is empowered to make a change across the globe. So generally, I encourage researchers to get in touch with your local language community or local projects and be in touch with these editors, because these are some of the most dedicated people who exist on this planet that I know, that are kind of doing free knowledge for the world, right? And they're passionate to connect with other people and do good. So I generally encourage researchers to get in touch and be in touch with that community, because that's where a lot of the impact and change happens, at the community level.
Okay, thank you. So there's actually one question here from the audience that I will squeeze in, because it's related to this editors community and the editing articles. So this is from a researcher. It comes as anonymous participant. Sorry, there's no name. That works on generating Wikipedia-like articles for topics that don't have one yet. And apparently, this researcher has been warned that uploading such articles violates editorial policies. And the question is, okay, do you have any suggestions on how would, oh, sorry, there's a problem here. Why would need to happen to work towards offering more automation on Wikipedia? So how could the community, researchers community, help in automating Wikipedia with these automatically generated articles, and what problems could arise from that?
Yeah, this is a great question, and I will say I'm going to assume that our anonymous participant has been working with English or one of the other big languages. If that's not the case, please just put it in the comments. So generally what can happen in these very large editor language communities is that they receive, the editors receive a lot of content every second. So on average, we're receiving around 4 edits per second in a language such as Wikipedia, right? So you can imagine that with this flow of information and knowledge coming into the projects and the patrolling burden that is on the editors are a little bit more careful about what kind of content they will allow to go on the projects. Generally speaking, what I've seen working well is when the performance of the model is high. What we as researchers may consider great work in terms of accuracy and performance of 95% may not work with the Wikipedia standards, right? So 5% error can be too high of an error for a community that then needs to go and fix those errors. So I will say, if you want to put automatic generated content on Wikipedia, make sure that you have a solution to what happens to that percentage error that is going to happen. And you need to work that out with the community to see what is the solution. The other thing is that while it is exciting to put content on Wikipedia, I always encourage researchers to think long-term. And this is not something this is not our strength, right, as researchers. So we are excited about research and development and kind of moving on to the next thing. And Wikipedia and the Wikipedia editors need to think about what's going to happen in the next 4 decades when we need to maintain this code and make sure that actually the code brings content on the projects that are useful. So I would say come from the place of empathy and try to acknowledge that there are maintenance challenges and try to address them. And sometimes this is easier to sort out if you work with the Wikipedia editors and the Wikimedia volunteer developers more closely to be able to address such questions. Maybe the last thing I will say in this context is there are particular projects that you can look at where a lot of the content is being developed automatically. So sub-project of Wikipedia, there are, within every Wikipedia language, there are different communities which label themselves as Wiki Project X and Y, right? So in the context of English Wikipedia, there's a Wiki Project group, which is called Wiki Project Gene Wiki Project. And this group is focused on writing articles on Wikipedia and bringing content from the gene and protein knowledge bases basically to Wikipedia. And what they have found over the years is that writing an article about a gene or a protein is something that you can more easily automatize. And they have actually worked this out with the English Wikipedia community. So they have a way of generating content automatically for these articles. So there are ways, but you need to kind of work it out with the community and figure out where are the areas that you introduce the machines, where are the areas that you're going to maintain the control by humans, and how are these two going to do the back and forth with each other in collaboration.
Okay, thank you. So just to clarify, the question was asked by Laura Dietz, and clarify that we intend to ask it anonymously. So moving on to the next question about disinformation and bias. So this is a world full of disinformation, and we are dealing with discussing bias in news in social networks. So I guess that Wikipedia is also subject to that. So how do we handle this kind of phenomenon? Are there injections of fake news in Wikipedia? Do people try to take advantage of that? Is this solved organically? Do you use any automatic tools for this? How do you do it?
Yep, very important question for Wikipedia and Wikimedia. I will say both on the bias front and also on the misinformation, disinformation front. I'll say a few things. One is, yes, there is bias on Wikipedia, and this is acknowledged, right? And this is expected in the sense that the biases that we have in our societies are being reflected on Wikipedia. What is amazing about Wikipedia is that it gives everyone a chance to change those biases, right? So I will say, as researchers, as humans in this world, I encourage each of you to help improve the biases that exist in Wikipedia today. In terms of misinformation and disinformation, yes, Wikipedia does get, it is a subject of disinformation and manipulation of content. This is again acknowledged by the Wikipedia editor community, so that I'm not breaking any news here to you all. And there are systems in place to protect kind of the integrity of knowledge that is on Wikipedia. And I will say we can't have enough technologies, at least for the coming 10 years, to support the Wikipedia editors and patrollers in the work that they're doing. A lot of their work is manually done. Before I go to that part, I will say a little bit about how Wikipedia operates and generally how does it handle disinformation or any kind of patrolling today, patrolling of content. So generally speaking, Wikipedia works based on the assumption that if you give people the chance to do the right thing, the majority of the people will decide to do the right thing. So if you show an edit button to people and you let even readers without logging in to edit, the majority of the people will do the right thing, which is improving the content and making the knowledge better. And this has proven to work over the past 20 years, amazingly. Of course, Wikipedia is not naive, right? So Wikipedia understands that there can be, and Wikipedia editors understand that there can be manipulation of content, there can be mistakes that are done by the editors. So transparency is a big part of what Wikipedia does and is about. Every Wikipedia article page is accompanied by a history page which tells you who exactly at what time has done what edit on Wikipedia. And if you don't agree with that edit, if you think that's not a good edit, you can go and revert it, you can go and improve it, right? There are also policies, content policies that are built in place, such as verifiability of content, which requires content that is not common sense to be backed up by reliable secondary sources, or the no forking policy, which forces editors to agree on how content is going to be represented on Wikipedia, as opposed to having different forks of the same topic, or Wikipedia consensus, which enforces the policy that the editorial decision making is consensus based. These are all kind of different levers that the editors use to try to assure that everyone comes to one place and talk and discuss and understand like what needs to go to a Wikipedia article. All of this being done, the quality of the implementation of these policies is a function of many things: availability of the editors and patrollers, the severity of the attack on Wikipedia, how the availability changes across the different languages, how many editors you have, how many patrollers you have, and this is a challenge. It exists. Now, what machine learning or artificial intelligence or your community particularly can do in this space, I will say I don't have all the answers of what you can exactly do, but I can tell you some of the things that we have seen starting to work. Our team in Wikimedia, in the research at the Wikimedia Foundation, is investing, for example, on aligning statements across the Wikipedia languages. And that's with an effort to try to understand if certain type of content is being represented in certain ways in certain languages, and whether that differs from other types of languages, right? And that can be maybe a flag to start signaling to the patrollers that something may be wrong in a given language, right? Or you can think about another line of work which is around what's called sock puppet detection. The sock puppets are accounts that are operated by the same individual. They can be benign or they can be malicious. And our goal is to be able to help patrollers identify sock puppet accounts more effectively, because sometimes they go into networks and they do organized activity on the projects, and they're very hard to tell, because generally the assumption is good faith and that everybody is doing the right thing on Wikipedia. When it comes to story generation and text summarization, I will encourage you to be creative. So you can think about kind of summarizing text across the different languages and the different Wikipedia articles, and start comparing them with each other to try to understand, are we seeing the same summaries? And if we don't see the same summaries, is that a source of misinformation potentially, or is that a source of bias? How can we help bigger languages with content from smaller languages, and vice versa? And I will say something that is of concern for many Wikipedia editor communities is the issue of language imperialism. And I'll emphasize this because a lot of the research that we see within the research community is focused on English Wikipedia. Or when we go outside of English Wikipedia, we go to a couple of other bigger languages, such as Spanish Wikipedia, German Wikipedia. And we would like to break this cycle. It is amazing to do research on English Wikipedia. Of course, it's understandable. It's one of the most widely read and edited Wikipedia languages. But also, I would say as researchers and as developers, we have responsibility for breaking this cycle. So I encourage you all, especially if you are multilingual speakers, to look at your language communities and look at what you can do in your particular language when you think about the issue of bias.
Okay, thank you. So there's here one question by Adam Yakov that I will take liberty to generalize. So Adam is specifically asking about detecting obsolete content on Wikipedia, and if there is any data set that could be used for that. And I would like to add to Adam's question, if he allows me. Well, I will not wait for his permission. That you mentioned that editors can reverse some edits, and this can also be added by consensus. So this would also be great data sets for the community. So what editors labeled as wrong or biased or whatever. So these kind of data sets with obsolete content or biased content, do you release them, or would you release them?
Yeah, these are great questions. I will start from the second one and I'll go to the first one then. I I will say there is an amazing opportunity to use what the Wikipedia editors are already doing on the projects and use those as labels for data sets. Wikipedia editors by design are very particular. They pay attention to a lot of details, and over the years, they have developed all sorts of technologies to help them do the work that they think is important to do on the projects. There are many templates, for example, that are being used by Wikipedia editors to label content quality or content reliability issues. I encourage you to search for wiki reliability, Wikimedia research on a search engine of your choice, and check out a recent data set that Diego Saez and Miriam Reddy with an intern from our team have released on this topic. So they have looked at English Wikipedia, the maintenance templates that exist on the English Wikipedia, and how these are being used by editors. And they have developed this data set of positive and negative cases of the existence of these templates as a signal for reliability of content or lack of reliability of content in specific areas. So check those out. And yes, generally, I encourage looking at these maintenance templates. To the first question, what I heard was also maybe an implicit question that the templates may be old, and that can be the case. So for example, you may see a citation needed template in a given Wikipedia article while the citation issue has been fixed. And I think there are a lot of opportunities for both identifying missing templates in given languages or in different Wikipedia articles, but also having technology to help editors update, raise a flag and say, this template may have to be removed. I will say if you embark on that path, it is really important to work with the particular wiki project and community that is interested in this, because usually editors are overwhelmed with the amount of work. So if you come with, these are another 10,000 flags that you have to review, the reaction may not be very positive. But if you work with the wiki projects, they will help you find ways, and wiki reliability on English Wikipedia, for example, is one of the projects that is active in this space. You can find ways to basically surface the technology that you would like to develop and support the editors with.
Okay, thank you. So another question here by Sergio Nunes, which is related to the data issue, is if you could detail the relation between Wikipedia and Wikidata, which one should be considered the ground truth?
That's a hard question. So I will say at this moment, so generally the idea is that Wikidata is going to work as a knowledge base behind Wikipedia, and beyond, right? So you will have the type of content that you may never see on Wikipedia in Wikidata, but not vice versa. So this being said, Wikidata is not fully there yet, right? So there's a lot of missing content in this knowledge base today. So I would encourage, depending on the application, to both look at Wikipedia and Wikidata and try to use the information that is available to both of them.
Okay. So you mentioned the language issue and the language diversity problem that is one of your concerns. So I don't know if you already have, if you have said everything about this that you wanted to say, but how do you promote language diversity, and how do you fight this on the field?
Yeah, so I won't claim that my thoughts are very organized on the topic of language diversity. I will say I haven't said everything that I wanted to say. It's an important topic for us. And for me personally, some of you may know I come from the Persian Wikipedia, the Farsi language, and for me, it is one of the more kind of low resource languages that exist in Wikipedia today. I'll say the most important component for us as we think about having content in a Wikipedia language or in Wikipedia at all is to think first about the community of people who are going to come together to write this content. So I will say Wikipedia to me is a place of knowledge, and knowledge is not independent of people. So part of the knowledge is content, but part of it is also about who gets the seat at the table to help develop that knowledge and who helps to bring that knowledge to the world. The choices that we make in terms of what knowledge we bring to the world, these are all important choices. So to me, Wikipedia is not just about the content. It's about empowering people in different cultures, languages to come together and contribute to the knowledge of the world. And when I come from that view, I see a lot of things missing in Wikipedia today, right? With the amazing work that the editors have done, there are, even within the English Wikipedia, you can see the differences in terms of the length of content that exists across the different articles, or kind of the depth that is available, the number of references, the quality of the content that is available. And as you go outside of English as a language, you see major differences, right? One effort that I think is really important, I said earlier, and I'll emphasize, is that as researchers, we have a lot of power in terms of what is going to happen to Wikipedia across the different languages. So I encourage each of you to think about the different languages and how you're going to include them in your research. The other thing I want to say is that Wikimedia Foundation has started investing in this project called Abstract Wikipedia. The project is in its early days, but the idea is, at the speed that the content and knowledge is being generated today, Wikipedia is going to lag a lot. And by lagging, we're basically keeping content away from people who need that content right now. So you have languages with 80 million, 100 million speakers today, which don't have Wikipedia articles in essential topics, right? So if you're speaking Malagasy and you don't have a well-written article on climate change, that is going to be an issue, right? So there are critical places where we need to accelerate content creation and the maintenance of the content. So Abstract Wikipedia is kind of a conceptual extension of Wikidata. The idea here is that we're going to have one content per article, and then we're going to have renderers per language, and then these renderers are being developed and maintained by perhaps a new Wikimedia developer community, Wikimedia research community, and these a combination of a content that is available language agnostic, the renderers, and the constructs is going to help us bring Wikipedia to more languages. You're never going to receive a Wikipedia article via this system, or we don't think you will see a system where the content is going to be available at the kind of human level that you see in some of the articles on the English Wikipedia today. But I expect Abstract Wikipedia to embark us on a lot of natural language generation type of research, and also availability of content down the line in more languages. I'll encourage you to check it out. If you search for Abstract Wikipedia in your search engine of your choice, you can read more about the project, and it can be interesting for your community.
Okay, thank you. So we are approaching the end of our slot. And you already mentioned some future challenges, which was the question I had here to the end. So what are the future challenges? And one of the things you already mentioned, and actually Adam Yatov also asked a question related to that. I will read Adam's question. Some of the articles may not be very comprehensible for average readers. For example, content in specialized domains like physics or law. The Wikipedia project is, however, very small. Are there any works on the side of Wikimedia for making articles, or at least their abstracts, easier to understand? I think you already mentioned that, but that would be great to hear you about.
Yeah, I'll be brief here. One is to say, on English, there is a project which is called Simple English Wikipedia. You may want to check that. And the idea there, and I wish simple exists for every language, is that what if you don't know all the terminology, which is different than the concepts. But the idea there is, let's simplify things for people to understand the content better. Within Wikipedia itself, there's a wiki project called Wiki Project Medicine. And they have been pushing really hard within the Wikipedia editor community to say the lead or first paragraph of articles related to medical content needs to be understandable by people who may not have any background in medicine. So if you read it, you don't want to see like fancy codes, anything. I'm a patient, I'm seeking information. I want to be able to read that article, right? So there are like pushes in specific areas on Wikipedia. I will say from my perspective, it is critical to have different levels of complexity on Wikipedia. As you mentioned, some of the physics articles are the famous ones. Even with a PhD, you may have a hard time understanding what's happening in that article, which speaks to the sophistication of the editors who write that article, but also not tuning that article to the different audiences of that article. So I encourage generally research and exploration in that space to understand how can we have maybe a nudge that can help us understand the complexity of the articles and surface the articles in certain sequences with certain levels of complexity to the readers.
Okay, so another question from Herman Kohl. Have you any good hints on how to practically work with Wikidata? For example, the query endpoint often runs into timeouts if queries are getting more complex. Downloading and parsing the Wikidata dump is obviously often problematic too. My experiences are that I have to work with smaller subsets of Wikidata.
Yes, and I will say requests for improving Sparkle can be something that can encourage more investment in that space. However, I understand this is not resourced enough. So I will say raising awareness about your need for better service on the Sparkle front can be one solution. The other one would be basically taking the data out and processing it out, which I know is not very accessible. As I'm saying this, I know that we're basically limiting the number of people who can use the data. This is understood as a problem. It is the priority of investment in this space, I think, is something that is not favorable or has not been favorable in the past couple of years.
Okay, thank you. So the last question I would say here, at least the one that the last that was put here by Laura Ditz. So Laura is asking, or is she's coming back to the question about different depths in the article. So when different cultures want to discuss the same topics differently, I could imagine a more in-depth discussion on pasta in Italian Wikipedia, and the deeper discussion on sauerkraut in German, which would not be discussed the same way in English cultures.
And is the question how to address this, or?
So the question is if it makes sense to have different different views on the same articles in different language according to the culture.
Yes. This is a hard one. I will tell you my personal view. This is not necessarily the view of Wikimedia Foundation or Wikimedia editors. I think there are certain topics for which it is desirable to have different representation of content and the way the story is being told across the different languages. Pasta can be one example, the kebab can be another example, like for Iranians and Persians. I would say there are other types of topics that are trickier to allow to go across the different languages. And we see the challenges of that happening in some of the languages. So for example, on topics of historical importance, where nations have divided in the past, the question of what is the true version of the article is a hot topic, right? So if you're talking about Holocaust, for example, what kind of topic and how you want that content to be represented across a different language is not answered today, right? So we are leaving that to the different language communities to make a decision about how they want to represent that content. And it's not clear to me that that is the final place we should be, because we are seeing divergences in historical topics and divergent topics that can be unhealthy for Wikipedia and for the broader reader base that reads Wikipedia.
Okay, so thank you, Leila. I will just ask you if you'd like to add some words without any question, anything that is pressing you to be said now, so that we can close our session?
Before, if I can do a question to Leila. So Leila, during our meetings, we have discussed the fact that editors or contributors of Wikipedia may be in the future replaced by algorithms that automatically create the articles, which may be kind of interesting. Consider that contributors on Wikipedia follow a Zipf's law, with a few contributing a lot. From your personal view, again, from your personal perspective, do you find it risky to have this possibility of replacing editors, or instead appealing as a means to automatically enlarge the Wikipedia corpus over different languages, or even probably a mid-term in between the
yeah. So yeah, this is a great question, and my personal view is that we should not advocate for the replacement of humans by machines. I think what we should advocate heavily for is to understand what the human is trying to achieve on Wikipedia and assist the human, the editor in this case, for doing that job in a more efficient or effective way if they choose to, right? This is a volunteer effort, and people come with different motivations for doing that volunteer work. And the replacement of machines can take away a lot of that joy and motivation from people. I honestly do not see the machines to be ready to replace, right? So the quality of content that we see, with the attention to details that we see editors of Wikipedia give when they write content, is not something I can see machines easily replace in the near future. And by near, I mean the next 15 years, 20 years. So what I'm excited about is that collaboration between human and machine, the transparency of the machine for the human to be able to understand what is happening exactly and what's happening on the projects. I think this is particularly important because, to me, Wikipedia is not about content only. It's about the human involvement, because knowledge is not just about content, about this process of you and I talking, disagreeing, agreeing, and kind of trying to shape knowledge. I think this is kind of I can use this as a segue to answer Alipio's last question, to say, to me, one of the most important messages that I would want to leave you all as a community with is that what you do matters. What you do for Wikipedia and other Wikimedia projects matters. And my ask to you is, when you develop technologies, consider to open source that technology, and also consider to publicly, under a free license, open the data that you work with. One of the biggest challenges that we have is that all the fancy technologies that are being developed are proprietary. We can't use them on Wikimedia. We can't use them in our production services because of our commitment to open source, which has good reasons, right? So contribute back to the open ecosystem. And I will say, think from the early on how you're going to do it, because it's, once you develop your research and at the end you think, oh, how am I going to make this open source? You're going to run into a lot of difficulties, because there are a lot of components that you have likely used which have not been open. So consider that. Keep an eye on Abstract Wikipedia. I think it's a project with a lot of promises for your community and things that you may be excited about. And I'll say, if you're interested in Wikimedia and Wikimedia research, Wiki Workshop is going to happen on April 14 as part of the web conference. You can go to wikiworkshop.org and get in touch with us. I think that will give you some more chance to interact with the Wikimedia research community more closely.
Okay, thank you. So any other question? Any other question from the panel or the participants? So the Q&A is not growing now. So I guess we can close. Thank you, Leila.
Thank you
so much for the great talk and the information that you've shared with us. And thank you to Wikimedia for the huge service that you are doing to the world. So it's definitely something that we all use, and we almost feel that it's there since ever, and it's just there. And there's a lot of people working on it and making it happen. It's like magic. Thank you very much.
Thank you all. It's been a pleasure. Good luck.
Leila,
thank you. Thank you so much.
Honored to have you here. So we should now, Alipio. should you hand over to the next session? Shall I do it? Okay, it's now it's time for Sergio Nunes to come by. He's already we have already promoted him a panelist since our morning session. Sergio, are you there?
Yes. Hello.
Great. Okay, so Sergio is coming from the University of Porto, the same university of Olímpio Jorge. We often collaborate together, the three of us, and Sergio was also part of the first edition of the organization of the first edition of the Text2Story. So Sergio, it's a pleasure to have you here sharing this session, which will resort to last presentation of a research paper.
Okay, taking over. Thank you, Ricardo, and thank you for the invitation. It's a pleasure to be here, and congratulations to all the organizers for the workshop. I've been watching throughout the day, and I really think that it has been a high quality event. So congratulations to all of you, to all participants. So we have a last single paper session. The paper is which entities are relevant for the story. Both the authors are here. I don't know who will be presenting, if Pouja Oza or Laura Dietz. I think Laura is already on the panelists, but
yeah, I think it's Pouja. I also promote Laura to panelists, but the information I have is that it will be Pouja.
Okay, so let me know if you have access to screen sharing so you can start the presentation. Okay.
Can you guys hear me?
Yes, and see also the shared screen. So the floor is yours.
Great. Thank you. Hello, everyone. I'm Pouja Oza, and I'm a PhD student in computer science from University of New Hampshire. And the co-author of the paper is Professor Dietz, who is also present here and who is also from University of New Hampshire. So today I'm going to talk about our paper, which entities are relevant to the story. Nowadays, information is spread across various articles or sources. Especially, the news stories are spread across different articles and they span over various timelines, which is days, weeks, or even months sometimes. Sometimes the users have the information need of a synthesized story of various topics, such as the US presidential elections or radiocarbon dating. Construct and present such a summarized story to the users, it is important to capture and understand the different complex relations or connections that are present between the different articles of the story. In our work, focus on the first step of such story construction, which is identification and retrieval of the entities that are relevant to the story. Now, this work resembles entity retrieval task, but it's different. In entity retrieval task, we usually focus on retrieving a small set of entities with high precision. Whereas in our work, we focus on retrieving entities that cover different aspects of the stories. So for example, if the query President of the United States is given to the search engine, it returns the entity Joe Biden. Now, if this entity retrieval is based on the precision, it's more precise. Whereas what we are focusing on is covering the different angles of the story. So for example, if the query radiocarbon dating is given, it should return us information or the entities about the scientists and the laboratories and the chemicals or the compounds that are involved in the process. So in our work, we define the task as, given a query input, we give a list of entities that are relevant to the query. Now, each entity in this retrieved list of entities is associated with a relevant score. We obviously assume that access to a text corpus and a general knowledge base is given. And in our system, we envision two different types of inputs. The first type of input is a short text, such as 2020 US presidential election nominations or radiocarbon dating background history. We define this type of input as a story request. The second type of input is a list of story requests or short text that are connected to a larger theme. So for example, a list of story requests such as radiocarbon dating samples or radiocarbon dating background history are connected to a larger theme of radiocarbon dating. We define this type of input as multi-story query request. So now how do we identify and retrieve the entities that are relevant to the story? We do that by using the relations or connections between the entities. A connection or a link between two entities indicates relevance. And especially for story construction, it is not just about finding a connection, a particular connection between the two entities. It is about finding connections that cover different aspects of the story. The previous work of the entity retrieval is based on the common approach of keyword matching or using entity attributes like entity names, categories, entity links. As stated previously, the prior work is more focused on retrieving small set of entities with high precision, whereas our work focuses on retrieving entities of varying degrees. So we hypothesize that the text surrounding the entity mentions provide a strong indicator about the relevance of the entity. So in contrast to the common approach of retrieving entities by keyword matching, which we refer to over here as KG entity, our approach is based on pseudo-relevance feedback on the entity link relevant text. So we do that by retrieving the text passages that are relevant to the query, and then we use the occurrence of the entities or co-occurrence of the two entities in the retrieved text passage as an indicator of the relevance of the entities. We argue that the entities that co-occur in the relevant text passages are likely to have a connection that is relevant, and thus these entities are also relevant. So we make three different claims. Our first claim is retrieving entities through relevant text passages is more effective than knowledge-based attributes. So in this claim, we demonstrate that the common approach of retrieving entities through keyword matching is not as effective as using the text-based signals of the relevant text passages. Our second claim is that to predict the relevance of an entity, the relevance to relevant text passages is more effective than knowledge-based. So in this claim, we demonstrate that the text-based signals of relevant text passages performs better entity retrieval than the knowledge-based links, such as in links and outlinks. Our third claim is that coupling patterns, such as bibliographic count and co-coupling count, can be improved by using relevance of the shared entities. Now, through this claim, we study the impact of the relevance on the knowledge-based links. I'll explain the bibliographic count and co-coupling count in the further slides. So to demonstrate our claim, we study three different link types: relevant co-occurrence graph, unweighted link patterns, and relevance-weighted coupling. The first link type is a relevance-based approach, and it is based on the thought experiment that if we know the text passages that are relevant to the query, then we can use the text-based signals of these relevant text passages to establish the links between the entities, and also to determine the relevance of these entities and the links. So we do that by retrieving the text passages that are relevant to the query. And after entity linking these passages, we create entity pairs. So for example, in the given text passage, one of the entity pairs would be Martin Kamen and Samuel Rubin. The other entity pair would be Martin Kamen and Radiation Laboratory at Berkeley. So for this link type, we have three different indicators. The first indicator is co-occurrence relevance. If two entities co-occur in the same passage, then we establish a link between these two entities. Now, the weight of the edge or the link between these two entities is done by accumulating this, the reciprocal rank of the passages in which these two entities co-occur. The second indicator is co-occurrence count. It's similar to the co-occurrence relevance, where we establish a link between the two entities if they co-occur in the passage. But the weight of the edge is done by accumulating the frequency of the co-occurrence. The third indicator is mention frequency. In this, we count the number of times the entity occurs in the retrieved text passages. A second link type is based on the knowledge base links. Wikipedia is a large-scale knowledge base, and the relation between the two entities is defined through inlinks and outlinks. So in this link type, we have 6 different indicators, and we consider inlinks, outlinks, bidirectional links, undirected links between the two entities, and we weight the edge between the two entities by its count. The rest of the 2 indicators in this link type is based on the coupling pattern. We have 2 different coupling patterns, bibliographic count and co-coupling count. The bibliographic count is based on the outlinks. So we take the outlinks of both the entities, and then we count the shared outlinks between the 2 entities. In co-coupling count, we take the inlinks between the 2 entities, and then we count the shared inlinks between these 2 entities. The third link type is a hybrid of the knowledge-based links and the relevance-based approach. Now, in the traditional bibliographic count and co-coupling count, there is no relevance factor involved. So we introduce the relevance factor by the scores of the ranked knowledge base entries in this coupling patterns. So we have 2 different indicators for this type of link type, bibliographic relevance and co-coupling relevance. In bibliographic relevance, we have the shared outlinks between the 2 entities, but we weight the edge between these 2 entities by the relevance score of the ranked knowledge base entries. In co-coupling relevance, we have the shared inlinks between the 2 entities, and we weight the edge by the relevance score of the ranked knowledge base entries. So now we have the scores of the entity pairs. So then how do we get the score of the individual entities from that? We do that by accumulating the scores of all the entity pairs in which a particular entity is present. So we do this for every indicator and for all the entities. And then we rank the entities indicator-wise as well as in combination. So we combine the indicators using the learning to rank framework, and we combine the top 4 best performing indicators. To evaluate the ranking of the entities, we use TREC Complex Answer Retrieval Year 1 benchmark dataset. Now, in this dataset, the text corpus consists of Wikipedia passages, and the entity links in the passages are preserved. The knowledge base is obviously the Wikipedia dump. And we use 3 different types of evaluation metrics: mean average precision, R precision, and F1. So now, as stated previously, we have 2 different types of inputs. Now, the first type of input is story request, and we have 1952 such story requests in our TREC-CAR Year 1 benchmark. So let's see the results. Okay, so our first claim was that retrieving entities through relevant text passages is more effective than the knowledge base attributes. So looking at the results, we see that the indicators of the relevant co-occurrence link type, which consist of co-occurrence relevance, co-occurrence count, and mention frequency, perform better than the common approach of keyword matching, which is KG entity. The second claim is that the relevance to relevant text passages is more effective than knowledge-based links for predicting the relevance of an entity. Now, again, if you look at the indicators of the relevant co-occurrence link type, which consist of co-occurrence relevance, co-occurrence count, and mention frequency, they perform better than the knowledge-based links, that indicators that consist of undirected bibliographic count and co-coupling count. Our third claim is that the coupling patterns can be improved by using the relevance of shared entities. Now, for this claim, we got mixed results. As we can see that the co-coupling count improved when we introduced the relevance factor, but the bibliographic coupling pattern did not improve when we got the relevance factor. The second type of input is a multi-story query request, which consists of multiple story requests that are connected by a larger theme. Now, the results of multi-story query request are formed by combining the results of the story request that are associated with this theme and that are given as an input in the list. In TRECCA year one benchmark, we have 132 such multi-story query requests. Looking at the results, we observed the same pattern that we did for the story request for both claim 1 and claim 2. The text-based signals performed better than the common approach of KG entity, as well as the knowledge-based links. For claim 3, which consists of coupling patterns can be improved by using relevance of shared entities, we also observed the same pattern that we did for the story request. So even over here, as you can see, the co-coupling pattern improved by introducing the relevance factor, but the bibliographic coupling pattern did not improve. We suspect the reason to be the small number of n-links. So to conclude, the relevant text passages are proved to be a strong indicator as compared to the general purpose knowledge-based links. It improves the result between 80% to 30%. And the relevant text-based signals, especially the co-occurrence relevance, is more effective for retrieving the relevant entities of varying degrees. We would like to thank NSF for supporting our work through the career grant. Thank you.
Thank you, Pooja, for such an interesting work and excellent presentation. I will ask participants to post your questions on the chat or the Q&A forum. One quick question or comment. So your goal was to address let us say, the diversity of results when retrieving entities, right?
Yes.
Okay, and have you made any user study, or do you have any insights on how users would value such diversity in contrast with non-diversity, with higher relevant results? Because you use QRLs from the track task.
Yes.
But those QRLs were not evaluated for the diversity. Do you think that can have an impact on the quality of your evaluation?
So the queries in the track are consisted of the entity links that are present in the Wikipedia articles. And if you look at the Wikipedia articles, they usually consist of the entities of diverse, that covers all the aspects of the story. For example, the passage that I was referring to talked about the scientists and the laboratories, as well as the chemicals that were involved in that process of radiocarbon history, radiocarbon dating history. So the queries itself consisted of diverse entities.
Okay. Okay, so the evaluation was in line with your experiments. Oh, another comment is if you think that your approaches for diversity generation would be useful in other contexts, or if you are considering using them in other contexts, like finding out if a story is generating a lot of opposing views or opposing or contrasting comments by mentioning different entities or different concepts. Do you think that could be applied?
Can I quickly jump in? I'm sorry. I think
Sure.
there's a little bit of a misunderstanding between, and I want to clear it up. So we are not doing user studies, but we are using curals that are verified by track assessors who are users.
Yes, I understood that. I was my initial, yes.
And
So,
in
sorry.
particular, kind of like the cural files that Pooja worked with mainly were actually just like harvested from Wikipedia. So what we're doing is we kind of like reconstructing Wikipedia pages that already exist, like the one on radiocarbon dating, which have entities that were mentioned by Wikipedia editors, who are also humans, who decided that certain entities would be important to mention in the context of this topic. So this is sort of like where we take the diversity that a Wikipedia editor decided was important. And it's, so this is sort of like where we kind of like think it's okay to say that humans will kind of like appreciate this diversity.
Okay.
I mean, it's the bigger direction that we're going. I mean, our goal is not to show these entities to any end users directly. I don't even think that end users can deal with lists of entities if you don't give them a context of a story. But the idea is to first, if we would know which entities are important for a story, we could then go out and find text that sort of like corroborates the story and explains how these entities are sort of like relevant in that context. And then we can actually produce a story. We can generate a story that then a user can look at. Unfortunately, you can imagine it's not work that can be done in a single paper. So this is like step one. Stay tuned for step two.
Okay, thank you. Much clearer. So you have not used the curals for evaluating the diversity, but the mentions made by Wikipedia editors, right?
Correct, and they are
Yes.
verified by track assessors. So we
Okay.
have sort of like both, you know, the.
Okay, Alipio has raised his hand, so.
Hi, yes, thank you. So thank you for the presentation, Pooja. That's very interesting work. I have a very specific question. So part of your problem is determining the relevance of entities, right? And you have you implicitly define a graph of entities using co-occurrence. Do you use centrality measures as possibilities for determining entity relevance using that graph? And do you consider using other forms of building the graph, for example, through semantic relations between the entities using semantic role labeling, for example?
Sorry, can I also jump in? Sorry, I didn't mean to take this away from Pooja, but Pooja didn't do that in her work. But in like other work that we've looked at page rank, personalized page rank, attribute-centric page rank, all kinds of page rank variations. We even like tried to learn to train page rank, how to combine different indicators to make better page rank walking decisions. The results are abysmal. And the results are abysmal because the knowledge graph is super, super, super dense. Like my point is, I think maybe in like 2013, PageRank worked on Wikipedia where Wikipedia was rather small. But now it's 2021 and Wikipedia has grown, and that's a good way, in a good way, right? So we have like much more diversity and also like not just head fact, not just the most important facts, but like various kinds of like other facts in there. But these are kind of like messing with PageRank. And this like known that PageRank was like prone to being attracted by these like communities, tightly linked communities. And this is sort of like why PageRank on Wikipedia, it performs even worse than the KG entity, which already like doesn't perform particularly well.
Okay, so it's important to keep it simple. Light, I mean.
I wish that anything that we would try, you know, we had like great hopes for the bibliographic methods, and they also kind of like were disappointing, and I think for like similar reasons. And it's in some ways the paper is a little bit frustrating because like something that's like really dead simple, like the most, you know, IR centric thing that pretty much like ignores the knowledge base other than having something to link to, kind of like works the best, which is like really frustrating. We've been banging our heads against this. So if anybody in the audience has any other suggestions, we are more than happy to look at it.
Okay, thank you, Laura.
Okay, no questions from just by now. So, but one comment or question is if you did any characterization of your explorations of Wikipedia, in the sense to understand which pages would have a more diverse set of entities. Do you have any comment or insight on that? Because based on your measures, on your metrics, you could try to find out which topics are more diverse in the sense of mentioning more different entities or a larger scope of entities. Do you think that would be interesting to assess or evaluate?
It is certainly an interesting point, but at this point of time, we have not done that. So it can be looked into for the future work. Yeah.
Okay, one hand raised by Herman Kroll.
Yeah, thank you for your great talk. I'm just wondering about how is your task different, for example, from entity summarization? So I know entity summarization is based on knowledge graphs, but you have some similar things in there. For example, you are looking to consider properties or entities which are very diverse and which should be mentioned in the same context. So I see a lot of similar things between both tasks, and I'm wondering if you could comment on it, maybe.
You want to take this?
No, if you want, you can go ahead, Laura.
I don't know. Well, thanks for bringing this up. And we haven't really looked at it, but then on the other hand, all of the knowledge graph links didn't really work at all in our context. I mean, for us, it was like, here's a story request, which in our case happened to be also a Wikipedia article. So you can take the story request as an entity if you wanted to. Okay. So now, but what we show is that using these links that are available in knowledge graphs are often not helpful at all. So, and I think that there's an important distinction. Like I think the entity summaries using knowledge graphs, they will work a lot better if your entities are people and organizations or places. In our case, our stories were also of like general purpose topics. They were actually selected to be not temporal events, to be not people, to be not organizations. But like from the rest, from the other part of Wikipedia that's like usually not studied that often. And for those, the links were kind of like not that helpful. And we used actually directly the links from the Wikipedia pages because we found that the links that you would, for example, get through DBpedia were really like way too sparse. There weren't any really in there. But I think it's an interesting point, and I'm happy to discuss this more maybe offline with you.
Yeah, I really agree to your statement. I think the major difference here is that if we work with knowledge graphs, then we have labeled relations between entities. And if we stick to text, we don't have them. And we know why, because open information extraction cannot do it. And for information extraction, we would have to, need training data. So this is really a problem, I think. Yeah. Thank you very much.
I 100% agree with you. I mean, we've been, especially Pooja has been looking into using various OpenIE with and without coreference. And it is really difficult because OpenIE's extraction is tuned for high precision. So on the topic of radiocarbon dating, if we get like 10 relations out of it, we just can't really do anything with it. So a while back, I actually looked at knowledge, like known relation types. And I think that was with DBpedia. And I think the moment where you leave the space of relation types, where DBpedia is really good for, which is like people and organizations, you're not getting any, like there's not a lot of typed information about how entities, like for example, how is fertilizer and algae blooms related in DBpedia? This information is like often not there, which is like the other problem. So if you have any ideas, any solutions, I'm more than happy to discuss this.
yeah, maybe we should move the discussion offline, because I'm working the last year on canonicalizing the open information output and how we can do some tricks there, but there are a lot of major problems which must be solved in future. Yes.
Yes, and we see them too.
Okay, I see one question in the chat from João Magalhães. I don't know if you can ask directly, but I can read it.
Sure, I can.
Okay, so just go ahead.
So, hi, Pooja and Laura. So great work. So we've been doing similar work with named entities, and we've been going through some similar pains. So have you observed any impact of the information extraction quality? So the named entities that you extract from the corpus and from text, in terms of recall / precision, the linking, the named entity linking.
Pooja, I'll let you clarify this.
Okay, so over here, we are just using those entity links that are already present in the Wikipedia passages of Wikipedia. So we are not using any external entity linker for this work.
But I mean, but you use some entity linker to get a higher rate of links. Maybe you want to tell a little bit about your experience.
Yeah, sure. So in other work, in other experiment, I used the WOT entity linker along with the Wikipedia. But while it gave me some good entity links for some passages, it was not, the difference was not that great. And it did not improve the result as much as we expected it to.
So so at least from our experiments, so using WOT and similar, we got noisy entities.
Yes.
And also possibly low recall as well. Some entities that were not properly linked. And what the best result that we got was actually when we combined the results of 2 entity linkers. That was the best. So one was more recall oriented, and the other one that is more let's say machine learning type of system. They achieve higher precision, but the recall is not so fantastic like with the other. And so a combination of the two things, of 2 entity linkers, was the best result.
Yeah.
So, please.
Yeah, that's a great point. Actually, we did not try to combine these two and then work on it, but I think it would be interesting to see how the combinations of different entity linkers would work out. Yeah, that's a good point. Thank you. I'll work on that.
But Pooja, didn't you look at DBpedia Spotlight entity linker combined with what?
No, that was just in the relations, not the, including all the entities. Yeah, that was for
so, I
the
mean, in this work, we kind of like take the easy way out around that, because the track car collection is sort of like harvested from Wikipedia pages. We take all passages that are on Wikipedia, and these passages already very comfortably have entity links provided by the Wikipedia editors. So we use that instead as like an idealized form of an entity link. I mean, it's not perfect because Wikipedia editor policies say you're only supposed to link the entity the first time. So if you have a passage further down in the article, it might not link an entity because it was linked further up in the page. But at least we can rely on the entity links that are there to be correct.
So you end up with high precision and very low recall.
No, it was actually not. It was not that low recall. I think the entities that are missing are maybe the ones that are very frequently mentioned on a page. I think most entities on a Wikipedia page are mentioned like probably once, but there are a few, like unfortunately the central ones, which are mentioned only once. And those we might be missing in later contexts. But because we retrieve first we retrieve passages and then we get entities out of there. We usually get these entities through other passages.
But how okay, that was then something that I'm not understanding here, because if you only look at the first occurrence of the entities, how do you deal with the occurrence of entities that are in later paragraphs, in later passages of the same Wikipedia page?
Okay, so the entity links that we have come from passages of pages, and not all entities are always linked because of like the editorial policies. So now what we are doing, we're not just looking at the first one, we are retrieving passages, then we inspect passages, and these passages can come from multiple pages, by the way. So we inspect these passages.
And then those passages, you run an entity linker?
No, we just use the entity links that were provided by the Wikipedia editors, because all of our passages come from Wikipedia.
And if a passage has the entity, but the editors did not include the link,
then we don't have it.
Then you have low recall. That's
yeah. So I mean, it lowers the recall, but we're not losing that much in terms of recall. Like this is what Pooja tried to say earlier. Like when she used the what entity linker to maybe pencil in more entity links, she didn't really see that much of a performance improvement.
Yeah, that's the point that we also observed, that it doesn't really matter if we tune the linker for high precision or high recall. Results didn't move that much when we tuned for high precision or for high recall. So
right, I think the confidence value of the entity linkers, it's you know, it is not really designed to really give you a confidence. It's really just a classification score on which you choose a cutoff. And the lower cutoff doesn't mean that you get better entities, right? I think what Pooja was talking about is like combining entity links that are provided by Wikipedia editors manually, and those that we find by feeding the same paragraph through the what entity linker, like adding the what entity links over our high quality but possibly missing entities. It did not really provide a lot of information. And I think the problem is that especially entities that of like, you know, not so popular types, what is just like miserably failing on them. What finds you people, location, organizations, a few other things that are pretty blatantly glaring in the text, but any of your complicated entities that maybe are like multi-word expressions that an NER detector wouldn't find, it will also not really identify, I don't think.
I posted a link about a dataset repository. Maybe it's interesting. I'm not sure if you know it. So T-Rex, it performs an entity alignment against between Wikipedia articles and Wikidata, but there are the issues you already have talked about. So quality is at some points good, like for persons, but more complex entities are not linked well. But I like this data set because you can play around with many different things there, and this is a good starting point.
Thank you for sharing.
Okay, I think we had a great discussion. I would leave to the workshop coordinators to decide if we pass on to the closing or we continue with some more discussing, because it's going on interesting. But Ricardo, up to you. And thank you to the presenters and all the participants in the discussion.
Thank you, Sergio, and Laura and Posa. Also, João, for doing so many great questions, and Herman. We know that for some of you, you're just beginning the day, especially those coming from US. However, here in Europe, we are moving towards the end of the day. It's been a very interesting session, and I should say that we had more than 120 attendees according to the app. So moving towards the end, we now have the awards session. I'm going to try to share here the screen. Just give me 1 second. I think it's this one. Okay, so we are going to start by, as I as I mentioned in the beginning of the day, our day, we have a certificate award for the reviewers, which is an important task that we consider, and it's not often value within the communities. We have 3 awards to the reviewers. I don't know if Brenda Santana is here at the in this Zoom session. Brenda, are you there? Because Brenda is.
Yes, I'm here.
Okay, I'm thinking that you're speaking from Brazil, correct?
Yes, correct.
Okay, nice to hear you, Brenda. So, as you can see here in the screen, you were one of the awarded for your great contributions to the workshop with your reviews. Thank you for that. Okay.
Oh, thank you very much.
Okay, thank you, Brenda. We have 2 more awards in terms of reviewing. So the next one for the 2nd year in a row, it's also here. It's to Bruno Martins. Bruno, you're still there?
Yeah, still here.
Okay,
well,
okay.
thank you. Thanks a lot.
Okay, we really appreciate your very informative reviews, and thanks for the great contributions to the community. And the 3rd one, I don't know if Dia is here from Florida International University. Dia, are you here? I guess not. Okay. So to conclude the session, we are going to present the best paper award, and the best paper award goes to Regina Ketibon and Honor Savas with the work A Different Story: How Conservative Narratives Diverge Between Twitter and Parler. Regina, are you there? And I think you're still there on the session. Or not here. Probably she has gone already and missed the part. And in that case, I'm going to do like Mark did some minutes ago, 1, 2, 3, and we are going to deliver this award to another researcher. No, so I guess Regina is not here with us. So in that case, we should conclude this session right on schedule, without coffee breaks, and we just a short break for lunch. It was a great and interesting session. We would like to thank all the attendees, which were a lot during all day, for the interesting questions they posed on the QA, and also our keynote speakers and session chairs for their amazing work and for making this possible. And obviously, I would like to thank my colleagues for the amazing work. Mark, who is not here. Sumit, I think he's not here any longer. And Alipio. Oh, great, Sumit. So join us again. Join us. And Alipio and Adam. Oh, and Mark is also here again. So you were able to return back to the last part of the session. So I will hand over now to my colleagues to say a final words. Alipio, Mark, Sumit, and Adam. So to you now, guys. Thank you. Alipio or Adam or Mark.
Just like to thank everyone like you did. So thank you very much. It's been a great workshop with great talks, great participation, great level of participation. And thank you, Ricardo. You didn't thank yourself. So thank you very much for pushing this. You've been leading the effort for organizing this workshop, and it's great work. Thank you.
Thank you.
Yes, I just want to second that, Ricardo. Great work on your leadership.
Great background, great background. Adam, some final words in Sumit, and then we should.
Yes, thank you all for the attendance. And I have to say, I was not sure how many people will submit papers and attend, because we had in January similar workshop. It was AI for narratives at ICHCAI conference, so very close time-wise to today's workshop. But we still had a lot of people attending, over, I would say, 35, 40 on average, often more than 40, close to 50 even. So I'm very happy, and also the discussions, I think, were very exciting, and I feel like we could continue quite much longer than now, but of course we have to finish. So hopefully to see you all next year at the edition of this workshop. Thank you.
Indeed, that's a great remark. As Adam said at the beginning of the morning, our morning, we were yesterday sharing some sessions, and we didn't have these numbers, these figures. So it was great to see that we on average had approximately 50 people. And now it's up to you, Sumit. Are you there, Sumit? Probably you are not as a panelist anymore. Sumit, are you there? You just raised your hand. Okay, you are on the side of the participants. Or, I don't know why. Okay, Sumit, I'm going to promote you to panelist. Here you are. You can now say the final words, Sumit.
Hey, sorry, it seems as you changed my role, I was locked out, but I think you can hear me now, right?
We can.
Okay, great. Yeah, so thank you all, and especially Ricardo, for making sure that this great workshop happens every year, and looking forward to many more years. And hopefully next year we'll all be meeting personally and face to face and having a lot more discussions. That's one aspect that I kind of miss, especially because it's close to 10 p.m. here. So that's what I'm missing. But yeah, thank you all for the participation and submitting all the great work, and looking forward to meet you guys next year also.
Okay, so great to see you guys, although virtually. We expect, I think everybody expect to meet in the near future physically in ACIR and the other similar conference, so that we can return back to our life. That's what everybody expects right at this moment. Stay safe, and thanks, and we expect your contributions obviously to the 5th Text2Story workshop, which for sure will happen next year. Thank you, guys.
Thank you so much.
Thank you.
Bye-bye, everyone.
Bye-bye.
Thank you.
Bye, everyone, and
Thank
stay
you.
safe.
Bye.
Goodbye.
Thank you, guys. Bye.
Bye-bye.